Hi, good morning, everyone. Let's get started with our next topic, which is on Introduction to CC Linux Enterprise Server. And in this topic, we will see a couple of things about CC Linux. Mainly, we'll cover the introduction. I will cover what is CC Linux knowledge domains, and we'll talk about YAST in brief. Okay, so let's get started with the key knowledge areas or knowledge domains of a SUSE Linux environment. So if we look at the different knowledge domains in SUSE Linux, so they are organized in this format. So there is software, there is storage, okay, then there is network. So these are some of the key areas that we are describing. Then we will be covering them in detail in each of our topics. Then we have users and permissions, about the file system. We'll talk about the system integration. Okay, so these are the core areas. Okay, then you have something called the broader layer of it is you will be performing an installations. Okay, so we will talk about the installation, that is how to download and install SUSE Linux. Okay, we'll talk about the hardware and the device drivers. Talk about process administration, shell concepts. Okay, and we will be looking at how we can monitor and administer. So we will talk about the administration aspect and the monitoring aspect, and we'll be covering shell scripts briefly. Okay, so these are the different knowledge areas that we will be covering in our trainings for SUSE Linux. Okay, so just to summarize, we will be looking into the installations, that is how to download and install a SUSE Linux hardware. Then we will see how we can manage and configure hardware and the device drivers. We'll see the different processes, how the process administration is done. Okay, the type of processes. We'll see the different shells, what is a shell and why we use different shells to manage and administer the environments. Then we will be looking at the administration and monitoring aspect of SUSE Linux, that is how we can monitor it, how we can administer it, how we can perform day-to-day administration work of it. Okay, we'll be looking into the different shell types, okay, like Bourne shell, corn shell, C shell, etc. So we will be looking at the different shells. Okay, and internally we will talk about the storage administration, the RPM packages. We'll look into how we can manage storage. We'll look at the different network commands, that is how we can check whether the system is up and running, how we can check whether your network is responding or not, how we can check the network traffic, how we can configure the IP address at network level. Okay, then we'll be looking at the different permissions, the file permissions, the directory permissions. We'll be seeing how to manage and administer the users in a Linux environment. We'll see the different file systems, how to check the space in the file systems, how to check whether file system is working fine and the file system integrity check is fine. Then we'll be looking at the system interaction, basically the interfaces, that is how this system can connect to other systems. We'll be covering briefly about some of the security aspects as well. So this is what we will be covering in our Linux training over the course of few days. That's all I wanted to cover. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of downloading the media. So we will cover about how and from where you can download the CD for your SUSE Linux. Okay, for the OpenSUSE. So to download the OpenSUSE CD, what you can do is you can go to this particular website called software dot opensusi.org, and to start with it is an HTTP website. Okay, so you can go there and download the CD or the DVD. So basically it will look something like this. Okay, so just go to this URL software.opensusi.org and it will take you to this page, and from here you can download directly, depending on whether it is 32-bit PC or 64-bit PC. You can download the respective DVD. Okay, so apart from that you can download couple of other things, like you can download the Genome desktop and download KDE desktop, you can download Rescue System. Okay, so these are other things that you can download, but to try and test or to go through this training, you can just download the DVD and you can download say Genome and OpenSUSE derivative. Okay, so this is pretty much that is required. Okay, so that's all in the download part, and we will look into the different type of SUSEs in the next topic, that is what is OpenSUSE, because this is not a SUSE Linux, this is an OpenSUSE, and how and these two things are interrelated, that is what is the interrelationship between these two components called OpenSUSE and SUSE Linux. Okay, that's all for this topic, and let's look into this reference in our next topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, where we'll talk about the different flavors of SUSE Linux. Okay, so we will cover the different flavors for SUSE Linux, that is the different types, different varieties of SUSE Linux. So the two main varieties that we'll see is the Open SUSE, which is an open source, and SUSE Linux Enterprise. This is also an open source, but we will see that under what circumstances or for what type of products we'll go with SUSE Linux Enterprise Edition, and for what type of systems we go for OpenSUSE. So in short, actually the reason why people go for OpenSUSE is people who wants to try multiple things, people who wants to test out multiple things very fast. So those type of people, they go for OpenSUSE. So it's basically it's a free open source and is an alternative to Microsoft Windows with many advantages. OpenSUSE, this is suitable for desktops, for notebooks, for servers, multimedia PC at home or in small office. Okay, this is one of the very old flavors of Linux, and the new versions of Linux, they are released almost every 8 to 10 months, and they support many different languages. Okay, OpenSUSE is developed by a community volunteering to work together with SUSE employees, and it forms the base for enterprise products. So that's why we see different revisions very fast in this. Okay, the revisions, they are released much faster than what you will see in the enterprise SUSE. Okay, so when do we go for OpenSUSE? When we look into things like bleeding edge technology. Okay, so that means the technology is just released, it is not yet matured. So that is where we try or start using the OpenSUSE, where the changes are fast moving, they are released very fast. Okay, so fast moving data target. Okay, next thing is about the lifespan is pretty short, that is 18 month of support cycle. Okay, and this mainly looks at the enthusiastic users who want to try out new things as and when it is released. Okay, so this is about the open SUSE, and there are different versions for it. The current version is OpenSUSE 11.3. Then we have 11.2, 11.1, and 11.0. So these are the different versions of SUSE which is available. Okay, now let's look into the another flavor that we talked about is the SUSE Linux Enterprise. Okay, SUSE Linux Enterprise, this uses the SLE common code base, and this is derived from X.1 release of SUSE. Okay, so basically this is a more matured version of it. So at the top you will see that if you see this is your enterprise SUSE, at the bottom you will find SUSE Linux Enterprise common code base, and this also comes in two different flavors. One is the server flavor, another is the desktop. Okay, then you have the SDK, that is software development kit. So you can see that the different flavors for SUSE is SUSE Linux Enterprise Desktop, SUSE Linux Enterprise Server. So this comes in these two flavors, and this also contains an SDK built on the same code base. Okay, this being an operating system, this requires some, see, as and when the security patches are released, as and when the updates need to be done. So as far as the support life span for this is concerned, this is 7 to 10 years. Okay, and the development cycle is also pretty long for this. But there are periodic service packs which are released, let's say, every 1 to 1.5 years. Okay, and so this is about the SUSE Linux Enterprise Edition. And as we have seen in the Enterprise Edition, there is a desktop edition, there is a server edition. We have seen its maintenance cycle, that is how fast those newer versions are released. And okay, so that is pretty much about the SUSE Linux flavors. Okay, that's all I wanted to cover in this particular topic. Thank you for joining and have a nice day. Bye bye. Hi, good morning, everyone. Welcome to this topic of why we need or why we should go for SUSE Linux, or in general the Linux based operating system, the GNU Linux. Okay, so let's look at it. So today's topic is why Linux. Okay, there are various advantages of going for Linux. Most of the people, they go for one of these benefits. The first and the foremost benefit is security. Okay, so why security? Because we don't see the viruses here, we don't see the spywares, and these are actually non-existent issues. Whereas in some of the environment, we see there is a lot of viruses, lot of patching being on going on because of virus, lot of spyware introduced. So this is one major benefit that I wanted to let you guys know. Second main benefit is the maintenance. Okay, so from maintenance perspective, what all the benefits we get in maintenance is we don't have to perform the virus scans, we don't have to perform the spyware checks, we don't have to defragment the disk, we don't have to clean the registry, we don't have to reboot the system frequently. So from the maintenance perspective, these are some of the benefits that you get once you get into the Linux based operating system. Okay, there is another benefit is the stability. Okay, this product is pretty stable. So individual apps might crash, but the operating system itself crashing is very rare. Okay, then let's get into the next item, which is about the fact that, as you guys know, that this is an open source. Open source means you may run the software as you wish, study the source code, modify it, share it, and there are no tricky end user agreements. Okay, then about the Linux community, as you guys know, it's being an open source, so anyone can modify, anyone can make changes to it. And finally, the economy of it is that this is much cheaper than the other operating systems. Okay, so these are some of the benefits what you get when you get into a Linux based operating system. There are few more benefits like transparency. So most of the Linux distributions are developed in open source using different public channels, different bug trackers, different public feature trackers, etc. So there is a transparency on what is there in the code. Okay, so that is pretty much about this particular topic, that is why we need Linux. Why Linux is a preferable operating system. Okay, why more and more people are switching to the Linux based operating system. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic where we'll see the basic commands in a Linux system. So let's say if I want to show or read something or throw some message out of it. Let's say if I want to say, hello, how are you? Okay, so if I want to say this message, I will type like this echo, and then whatever I want, I can just put it there. So it will be like this. So this is your command here. So let's execute this first so that you get an idea about the output. So here you can see that this is your command. Let's say that echo good morning Raj and double quotes close. So you can see that I need to start with a double quote and I need to end in a double quote, and you can see the, let's say, take one more example that so the command is echo put double quotes, and in that command you can mention that today is the final match for FIFA World Cup 2014. And if you just press enter, you will see the message how it comes. So basically, whatever you want to see or show, you can just write this command echo and put the two double quotes, starting quote, ending quote, and just put whatever you want in that. So let's see this. This is your command here. Okay, so let's note down this command here first. So this is your command, and this is the command name. Okay, in this command you can see that there is one starting code, there is one ending code, and whatever you want to write or show, you can just put within this. So whatever, anything can be written here. So just to recap this command, echo double quote and just write whatever you want to give message, and that's it, press enter. So this is the first command that I wanted to share with you is echo, means it will echo the message on the output. Okay, so that is about the echoing of message. Then let's say that when you are working on a system, there is one command called clear command. Okay, so you might be knowing that in Windows you have the CLS command, but in Unix it is clear command. So whatever is there on the screen, you will see that there is a, it is cleared from here. You have so much of lines there, and the moment you type CLEAR clear, you will get a blank screen. Okay, so that is about the clear command. Then now let's say that you have logged into the system and you are not sure what is your ID. So you can type a command called who am I. Okay, so what this command will do is it will give you the information about your user ID. Okay, so what user ID you have logged in, it will provide this information. Okay, so this is the your user ID with which you logged in. Okay, there is other variant for this command is, let's say, who. So this will tell the information about the details like what is your user ID, what is your terminal, from which system you are connected. So all that information will be seen here. Okay, so that is about the who command. Then let's say that while working on a system, you are not sure in which time zone you are in or what is the current time. Then what you can do is you can type this command called date command, and this command will give you the information about what is today's date. You can see this format. There is a way to change this. I won't share it in this basic commands training, but we will be seeing in our subsequent training how we can tweak this date in different formats that we want. Okay, so that is about the date command. Then there is one extremely important command is, let's say that you are working on a system and you want to see how to use a particular command, and this is going to be a very important command, because whether you are a newbie, whether you are a beginner, whether you are an expert, there are times when you need to see the syntax, whether you need to see the different options available in a command. So let's see the options which is available in, say, the date command. Okay, so we type like this. Man means we want to see the manual page, and the command name for which you want to see the manual page. Okay, so just type enter man date, then enter, and you will see that information about the what is this, what this command will do, what all the different options that can be used with this command, and different formats. Okay, you can see these are the different options. There could be chances you will see some of the examples of how to use this command. Okay, so that helps for people who want to explore the different options to see how better I can use this particular command. Okay, so that's where I will stop for now. So just to recap what we have done, we have seen the command called an echo command. Okay, then we have seen the command that is, so first command that we have seen is echo command. So this command is for throwing the output on your terminal on your screen. Okay, let's go back. The other command that we have seen is the clear command. Okay, so the clear command is used for, this is the command for clearing your screen. Then we have seen a command called who am I. This is a single word. It will tell with which user you have logged in into the system. We have seen a command called who command. This will tell information about what is your user ID, what is your terminal ID. Okay, then we have seen a command called a date command. Take note that Unix or Linux, anything, they are case sensitive. So if you use any of the letters in capital, this command will not work. So that is extremely important whenever you are working on a Linux or a Unix based environment. They are case sensitive. Okay, so the next command that we have seen is the man command. So this stands for the manual page for a particular command. So that is pretty much I wanted to touch base on this basic commands topic. We will be seeing a lot of commands because Unix is full of commands, and we will see them how to use them and how we can practice them and master them. Okay, for now we will stop here. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of directories. In this topic, we are going to see how we can create a directory, how we can change to a particular directory, how we can remove a directory. Okay, so let's get started with this. The command to create a folder is mkdir. Okay, so let's say that I am in this folder and I want to create a folder called training. Okay, so if I just type ls training, you can see that there are no files present in this, and you can use this option ls-ld to list this. This shows that this is a directory starting with D. Okay, so now we have created a directory using this command called training command, using this mkdir command. Let's say that I want to create one more directory called test. Okay, and if I do ls-ld test, you can see that there is another folder which is created here. So we create a folder using this command called mkdir command. Okay, let's change it into this particular folder. So let's get into this folder. So how do we get into a particular folder? We type this command called cd, that is change directory space the directory name. Okay, so we get into this directory. How do we know if we are in this directory? We type this command called pwd, which stands for present working directory. So pwd, if you press enter, it will tell that you are in this folder. Okay, now in this folder, let's see one very important thing is if you type ls-al in this folder, which you have just created, you can see there are two directories which is present by default. So first directory is dot, which means present working directory. The other directory dot dot, that means it's parent directory. So let's say if I am in this folder, what is my current folder? It's slash training. What is my parent folder? It is slash. Okay, so if I type cd dot and check the directory, I am in this. But if I type cd dot dot and type check the directory, I am in the parent folder. So that is about these two directories, that is dot current directory dot dot the parent directory. Okay, so we have seen how to create a directory, how to change into that directory, how to check we are in which directory, okay, and how to see the hidden files and folders. Okay, now let's see a command called delete a folder. How do we delete a folder? So for deleting a folder, we use the command called rmdir command. Okay, so if I type this command rmdir, that means remove the directory. So let's try to remove the directory that we created. Okay, so this is the command name rmdir. and which folder we want to remove here. Okay, so just press enter, and if you type ls-ld training now, you will see this message, which means no such file or folder or directory. That means that this does not exist anymore. Okay, so this is how we use the commands for the directory. So just to recap, what we have done so far is we have created a directory using mkdir command. We have changed to that directory using this command called cd command. Okay, we have checked which present working directory we are in using this command called pwd command, and we have seen how to remove a directory. So this is how we manage the directories in a Linux system. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye-bye. Hi, good morning everyone. Let's get started with our next topic, which is listing of files. So in this topic, we are going to see how we can list a file. That is, how we can see how many files are present in a folder. So we use a command called the ls command. Okay, so this is the command name, and when we type this command, you will see the list of all the files which is present in this folder. Okay, so that is ls, that is list the command files in the current directory. So wherever you go, let's say if I go to this folder /tmp, and if I do an ls here, you will see all the files in this folder, which is /tmp folder. Okay, so if I just type cd and do ls, it will show me files in this folder. Okay, take note that if you change the folder, the number of files, type of files will change, because ls lists the files in that particular folder. Okay, there are a lot of variants or options which can be used in ls. So to start with, we use the command without any options. Okay, we can use it with wildcards, we can use it with various other options. So the most common and important option is -l. This will give you the long listing of files in this folder. Okay, so you can see that it will show all the files, and you may need to scroll up if the number of files are more than what you can see on screen. Okay, so that is about the long listing, -l option. This is the option. Why it is called long listing? Because if you see the file name is this or directory name is this, okay, but it is showing all the attributes of a file. What is the permission, who is the owner, which group it falls, what is the size, when it is last modified. Okay, so all that information is seen in the command called ls-l. Now let's look at one very important option in ls, which is ls-al. So the A stand for the hidden files. So if you have a lot of hidden files in your environment, this will show all the hidden files. Okay, so this will show you the list of all the hidden files. some of the very important hidden files, if you see, is dot and dot dot. So they are the dot stand for the current folder. Okay, dot dot stand for the parent folder. How do we know? Let's check that part. So if you type pwd, you will see this. Now if you type cd dot and type pwd, you will remain in the current folder only. But if you type cd dot dot and type pwd, it will take you to one folder below it. So this is your folder in which you are in, and it will take you to this folder. Okay, so that is about the dot and dot dot file types. Okay, so then there is one more option that I wanted you guys to know is ls minus I. I stand for the inode. We will see what is an inode, but here you can see the inode number of a file. So this inode number is unique in the system. Okay, so this is an inode. Okay, how do we write this is inode. Okay, so each file has a unique inode, and you can see that this particular folder, that is var folder, which has a inode number of, this is the inode number for it. So like that, these are the different options which can be used in ls. Okay, so that is pretty much I wanted to cover in this particular topic. So just to recap what we have done, we have covered the command called ls without an option, ls minus l with long listing, ls minus a stand for hidden files, ls minus I stand for inodes, and we can combine these options as well that we have seen. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic where we'll talk about the file system. And in the file system, we'll be focusing mainly on the file types. So in the file types, if you see the file types, there are actually 7 different types of file in Linux. So first thing is the regular file. So let's look at what is a regular file. Regular file. Okay, so let's see how we can find out whether a file is a regular file or not. Okay, so let's get into the system straight away. And in the system, you can see, let's say that these are the files that is there. And in this particular character, the first letter, it tells about the type of the file. Okay, so this is the letter, and if you just, you can see this is a directory. Okay, if you go to this folder, you can see that this is a directory. Okay, let's say if you go to this folder, you can see this type. This is a symbolic link. Okay, so the first letter that you are seeing here, this is a directory here, D, starting with D. Okay, this is a symbolic link starting with L. Okay, and if you go to this folder, say, let's say I go to this folder. Okay, so you can see this is a regular file. This means that it is a file starting with dash. Okay, this is your symbolic link. This is a directory. So just focus on first character here, and that character tells what it is. Okay, so based on what, based on the first character, you can tell whether it is a regular file, it is a directory. And let's go to this folder called /dev. Okay, can you see here some different thing that is C, starting with C, that is a character. Okay, so this is a character device file. And let's look at something which is not starting with C, that is character file. You can see there is something called starting with B, the block device file. Okay, so you can see the different file types here. Okay, so let's look at the other ones, which is starting with S. You can see that this file name is starting with S. So S in this stand for socket, that is local domain socket. Then there is one more file type, if you note, which is starting with P, which means it's a named pipe. Okay, so just to recap what we have seen, what all the file types we have seen a regular file. Okay, so how do we identify it is a regular file? You'll find starting with dash. Okay, second thing is the directory. So this is the second file type, which is directory. Take note that directory is also a file type, and you will find it starting with letter D. Okay, then the next one that we have seen is the symbolic link. Okay, symbolic link means starting with L. Okay, so this is the third file type that we have seen. Now the next one is that we have seen is a character device file. So you will find them under the device folder, and they are starting with letter C, character files. Okay, then we have seen block device file. Okay, starting with letter B. Okay, then there are other file types that we have seen is the socket. Okay, so the socket file type starting with letter S. Okay, and there is one more file types that we have seen here is starting with letter P, that is a pipe. Okay, so we will be using them in our training. So this is our number 7, that is pipe. So this means starting with letter P. So these are the file types that we have seen, and you can see device files. So these two that we have seen, these two are the device files. This is your socket and pipe. Okay, then this is your link, symbolic link, directory and file. So now let's see how we can create and delete these file types. So directory, how do we create a directory? We can create a directory using the command called mkdir. And how we remove a directory? We can remove it using rmdir. Okay, how do we create a file? So we can use a vi editor, we can use any other editor. Okay, or we can create using copy command also, and to delete a file we just use rm command. Then the symbolic link. So the links, how do we create a link? We create a link using ln-s command. Okay, and we delete like any other normal file, rm and then the name of the link. Okay, then for the block and the character files, we use the command called mknode. Okay, and deletion for all of them is rm only, except for the directory. Then for the socket and pipe, for socket we use the command called socket, and for pipe we use mknode. Okay, so this is how we create these file types. Okay, so let's go back here one more time. If you see, let's go to this folder called /tmp folder, and if you see a file type, this is your directory starting with D. And if you create a file, let's say I want to create a file called using vi test. Okay, go to the insert mode, type something and just save it. And if you do ls-l test, you can see there is a file created. Okay, and to remove the files, the command is rm test. So this is how we create a file. Now in this case, if you see, I use the command called rm. Okay, now let's create one more file called, say, test file again. And if you just do ls-l test, this has read write permission. Okay, if I just make the permission as just read permission. Okay, and now if I try to delete this file, you can see I can delete using rm command. Okay, there is one more option in rm, which is rm-i. Okay, so let's create this test file one more time, and if I type rm-i test, you can see that it is prompting that do you want to remove it, that is, it is asking for confirmation, and if you press yes, then only it gets removed. So this is one of the variant for interactiveness. Okay, so let's look at the regular files first. So in the regular file, so first file that we have seen is a regular file. Regular file, we can call it as a normal file or just file. And if you see this normal file, it could be a text file like an ASCII file. It could be a executable, that is any executable. It could be a library, so it could be a library file. Okay, so these all fall under regular file. So for a regular file, you can have a sequential access, that is, you can access them in a sequential manner, or you can access in a random manner also. Okay, so that is on the regular file. The second file type that we have seen is a directory. So before we get into directory, I want to show you one of the very important special regular file. So here you can see, if I just type ls minus l k, and if I just scroll up a little bit, so for any file, any directory that you see, okay, so if you see any directory, any folder, you will find these two files. So which are these two files? Dot and dot dot. So these are two important files. So dot refers to the current folder. Dot dot refers to the parent folder, parent directory. So any file you take it, you will find these two files. Okay, so that's why if you can use this command cd dot. So if you do pw, means it's current folder. You type cd dot dot like this or like this, so you can see that it takes you one step to the root folder. So that is one very important thing to take note of, that is dot and dot dot. Okay, next thing is about the directories. So if you see directories under slash, you can see that these directories are to organize the files. Okay, so under directories, like at the root file system, you can have these subdirectories or files in an organized manner, and it can be in the hierarchical file system. Okay, so that is about the normal or the regular files and directories. Next thing is about the links. Okay, so in the links, there are actually two types of link. One is called the soft link or symbolic link, and another is called the hard link. Okay, so where we can find these symbolic links, so let me show you that information. Okay, so symbolic links, you will see them in mainly in the, say, lib folder. So if we go to this folder, you can see these are symbolic links. Okay, so these are the symbolic links. Hard links, so two types of symbolic links, hard links and okay, so next file types, directory we have seen. Okay, in that dot and dot dot file types we have seen. Then next type that we are talking right now is on the links. So in the links, two types, hard links and symbolic links. So symbolic links, we also call it as soft links. Okay, so how do we find out which is a soft link, which is a hard link, why we use them? Okay, so let's look at this. This is your link. Okay, so hard links, they are actually secondary file names for files on the disk. So multiple file names may be referring to a single inode. So for hard link, take note of one thing, that they should remain in the same file system. Okay, next is on the symbolic link. So symbolic link, they refer to other files on the disk, and the reference file can exist in the same file system or in another file system. So just take note of the two differences between the hard link and the symbolic link. Okay, then let's look at another device file type which we have seen is about the character and block files. So these character files and the block files, they are the device files. Okay, character and block file types. So these two go together because both are the device file types. So as we have seen that if we go to a device folder, so where is the device folder? You can see that under slash, if you do ls, you have all these devices are present in this folder. So this is your device folder, and if you do ll, and you will find all the device types listed here. Okay, so device file, actually these device files let programs communicate with system hardware, peripherals. Okay, so any hardware you take it will be represented by a device file, except network cards, which are actually just the interfaces. So these files are the link between hardware devices and the kernel drivers. Okay, device files actually are created automatically by the OS when the device is discovered by the kernel. And let's look at a little bit more about the device type, and let's look at something that we have covered, which is on these links. So we have not yet seen how do we create a hard link and how do we create a symbolic link. Okay, so that is one topic. Let's cover that in our next training topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this training topic of chown. This is a command to change the ownership. So how do we change the ownership? We use the command called chown, that is change the ownership. We can change the ownership of an existing file using this command chown, and here we give the chown the new owner or the username, and then so this is your username and this is your file name or directory name. Okay, so that is one variant of it. Second variant is that we can do chown username colon group name and then file or directory. Okay, so this is your username and this is your group name, and this is the file and file or directory. Okay, this could be a single file or multiple files or multiple directories. Okay, so that is one variant of it. Another variant is that I want you guys to take note is a recursive ownership change. So chown then minus capital R. So this will make sure that any directories, subdirectories, and within subdirectories, if there are any directories, everything gets changed from that point onwards. So this is your username or new username or new group name. Either of them we can specify, and this is your the directory name or okay. So these are the four different major variants of chown command. So let's look at this command in the system. So let's go to this folder. Okay, now here you can see that the ownership for this file is root. Okay, so let's check if there is a user called by name test from password file. You can see that yes, there is this particular user, and what I am going to do now is I am going to change the permission for this file. Current owner is root. Okay, so I am going to make the new owner called test4 here and chown the new owner name, which is test4, and this is your file name. Okay, so now if I look at this file now, let's see what is the ownership for this file. Take note that this is the owner, and this ownership has changed from the root user to the test4 user. Okay, so this is how we change the ownership. Let's say that I want to change this group also. Okay, so for changing a group, there is a command called chgrp, and we can change the owner from this to, let's say, staff for this file. Okay, you can see that if there is no such group in the system, you will get this message. Let's confirm that. Okay, how can we confirm that? We can grep this group from the group file. So there is nothing called this user. So what we are going to do is let's select an existing group from this. So let's say that I want to change the group to SAP sys. Okay, so and you can see that the group ownership has changed. There is no error message. Now let's see the permission of this file again. You can see that the group permission is changed to SAP sys. So this is how we change the ownership, and that is the owner and the group, we change it this way. There is one more variant that we have discussed. It's chown user colon group name. Okay, for let's say I want to change it for this file. So I am changing user and group at one shot. So let's see this, the value for this. You can see that the user is test4 and group is this, and both are changed at one shot. Okay, now let's look at this directory. There is one directory here which is bin folder, test folder. Okay, so there are no files. So what I'll do is let me go to test folder and create some file called, let's say this is first file, this is, let's say, second file, and if you do ll, you can see there are two files in test folder and both are owned by root. And if I do ls-ld for test, this is also owned by root. So if I want to change all these permissions at one shot, I can say chown -r command. And if I want to change just the owner, I can say test4 and this folder. And if you do ls-lr for the test folder, you can see that everything is changed to test, even the files inside this folder and this folder permission also. Okay, and we could have tried the same thing for the user colon group. Let's say that I want to change this to say test3 user and group is say SAP sys for the test folder. And okay, test3 user is not there, so let's select some existing user from the password file. Okay, now here you can see that let's pick up test5. So if I change the ownership recursively to test5 colon SAP sys for the test folder, you can see if I do ls-lr for the test folder, can see both ownership and group permissions are changed at one shot using this recursive command. Okay, so this is how we use chown and chgroup command. So that's all I wanted to cover in this topic. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of symbolic links and hard links in a Linux system. In this topic, we are going to see how do we create a hard link, how do we create a symbolic link, and what are the key differences which we need to take note of or need to be aware of. So let's create a hard link first. Okay, so to start with, let's assume that there is a file by this name. Okay, so let's say the file name is say yesterday. Okay, so this is a file that is present in the system. Now I am asked to create a symbolic link and a hard link to this file. Okay, so to start with, let's create a symbolic link. So to create a symbolic link, the command is ln, that is link, minus s. S stands for the symbolic link. Okay, so in this case, what we need to do is we need to specify here which file I am referring to. Okay, and the link name that I am creating is, let's say, link for symbolic. Okay, so if you do ll here, you can see that this is a symbolic link. Okay, let's use this command to see the difference between the two. You can see that this is a file which is present in the system and this is a file we have created it. Okay, so you can see that the difference between the two is this value. So this value is different here and this value stands for inodes. Okay, so the inodes are different in both the cases for a symbolic link. Okay, let's create one more link called hard link. Okay, the command to create hard link is ln and then the file name and we are creating a hard link for, say, yesterday. Okay, and just see the difference. Okay, so we have created this. This is a hard link, and if I see using this command, you can take note of the difference in the inode numbers. Okay, so this inode number is same as this inode. So inode number is same for a hard link that we create, and inode number is different for a soft link or a symbolic link that we create. Okay, so this is one major difference between the two. Okay, so where do we use them? Let's take an example of the existing use in the system. So let's say if I go to this folder called lib folder, you can see there are a lot of links here. You can see that these are the symbolic links that are present in the system. Okay, what is the other use of symbolic link? Let's say you are running out of space and there is a space in other partition. So you can create a symbolic link and use, you can keep those files in the other file system, and this link will just point out to that particular file system so that your file structure doesn't get impacted, and you can add this as a file system. So that is one use of symbolic link. Okay, so during installations you will see there are a lot of symbolic links, and one major area is for the libraries, for the device driver, for the kernel. So system itself uses a lot of these symbolic links, and as a user defined links we create them when we run out of space in a particular file system. Okay, so let's say that I am in this particular file system. Okay, and you can say that this is on slash. Let's say the slash is, say, 9, it becomes 100%. I need to move this file system into some other new disk that I have added. Okay, so let's say I want to move this into this location, this ITG. So what I'm going to do, I am going to create a symbolic link. Okay, so the actual data will lie here and the link will be pointing from this place. So how do we exactly do that? Let me show you. Okay, so let's say that there is a directory. We create a new directory called this, and we move everything from this folder to this folder. Okay, and we just come out of this folder, remove this directory, and we will create a symbolic link from this location, and this is your symbolic link. Okay, so if you do ll/itg, you can see that this is a symbolic link and it is pointing to this location. Okay, and if you do ls-li for itg, you can see that this is the inode number for this, and if you do symbolic link for this folder, you can see both the numbers are different in this case. Okay, so let me show you them. Okay, so this is 11264 and this is 11265. Hi, good morning everyone. Let's get started with some of the interesting features of bash shell, and let's see how it makes this particular shell very powerful. And these are the features which is helpful to increase your productivity as well. So let's look into those features. So to scroll up and down the arrow keys. Okay, so how do you scroll with the up and down arrow keys? So as you can see that when you press enter command, you can go to the next line. Okay, and if you just press the up arrow, the down arrow, okay, you can see that the previous commands get scrolled. Okay, so this is how you can scroll the commands, the history commands which is there in your history, to find that out. So that is one thing that I wanted to let you guys know. Another thing is about the control P. And let's say if I press control P, you can see that the same thing, the scrolling I can see from here, and control N as well. So you can see the scrolling that you were seeing from up arrow and down arrow using control P and control N commands. Okay, then next thing is there is something called history commands that you should know. Okay, history is, it will show you the previous commands that you have executed. Okay, say if you say history 10, so it will show the 10 previous commands that you executed. Okay, and one thing to take note is that you can just run using, let's say if I run history, and if I want to execute this particular command, let's say this command, so I can just type exclamation and 980. So it will execute this particular command. And if I want to repeat that command, I can just type 2 exclamation marks. So I can rerun that particular command again. Okay, then there is something called search in the history. So how do we do that? There is something called control R. Okay, you can see reverse search. So if I search for something called, say, VI, you can see that I will get the VI, different VI commands. Okay, if I just say, okay, so it depends on what you are searching, you will get that information there. Okay, then there is something called, let's close this. You can convert your editor, the command line, into a VI editor itself using this command set-ovi. Okay, and then you can use these keys. Let's say if you type ls and something and type escape, then you can just say, you can scroll using these keys, that is H, J, K, L keys that we saw for moving left, right, up and down. Okay, so you can scroll using these keys. Okay, then so that is about the VI editor command. And there is one more very important thing that I would like to know you guys is the repetition of the command. See, let's say if I am searching for a previous command. Okay, so let's say if I just search this, press escape, and you can see that VI, then next VI. Okay, so it will show me different VI commands. So the way it works is that, say, let's say that if I type something called, let's say, escape and /ls, or let's say escape, say type escape and say /ls. Yeah, it can take me to the previous commands. Okay, so let's say escape, say vi. So if I type, let's say, escape vi there, so basically what I am trying to show you guys is that you can search within this. So you just press, let's say, you are typing something, okay, and you decide that you want to search something, let's say /vi, and just press enter. It will show you the next commands, and then you can see hjkl in the vi editor. Okay, so let's say anything starting with clear, so /cl, just press enter and you will get that. So this is how we can run the previous command starting with a particular character. Okay, so that is about this particular topic. There is one more thing that I think you guys know pretty well is, let's say if I type ls-l and let's say desktop, so ls des and just type tab, and this will complete this command. Okay, so this is how you can complete the different commands here. So if I type, let's say, lstr and type tab, so there is more than one. Okay, so if it is one thing, it will tell you. Okay, so let's say if I type lstte and tab, you can say test, it will stop at test, because there are two things here, test 1 and testing. So if I just type test, then I, and then again tab, it will complete that command. Okay, so this is how we use different ways or different productive things to improve or to use the power of the Linux environment. Okay, then there is some few more things that we use, and we will cover that in our environment variables. That's all for this topic. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, which is maneuvering in a VI editor. So let's open a VI editor and let's see how we can move around. Okay, so let's say this is our file. So we type VI, the file name, and press enter. Now here you can see that I can scroll a cursor. Okay, but as far as the VI commands are considered, okay, so the way the VI commands work is that you will use these, you will use the commands like, if you look at your editor, you will find H, J, K, L. Look at your keyboard, you will see that these four will be in one line. So if I want to go down, what I will do is I will press J for going down. Okay, if I want to go up, I will press K. So if you press K, you will keep going up. Now, if I want to move on the right side, I will press L. Okay, so if you press once, you will move one step, two step, like that. Okay, now if you want to go to the left side, you can press H. So just keep pressing H. It will take you to the left side. So just to recap, so what we have seen is, this is your VI editor, let's say, and you are here at this place. This is your position. So if you want to go down, you will use which key? Small g. But if you want to go up, you will use which key? K. If you want to go on the right side, you will use which key? L. And if you want to go on the left side, you will use H. So if I just put it in the arrow mark, this way is L, this way is J, this direction is your K, and this direction is your H. So when you are in a VI editor, this is what you need to follow for moving around. Okay, so now let's look at some other commands for maneuvering this, some other keys that we will use to maneuver in the file. So let's say that if I want to scroll pages up and down, so if I say I'll go down, press Ctrl F. Okay, so it will scroll by page. And if I want to go up, I will say press Ctrl B. Okay, so you will keep moving up. That is Ctrl B. So we have seen Ctrl F for forward movement, Ctrl B for backward movement. Okay. Next thing what we will see is we will see these commands like W. So if you say from here, if you press W, just take note that you will scroll by one word. Okay, word by word you will move. Okay, but if you press say L, you will move character by character. Okay, but if you press W, you will move word by word. Okay, then another major thing is if you press 0. Okay, let's press 0. You come to the start of the line. And if you press, let's say, dollar. Okay, so what will happen is you will be taken to the end of the line. Okay, so start of the line, press 0, and end of the line, press dollar. Okay, so this is how you move around in a VI file. Okay, that's all I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of VI, in which we will see how we can run the operating system commands in a VI editor. So let's open any file. Let's say that I have this file. Okay, so this is nothing is there in this, and let's say there are a few things which is being done. You are working on few lines, and at some point of time you feel that you need to run operating system commands. So what you do is you are in the insert mode right now. Just press escape button in your keyboard and you can see the insert mode is gone. Okay, now in this command mode, just press colon and take note of this exclamation and any command that you want to run. Say date. You will see the output there. Okay, so this is the output of date command. Okay, just press enter. You are back in VI. You say Who am I? See the output. So this is how you can run the operating system commands in a VI editor. Okay, so let's take another example. Ask which folder you are in, this folder. So this is where you can run multiple commands in a VI editor. So that's all I wanted to cover in this topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of VI, and let's see some of the editing work that can be done in VI. So let's open this file which has some content, and don't worry about what content is there, just make sure that there is some text is there in this. So I have created one text file. Okay, so let me open it again for you, and at the bottom you can see there is an edit for E. So just press E and you are in the edit. You can edit this file. Now let's explore a couple of things here. First thing is how to delete a character. So let's say I want to delete this B from the because. Okay, so just press small x. The character is deleted. If you press it one more time, one more is deleted. Okay, if you just press, let's say, 1, 2, 3, 4, 5 characters you want to delete one shot. So just press 5x. You can see all 5 are deleted. Okay, so that is one thing, how to delete a character. Next thing is how to delete a line itself. So just press D. Okay, D for Denmark, or D for Don, or D for Danny. Okay, so just press D. You can see that the line is deleted. If you press one more time, another line is deleted. If you press 2 times, just press 2DD, or let's say if I press 3DD, 3 lines will be deleted. Okay, so this is how we delete the line and multiple lines. Okay, next thing I want to show you guys is how to go to the end of the line. So let's say that you are here at the start of the line and you need to go to the end of the line. Just type Shift A. Okay, you will go to the end of the line. So this is your line which starts here and which ends here. Okay, and at the bottom you can see it's an insert mode. So using Shift A, you go to the end of this line, and here you can start typing. You're already in the insert mode. Okay, and once you are done, press escape. So this is how you use the Shift A command to start editing it. Okay, so we have seen how to delete a line, how to remove a character, and let's say if I want to remove this word, okay, you can type CW. You can say the word is removed, and here you can start typing and just press escape. So the word is removed. Okay, now if you want to perform a redo operations there, okay, so if you can press Control R, okay, already at the newest change, and Control U. Okay, you can press U to revert back, and you can press Control R to change it to the newest one. So just to recap what we have done so far here. Hi, good morning everyone. Let's get started with our next topic, which is copying and pasting the words, the lines in a VI editor. So how do you perform these activities? Let's open a VI editor. So let's say I have this file and I'll open this file. Okay, so let's go to the top line and go to the start of the line. Now, if I want to copy paste something, okay, so for that there is a command called yy. Okay, so just type yy to copy the current line and p to paste the current line. Okay, so let's say that this is the line that I want to copy, the first line. I'll say yy. So to copy the line, as we have seen, is the command is yy command. Okay, so just press yy and press p. You can see that I had copied this particular line and I pasted this line. Let's say if I copy this line yy and if I go at the bottom of the page and press P here, which is small, you can see that how that line that I had copied is pasted here. Okay, so that is about one line. But if let's say I want to copy multiple, let's say I want to copy 5 lines. So say I want to copy 1, 2, 3, 4, 5, 6 lines. So I will go here and press 6 YY. You can see at the bottom that 6th line yanked. Okay, now I can go anywhere wherever I want. I can just press small p to paste them. Here you can see 6 more lines. So this is how you do a copy and paste of lines in the VI editor. Okay, so next thing we will see about deleting a line. So let's say if I am here at this line and I want to delete this line. So what I will do is I will press DD, small d and then small d, DD. So this line gets deleted. But if I want to delete, let's say 5 lines, so I will press 5DD. So you will see a message like 5 fewer lines. Okay, so now let's see if I want to delete a character, small character. How I will do that? I will just press small x. One character is gone. If I press another time that x, another character is gone. Okay, so depending on how many times I press X, so many characters are deleted. Okay, so this is how we delete a character. So we have seen how to copy a line, how to copy multiple lines, how to delete a line, how to delete multiple lines. So that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye-bye. Hi, good morning everyone. Welcome to this topic of finding and replacing text in a file. So let's get started. Let's open a file. So let's open this particular file, that is testing.txt, and you can see this file has some content in it. Now what I want to show you guys is how to search for a text and how to replace a text. Okay, so to search for a text, what you do is you press slash. The moment you press slash, look at the bottom here. Okay, so you can see that this is where this is your slash, and you can start typing, like let's say I want to search a word called Belgium. Okay, so if I just press enter, you can see that it has shown you this word Belgium. So how do we do that? Slash and the word name that you are searching. Okay, and if I want to find out the next occurrence of this word, what I will do is I will press N, just simple small n, and you can see that it will take you to the next occurrence of the word. Okay, so this is a way to search a word. Now next thing what we will see is to replace a word. Okay, so let's search a word and replace it. So there are multiple ways we can do. We can type something like :1, that is starting from the first line, comma $, that is from the first line to the last line, space S is search for this word, let's say Belgium, and replace it by, let's say, Netherlands. And so this will search Belgium and replace it by Netherlands. But this will replace just one occurrence in a line. But if your line has multiple such occurrences, so you just type /G, that is globally. So take note of how this command is formed. Let's analyze this command. Okay, so what we are going to do is we will see the details of this command. But if I press enter after this, you can see that the Belgium is replaced with Netherlands. Okay, so this is a read-only file. So let's open. Okay, so now let's search it again. Then 1, $, that is starting from the first line to the last line. Search S slash the word that you want to search, and after that the word that you want to replace it with. Okay, and all occurrences of this word in a line is /G. Okay, so here you can see that the occurrence is not found because I spelled Belgium as BLEGIUM. Okay, so you can see that how we can change the words, how we can replace the words. So let's analyze this command again. Okay, so let's look at the analysis of this command. Okay, so $1, $, that is starting from the first line to the last line, space S means search the word that you want to search. So this is like, if find this thing slash replace with some word, let's say Netherlands. So find and then replace with this word, /G means globally. Okay, so this is one way of replacing it, that is starting with the word :1, that is starting from the first line to the last line. S stand for search. Okay, search this word and replace it by this word globally. Okay, same thing, we can do it in a different manner also. Okay, now let's see the different way of doing this. So %s. Okay, then so what we are searching, this word, let's say I want to search this word, which is, say, Netherlands. Okay, so I am searching this word Netherlands and I want to replace with this with say Hong Kong. Okay, and slash G means globally. Okay, I'll press enter and you can see that the Netherlands is replaced with Hong Kong and all the currencies of Netherlands is replaced. And if you just type Netherlands here, you will not find that word. Okay, so this is how we do a find and replace of the word. So the command looks something like this. It is extremely important command. Just take note of this. So this is colon %s. Okay, so this is for, we are searching for what? This word, let's say Netherlands, and so this we are finding this and replacing with Hong Kong. So replace by this word slash G means globally. If you take note of this command and this command, the output, the end result is same for both the commands. Okay, so this is how we do search and replace, that is find and replace in a VI file. So that is what I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic of joining a file. So what we are going to do here is we are going to see a feature of VI to append a file at the bottom of a file or anywhere in a file. So the way it works here is, let me show you the example straight away. So let's say that this is your VI editor. Okay, let me close and open it again. Okay, so let's see that this is your file that you want to work on, and so let's say that this name has, okay, so this is your file. Now at some point of time you feel that you need to add a password file here at this. Password file is an example. So just type :r and just type /etc/passwd, and you will find that at this very location, the password file is embedded here. So this is how we insert a file inside a file. Okay, so let's say that at the bottom, if you feel that you need to add some file, say services file, so just type :r and the file name that you want to embed here. Okay, so this is your :r and the file name, and just press enter and you will find that this file, the services file, is added here. So this is how you can insert a file within a file using this command. Okay, so there are cases where you need to perform this type of editing, and this is the way to insert a file within a file. So that is pretty much I wanted to cover in this topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of joining multiple lines in a VI editor. So there are cases where you want to join the two lines into a single line. Okay, or there is a multiple command or single command which is spread in multiple lines you want to club together in a single line. So how do you do that? So the way it works is that, let's say this is a VI editor and you type something, say this is working well enough. So there are 3 lines like this. Okay, and press escape. So there are 3 lines here, you can see, and there is a requirement that this command, if it is split into 3 parts, will not work good enough. So I want to join them in a single line. So what we do is we just press J. Okay, so the letter J for Jordan. Okay, J for justice. So J. Okay, so it's shift J, that is a capital J. Just take note that you have to press capital J or shift J so that you can join the lines. If you press small j, it will take you to the next line. Okay, so let's do this again. So let's say that this is my second job in Linux. So let's say I'm asked to put this in a single line. Press capital J or just press shift J. So if you press once, you will see 2 lines combined together. If you press 2 times, both the lines. So any number of lines can be combined together into a single line. So this is how you join multiple lines in a Linux system in a VI editor. That's all I wanted to cover in this topic. Thank you and have a nice day. Bye-bye. Hi, good morning everyone. Welcome to this training topic of VI. Let's open a file which has some content in it. Okay, it's a text file, and if you press E, it will be in edit mode. Okay, so now what I want to show in this particular topic is 3 different commands. That is how to see the line numbers in this text editor. So VI is a text editor, but if I want to see the line numbers, I will do :SE space NU. So that means it will show you the numbers. You can see the line numbers, line number 1, 2, 3, 4, like that. The different line numbers are there. Okay, so that is pretty useful command, very handy command to see if there are any empty lines. Or so empty lines, if I don't need it, I can just delete them. Okay, so that way for editing it is important. Next thing is, let's say that I am searching something and I am not able to find it. So there could be it could be in uppercase, I am searching in lowercase, or something like that. So what I can do is I can say ignore case, C/ignore case. Okay, so if I search something, say I am searching this word, and you can see that it is small, but it's selected. You are able to find that. Okay, so that is about the ignore case. So we have seen how to see the line numbers, how to do an ignore case. Okay, whether it is small case or capital letters, you will be able to search it. Okay, so these are 2 different things that I wanted to bring it up in this topic for you guys. So the line numbers is very important. Ignore case is important when you're performing some search and editing operations, or reviewing or analyzing some issues in a file. Okay, so that is pretty much I wanted to bring it up in this topic. Thank you for joining me and have a nice day. Bye-bye. Hi, good morning everyone. Welcome to this topic of the shell. In this topic, we'll talk about what is a shell and the role played by the shell in a Linux operating system. So whatever commands we issue at the command line, so this is called the command line, as you can see here on this window. So this is your command line. Whatever you type here, so that is a command you are typing. Okay, so let's say I'm typing this. This is a command that I'm typing. And so as per definition of shell, whatever you type, that is, if you just tick, if you have just noted down that we gave the command ls minus lr. So these commands that we have seen so far, ls command, ls minus lrt command, okay, the previous commands like date command, time command, date command. So all these commands that we type on the command line. So this is your command line. Okay, so let's say if I type date, if I type, say, let's say man command to see the manual page. So whatever I type on this, that is on the command line, is interpreted. Okay, so this interpretation is done by the shell. So commands issued at the command line on any computer system are read and executed by a program known as command interpreter. So this is whatever we saw, that this all this is interpreted by the command interpreter, and this interpreter in a Linux system is called a shell. So what this command interpreter does is it will read the commands and any options and arguments that you provide. So in this case, if you see that this is a prompt, this is the command that we gave, and these are the options that we used with the command. So this is the command, this is the command, and these are the options that we used with the command. So let me write it down. And this one that you see, the dollar prompt, okay, this is called this is basically a prompt, that is, it is waiting for your inputs, it is waiting for you to enter the command. So what this command interpreter does is this will read the command. So this command interpreter, what it does is, first thing is it will read the command. Okay, it reads the command. So along with the command, the options that you give, the arguments that you provide. Okay, then next thing what it does is it will translate or expand any special characters. Okay, so the special characters in this case, so second major thing that it does is it translates. Okay, so it will translate the special characters that you provide. Let's say I will give the information as ls, let's say s star. So star is a special character, that means anything starting with s. Okay, so there is nothing starting with s. So let's say if I give ls c star. Okay, and let's see here what we have. Let's say if I give the command as ls b star. Okay, so you will see that it will list me the commands, that is ls, let's say the command is, say, d star. You will see anything starting with d, and if you type something like, let's say you type ls r star, so it will show all the things which is starting with that. So these are the wildcards. So the next thing that we saw is done by this particular command interpreter is it will translate or it will expand any special characters. Okay, then the next thing is it will locate the command that you want to execute on your system. Okay, so next thing is it will locate the command, and finally it will execute Okay, so it will execute the command with whatever options you have given, and it will display the output of that particular command. So on a Linux system, a command interpreter is called as a shell. So this is called the shell. There are different types of shell that we will be seeing, but in short, this is what is the shell. So in short, whatever commands that we want to see, these commands are interpreted by the shell, and there are different types of shells. So we will see the different type of shells which is available, and just to list down for your information the different shells. Number one is your K shell, that is the corn shell. Okay, and you call it as KSH. There is something called Bourne shell. You call it as Bash or BASH. Okay, and the simple shell that you call it like this. Then there are other shells like you have TCSH, you have ZSH, you have ESH, but the most common of them that we will be using is the corn shell, the Bourne shell, and the C shell, that is CSH. So CSH, KSH, and Bash, and the out of the box, the SH. Okay, so these are the shells that we will be looking into, and all these shells, the list of all these shells, you will find in the file called /etc/shells. Okay, so let's see that this file, and after that we'll close this topic. So how to read the command or read a file /cat/etc/shells. So this will list down all the command types that is available. So you can see bash, that is Bourne shell, C shell, corn shell, and the default shell. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining me, and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of shell that we started. So in this topic, we will see some of the features of shell. First feature is about the command history. So in this particular shell, how do you find out which shell you are working in is to type echo $shell. Take note that they are case sensitive. That is extremely important if you have worked on Windows before and you are transitioning from Windows into a Linux or a Unix system. So if I type capital ECHO and say, you will see the message, this command not found. Whereas if you type small, it will say this is found. So this is a case sensitive, extremely important. Throughout this training, just make sure that you type whatever you see. If you see capital letter, use capital letter. If you see small letters, use small letters. Take note that the working in Linux or Unix is case sensitive. Okay, then next thing is about some of the features of the shell that we saw. So one very important feature is called history. If you want to see the list of all the commands that you executed it will be shown in history. Okay, you can see that so many commands got executed and we can see all the commands here. Okay, and let's assume that as an example, if I want to execute the command number, say 996, that is who am I again. So just write this and type the command number that you are seeing here, and you will see this command is getting executed and this is its output. Okay, then next thing is command completion. So if you see this particular command which is too big, ls minus al, let's say this dot x, this is too big. So if I just press tab, you can see that this is getting completed. Okay, so this is how you can complete the commands. Okay, so if you want to use a wildcard, you can just give star. Okay, and you can see there are two such files. One is this, another is this, because you use the wildcard. But if you do not use the wildcard, you will see that this is like this. Okay, next example of command completion. Let's say if you want to see dot recently seen commands, so just type tab after that, see how that command is completed. So that is one feature, that is command completion feature. So we have seen the history feature, we have seen the command completion features, and there is one very important feature that I wanted to show you guys is about the VI feature. That is, you can invoke the VI from here itself using this command. VI is an editor, so if you want to invoke the editor from the command line from this shell, you can just type this and press enter, and whatever you type you can execute, enter it or change it using the VI syntax. Okay, then the next thing that I wanted to tell you guys is about the environment variables. So what are the environment variables in a Linux system? So if you just type set, okay, so you saw something scrolling on the screen because it goes by the which command you are, which shell you are in. So first thing that we need to see is the type of the shell. So what is the type of the shell? If you guys remember, echo dollar shell. Okay, and in this particular shell, that is a bash, that is Bourne shell. Okay, so in Bourne shell, if you want to see the environment variable, you can just type the command called printenv. Okay, so you can see these environment variables, and there is a command called env also, using which you can see the environment variables. So what are environment variables that we are talking about? Let's say this environment variable, let's pick up one of them, home. So if you type cd $home, so what this means is that this is one environment variable, but I want to go to the value of this. To get the value of this environment variable, I will type cd $. Okay, dollar will give me the value of that environment variable. So $home. And if you just press enter, it will tell you that, okay, and just type command pwd, which means present working directory. So that will say that you are in this folder. Okay, but if you want to see the value of this, just say echo $home. So what it will tell is, it will tell the value of this. Okay, so the value of this environment variable, or what it is set to will be seen here. Okay, so these are all the environment variables which is available here. So what you can do is you can define your own environment variables that you work on. So how do you do that? We will be seeing in this subsequent trainings, but just take note that you can control your environment variables. Okay, that is, you can define that when I log into a system, I should get this values of the, let's say instead of getting slash home equal to slash root, I want to go to some XYZ directory, so I will be taken to that particular folder. Okay, so that is the environment variable. So this particular environment variables, actually there are some system files which controls, okay, so controls this. So let's see these system files, that is etc slash profile, and to read a file we'll use the cat command. Okay, here you can see that this particular command or this particular file that we saw, etc slash profile. Okay, so let me, this is our command, but it scrolled so fast I couldn't see it on the screen. So to go slow, what we can see is, or to scroll page by page, we can say pipe. This is a pipe symbol. If you just see your keyboard, you will find this. Okay, this type of symbol. So this is the symbol. Let me retype and then type more, or you can type less, or you can type page wise page scrolling. Okay, so less, if the your system has the less command, so you can go up and down, but with more you can just keep going down. Okay, so here what you are seeing is, this is the etc profile file. Okay, so what this profile file is containing, it will contain the information about the different profiles. If you log into this, so what is the profile you are going to get? You create a new user, what is the profile he's going to get? What type of terminal you are going to get? Okay, what are the default environment variables you are going to get? So that information is present here. So this defines, that is, whatever users you create, they will get this profile by default. Okay, so that is about the profile file. Then there is something called profile.local file. Okay, so let's look at this file also, that is profile.local. So if you see ls minus ld I have typed, that means I want to see this, if it is a, whether it is a file or directory. If I am not sure, I will do like this. So it will tell, okay, this is a file. Okay, if it is a directory, if I type ls minus l, it will show me the listing under that. So let's open this file, or we can say, instead of cat, we can say more this file. Okay, you can see the syntax of this, that is what is available. Okay, then there is another system-wide configuration file for profile on a Linux system, is etc profile.d. Okay, here take note that this is a directory. That is, if you type ls minus l, this, you will see the listing of files under it, but you will not know whether you have what else went into that. So you can type this command ls minus ld to see whether it is a file or a directory. If it is a directory, then to see the files under it, you can see this command ls minus l. Okay. So these are the different features which are available, and as we have seen what is an environment variables, how to see the value of the environment variable, what is print env, what is env command. Okay, and take note that if you want to use this, let's say that this is your env or print env command, and if you want to change this value of, say, this variable, home variable, what is its current value? Root. So if I want to change it to something, say, let's say it is /tmp. So if I just type let's say echo dollar home is this value, and if I want to change this, I will use a command called export home equal to /tmp, and to validate whether that value is changed is which command? Echo command, echo dollar home. Okay, you can see that even though your environment variable, you have the value as root /root, but you can change it like this. Okay, so this value is changed, but if I want to again change it back, so I just need to type echo home equal to, so we will use the command export home equal to. So the moment you use this command, it will change the values, it will reset. Okay, this is your current value, and if you just say echo dollar home, it will change it immediately. Okay, so that is what this particular command is, and this is how we see the environment variable. This is how we change the environment variables. So that is the important thing. That's all I wanted to cover in this topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of home directory. So whenever we create any user, so let's say that we have created a user test4, and the moment I become this test4 user, okay, so if you do pwd, you can see that this has a home directory. Okay, so this user will land in his home directory. So if the home directory is not there for some reason, you can create it and make sure that this home directory is fully owned by this user, which is test4. Okay, and this should be the permission for this. Okay, so this is the home directory, and let's say if you are in any folder, any XYZ folder, and you want to come to the home directory, you can just type cd and this sign, which is the tilde sign, and if you do pwd, you will see that you are in your home directory. Okay, another thing to take note is if you do ls minus e, you can find couple of files which is created automatically by the system the moment you create a user. So we did not create any of these files. The moment we created this test4 user, these files got created. Okay, let's see that one more time how that happens. Let's say that I am adding a user by name, say test 5. Okay, and if I log in SU to that user, and if I just do ID and take pwd, this is the home directory, and if I do ls minus a or ls minus al, you will find all these files which gets created automatically by the system whenever we create user. And if we do ls minus l, you will see that there are no files there except this bin folder. Okay, why is that we cannot see the rest of these files? You can see this is one file. Okay, so let's take a screenshot for this and then let's investigate it further. Okay, so this is your files that we are interested in, and if you see this, okay, let's look at them in detail. Okay, so this is the output of that, and if you see some of the important files that I wanted to highlight here is that you can see there is a file called .profile file. Okay, so this is the file which is read whenever we log in. Let's say if we want to set some environment variables, so we need to set them in this file, the .profile file. Okay, then there is a file which is called .bash rs. So this is another file which stores information about the profile parameters and all, and the startup profile, startup environment. Apart from that, there is a file called bash underscore history. So this is the history file. So whatever you do, whatever commands you type, it will be stored in this file. Then there are some other dot files you can see. There are a lot of other dot files for, let's say, there are so many dot files are there. Okay, so the main objective of these dot files is that first thing is they are hidden. So if you do ls minus al, then only you are going to see these files. Okay, but the moment you take out a from this, you do ls minus l, you will not see all of these files. Okay, so this particular parameter, the parameter that is a, so this parameter is for showing the hidden files. So whatever files that start with .xyz, these files are called the hidden files, and they are seen only when you specify -a option. Okay, so that is pretty much I wanted to cover in this topic. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, which is on shell scripting. This is one of the core topic in Linux or any flavor of Unix. This is the heart of the topic. So just make sure that you get conversant with this topic. So let's start a simple shell script. So to write a shell script, what we have seen is we are going to use a VI editor, and at the prompt you type VI and the file name. Let's say I have the file name as first script and the extension for a, let's say if it is a bash script or shell script, we give the extension as sh. Okay, if it is a C shell, we could have given csh. Okay, let's assume it is a ksh or bourne shell. So we gave this extension. So for ksh it is .ksh, but for a bourne shell or for a normal shell it is .sh. So what we do is we create a file using vi editor, and once we are done with it, let's say we open the file, and the first entry that we do is that will tell exactly what I'm trying to. Okay, so what is that particular entry is? We will come back to that. Okay, so you can see that hash mark exclamation slash bin slash, let's say, sh, or it could be bash, it could be ksh. So let's look at this file, and here you can see exclamation. So hash exclamation and this entry. This tells the system that whatever prompt you are in, whether it's a C shell, K shell, Bourne shell, you always execute this particular file that you have in this script, in this shell. Okay, so that is the significance of this. So if we see here, I am running in /sh. Okay, so this is entry is extremely important. Just take note that this is kind of mandatory for any program that you are writing, any shell script that you are writing. Okay, so this is a one of the mandatory kind of statement, and this shell will depend on, it could be bash, it could be ksh, it could be csh, it could be gsh. So it could be any of the standard shell that you prefer working on. So if it is a bash shell, you will see the first line as this. Okay, so you will not see both the lines, you will see just only one of it. Okay, so this will ensure that the shell that you are going to execute your program is going to be whatever shell you want it to be in. Okay, so that is about the first most important parameter that we just saw. And second thing is, if you take note that when we are writing a program, we have to write a lot of comments, and any line starting with hash, okay, that means that this is a comment. So the significance of this entry is you can specify, or you can do your kind of documentation in this, so that it will tell people who is reading the script that what you are intending to do. Okay, so how you have prepared your variables, what program you are planning to run, what variables you defined, and what is the flow of activities that you plan to perform. So comments is extremely important, and you can add a comment about when you made any change, what changes you made, okay, who made the changes. So all that information you can put under any comment starting with this. So this line is extremely important, which is hash. Okay, any line with starting with hash will tell the system that this is a comment. Okay, so you can write, we are starting our first program. Okay, so we are starting our first program, but this will not be executed by system because you will see that this program is starting with hash, means it is a comment. Okay, then there is one more way to add a comment in a Linux or Unix system is starting with backslash and asterisk marks, ending with anywhere asterisk marks and this slash. So whatever lines you write n number of lines in between the two. So whatever is written in between the two, so all that bracket is your comment. You don't have to write comment here. If you use this characters, this symbol, so this is the starting one and this one is for the end. Okay, so that is about the comments in a Linux system. Next, very important thing is how do we echo or how do we put some statement on the screen. Okay, so we use this particular command called echo command. Okay, so using echo command, you can whatever you write here. So like this is my first script in Linux and double quotes close. So the output will be that you will get this on the output screen. So echo, then in the quotes you will have whatever statement you want to echo. So echo is extremely powerful command that you should be aware of. Okay, next important command that I wanted to tell you is about the exit command. Okay, so exit 0. So this exit command is why it is important, because if you are on loop or if you are stuck, so there is a path to get out of the execution using the exit command. So that is about the exit command. So these are some of the very popular commands that you should know. Okay, there is one more way of adding comment in the system is, let's say that this is your program, you are writing say date, this is your command, exit is your command, echo is your command. Okay, but after this command you can write hash and this is your comment is starting from here. So you are executing the command and then your comment is starting. So this way we can write the different options in a shell script. Now let's try to write one simple shell program. Okay, so let me go into this folder. Okay, and there are some files are there. So let's say I want to write a shell script. Okay, let's say .sh, and this being a VI editor, first thing is you become a get into insert mode, then type hash, after that exclamation mark slash bin slash, let's say ksh or bash bash. Okay, after that we will write that the comment that this is my first program in shell script in Linux and quotes close. Okay, so this is, and how do you echo that on the screen? Echo double quotes. Okay, this is my first program. Okay, so whatever you echo will be echoed on the screen. Then if you want to type date, you can just say date command. Okay, and if you want to say exit in between, say exit 0, and just type escape and colon WQ. So you have saved this, but how do you run this? So if you do ls minus l for this particular program that you wrote, this is not an executable. Okay, so you need to do chmod plus x. Okay, so we are adding the execute permission. So what will happen is that the owner will be able to execute this. Okay, so the plus x is executed. So owner has executed right, group has executed right, and others has executed right. So they will be able to execute this program. Okay, now to execute this, type dot slash and the program name. Okay, so this file and press enter. You can see that you are getting this message. This is my first program and the date that you wanted to show. So that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with this next topic where we'll talk about the different functionalities of RPM, that is how do we install it, query it, list it, update it, and all this information. So before we go there, so first thing is about RPM, what is contained within an RPM. So it is actually it's a dot RPM file. That is the file with the dot RPM extension. And when you look at the different components packaged in this, you will find that there is an information header which will tell that, okay, so there is an information header. This will tell that what is contained, who created this software, what is the version of this software, and all that information. Then there are CPIO archives. So this is a list of archive files bundled together. Okay, so then there is a GPG signature is there. So this will ensure that your RPM is not corrupted during a download or during an installation. Then there are installation script which runs to ensure that the installation is as desired. So any RPM has these four major building blocks. Okay, so these are the four major building blocks of RPM. So these are our four major building blocks. Okay, so these what we call them as the building blocks. Okay, just to recap what we have seen in our previous topic about the disadvantage or the benefits of RPM is you can organize your stuff better. Okay, so you get the benefit of organization. That is, it is an organized manner. It's better organized. Okay, there is a central database. It's centralized. Okay, then there is a, you can track it. So tracking functionality is there. You can see the dependency. dependency can be seen. This can be automated as well. You can see the security features there. So all these are the benefits of using RPM. Okay, now let's look at seeing how do we install an RPM. Okay, so for installation of RPM, normally we use a command called RPM. Okay, so this is the command that we use. RPM is so at the dollar prompt using root user ID, RPM minus I. Okay, and the name of package. And this package will be in this particular format, .rpm format. And if we want to see it in a verbose manner, that is to see what is going on, we can see IV stand for verbose, H is for hash, that is it will give the hash marks to say what is going on, how much is done. And this is for installation. This is the package name .rpm. So this is how we install the RPMs. So let's see it in the system how it works. Let's say that I have an RPM here in this system and I would like to install my RPM. So before we install the RPM, we can just query also if we want. Let's say RPM minus QA to query, and we grep for, let's say, grep minus I PDF. Okay, there is nothing by the PDF word. So what we'll do is we'll try to install this RPM minus I for installation. V is in verbal mode and H, it will show the hash signs of what it is doing. Okay, and this is the package name with the .rpm extension, and I'll just press enter here. You can see that this is preparing is done, then installation is done. Okay, and this is the file. Now to check whether the installation is successful or not, you can just run this query command and you can see that this particular package is installed. Okay, so this package is installed in the system. So this is how we perform the installations of RPM. Okay, so that's all for this topic. Thank you for joining me and have a nice day. Bye-bye. Hi, good afternoon everyone. Let's get started with our next topic, which is on querying an RPM. Okay, so this is about querying an RPM. So how do we query an RPM and why do we need to query an RPM? To find out information about an RPM package, you have to query the RPM, and you can use the -q option for query. So the option will look something like this. RPM -q is for query, and then the name of the RPM. Okay, so we will see an example about, so this is your package, and we will see the different options which goes with the query option, but the main option is Q for querying. Okay, querying RPM is extremely important to administer an RPM based system because you may need to see what version of software is installed, determine whether a file you have come across on your system is used or owned by an RPM package, or list the files that belongs to an RPM. So that's why it is extremely important to query an RPM so that you can find out the file ownerships, the files which are part of the RPM package, and the different versions of the RPM files. So listing files in RPM. So how do we list them? So while querying, if we want to list it, we can use this option called RPM minus QL. Okay, and the name of the package that we want to list. So let's take an example. Let's see how this works. Okay, so what we are doing is we are listing down the files in an RPM. Okay, so let's see in our system. So let's say in our previous topic we had installed an RPM. Okay, let's grep for that package which has the PDF name. So this is the package that we installed, and let's see the files which are associated with this package using -QL, and the name of the package, which is, this is the name of the package and that is the name of the version. So if I just click here, it will give me the different files which are installed as part of this particular RPM package. Okay, so now if you want to see what files belongs to a package before it is installed, you need to query the RPM using -p option. So let's say using -p option, we are going to find out which files belongs to this particular package. So -p, and it goes with QLP and the name of package that we gave. Okay, so open up this field. So we just need to give the name of the package here. So by package, so first thing here you can see that we gave this option. This is the package name, but this is the with the version that is with the RPM. Okay, so we need to give the RPM name here. So what is the name of the RPM we have? So this is the RPM that we have, RPM minus QLP, and we can find out with this particular RPM which are the files which are associated. So take note of the difference between the two. This is okay, so this particular command which is there, which will give for a particular RPM. So you are querying an RPM here. So you are querying an RPM package and finding out what files will be installed. And here you are querying a package which is installed in your system. Okay, so this is about querying a package which is installed, and this is about querying a RPM file to find out what all files which it will be having. Okay, so next thing is about finding out a RPM, what a RPM package owns a file. Okay, so let's see this. Okay, so let's look at this option, RPM minus QA, which will list all the RPM packages in your system. So this is extremely important because you can filter what you want to see, or you can see a list of what packages are there in your system. And if you pipe this and grep for a particular package name, say grep -I means ignore case, for SAP, what SAP packages are installed, you can see that these are the list of SAP packages which are installed in this system. So this is how you can query all the packages. There is another useful way of doing is you can do RPM minus QA and redirect this to a file. Okay, say list of RPMs. Okay, now you can open this file and go through this list. Okay, you can see that which all packages are present in this particular system, what is their version numbers, Okay, say let's say for SSL, you can see, okay, you have open SSL. Next is you have live open SSL. You have this version of SSL. SSL certificates are there. So you can find out, you can see in detail what is present where. And let's say if you want to see C++, okay, you can see this is the C++ compiler you have. Okay, C++ 4.3 compiler you have. Okay, so this is how you can query an RPM, which is extremely important command, that is RPM minus QA. Q is for query and A is for all the packages which is there. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is removing an RPM package. So we are talking about removing an RPM. So far we have seen how we can create an RPM, how we can query an RPM, and in this topic we are going to see removing an RPM. So the command is RPM minus E. This option is for remove. So whenever you are working on RPM, just take note of this option, and you need to give the package name that you want to remove. Okay, so after an RPM has been installed, you may need to remove it from the system for one or the other reason. As it does when installing packages, RPM will check the dependencies of the package that you want to remove. So this check of dependency is as important as checking package dependency during installation, because it should not happen that you end up deleting files that another RPM depends on. Okay, so that is one good feature of RPM, that it will check the dependency analysis before removing it. Okay, so let's take an example here. So let's get into the system and let's try to remove a package that we had installed. So this is the package that we had installed, and let's query this particular package. So this is package name having PDF Word. So you can see that this is the package that is there, and I want to remove this particular package. Okay, I can remove it like this and give the package name, and if I just press enter, this will remove this package. How to check whether the package is removed? You can run this command again, and you can see there is no output returned here. So this is the way you can remove a package. There is one more flag there, is that dependency, that is don't check the dependency. So that is not a good option because dependency has to be checked. So just take note that whenever you are removing an RPM, make sure that you don't specify no dependency check. Okay, so that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, which is updating an RPM in a Linux system. So how do we update an RPM? So the topic is updating of RPM. The command remains the same that we have seen. It's the RPM command, but we use the option -u and the package name. Okay, so this is the name of the package. And there is one more option which is comes with for updating an RPM, that is -f. So this is for freshen up, and this is the upgrade option. Okay, the difference between the two is that this particular option, this will remove list of old files and install the new file, but this does not work if previous version is not installed. Okay, but the difference with this one works even if the previous version is not installed. Okay, so let's try to see this. So let's say this is the version that I want to upgrade it to. I can use this command rpm minus capital U, and we can use this option minus VH and give this name. So this is how we update an RPM. Okay, you can see that the RPM is updated using this. Okay, now let's say that if I remove this, and so this is the application, and now this is removed. Okay, there is no such option. But if I run this with minus F flag, okay, let's see what happens. Okay, so there is no previous versions are there, and let's run this, and you can see that this is not installed. But if you run this one, what will happen is that this will install this, because this has failed while installation because there was no previous version, but this installs it even if there is no previous versions of this. Okay, so that is about updating an RPM. Okay, so that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of RPMs. In this topic, we are going to see what is an RPM and why the Linux based operating systems require RPMs and what brought them into this stage of using RPM functionality. So before we get any further, RPM is actually, it stands for Red Hat Package Manager. Okay, as the name indicates, this is started by Red Hat, but this is not only for Red Hat, this is for all flavors of Unix, for Linux, basically all the Linux flavor. Plus, there are other operating systems which have started using this RPM concept. Okay, so previously in the olden days, what used to happen is that whenever you install any new applications, you download the software, you untar it, you configure the build environment, compile it, and when it comes to installing the application, you had no way of telling what file belonged to what application. Okay, so let's say there are thousands of applications in your system, and if you install it this way, it will be a nightmare to perform uninstallations, perform installations, query the installation, find out which version of what software is present, and all that stuff. So that led to the creation of RPM. So RPM solved this particular issue. RPM uses a standard central database. Okay, so that contains information about all softwares installed on the system. Okay, so the previous problem that we had, the bottleneck that was there, is no way of tracking which software, which application, which package is present. But this central utility, central RPM tools, which has a central database, keeps track of all softwares which is installed on the system. So what you can do is you can query the software. So you can just query and find out whether a particular package is installed or not, what version of that package is installed, what files are owned by that particular package. So all that information can be found using this query to the RPM database. So that is the reason why the RPM was built and people started using RPM. So before we continue with the examples of RPM, how to create it and all that information, what I'll do is I will just list down some of the reasons why RPM came into existence and what was the disadvantage of unpackaged softwares. Okay, so as we have seen that when we install a package, there is no way of telling which files are owned by which particular package. It's difficult. Upgrade becomes very difficult. So the first and the foremost thing is no way to tell which files are owned by which particular package. So the ownership becomes, and which files belongs to which package. So this becomes difficult. Next thing is the update becomes very difficult. So when you try to update, you will not know which are the files which I should be worried about. Security, let's say there are security bottlenecks identified. It will be difficult to identify which particular application or package it belongs to. Then there could be a duplication could be there. Let's say someone has installed with one name and you installed with some other name, and there are chances of duplication is there, and support is totally nightmare for this type of. So support, let's say if you want to administer it, you want to manage it, you want to control it, it becomes very difficult. Okay, so these are some of the drawbacks why people got away from the traditional way of installing the different softwares, and that is where the RPM came into existence. So just to recap, it is difficult to track installed files. Manual tracking after each installation is there, and you need to use find and tar and vmdiff command to find out what has happened. Okay, so that is why the RPM came into existence. So in the next topic, we will cover about how to install an RPM, how to configure an RPM, how to update an RPM. Okay, so that's all for this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is on verifying an RPM. So how do we verify an RPM? Okay, so the topic is verifying an RPM. So to verify whether an RPM is installed correctly, we can use the command called RPM minus capital V and the name of the RPM that we want to check. Okay, if this returns nothing, that means if there is no output, that means this is installed successfully and is working successfully. All the verifications are done. On the other hand, if something is wrong with the package, you are told what file in the package is different from the original installed file from the RPM. So for each file in an RPM that differs from the norm, you receive a letter that dictates what difference was and why. Okay, so that is on how do we check an RPM. So let's run this command and check that. Okay, so get into our system and let's use this command to verify an RPM. Okay, so let's check that. As an example, let's take minus capital V. Let's check the zip utility, whether this is working fine. So this is installed properly, working fine properly. So let's use some other, let's say if I use OpenSSL. Okay, this is also working fine. Okay, one more thing in the RPM side is, let's say if I have a command, let's say if I have this particular zip command. Okay, so let's see the binaries for zip. Okay, so this is the command that I have. And now I would like to know what is the RPM, which is, if I query in RPM, what it should look like. Okay, so we use the command called rpm-qf, that is the associated file with this RPM. And if I just press enter, it will give me this, that is, this is the version of this particular RPM that you have in this system. Okay, let's apply the same thing for OpenSSL. Okay, so which OpenSSL. Okay, now let's run this command rpm-qf for this OpenSSL, and you will see this particular version. And you can run this, check the same thing using rpm-qa grep for OpenSSL, and you can see there are number of OpenSSL stuff here, but the relevant ones that we are interested is in this one. Okay, so this is the version of OpenSSL that is effective. So that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye-bye. Hi, good morning everyone. Let's get started with the next topic, which is pipes and Unix and Linux. So basically, what is a pipe? It's kind of inter-process communication, that is inter-process communication means the communication between two different processes. We call that as IPC also. Okay, so what happens in this is that you can connect two commands together. Let's say there is a command called ps command, and I want to connect this command. Okay, and I want to, let's say that I want to connect this command. Okay, or there is a command called ls-l command. I want to connect this command with some other command, let's say grep command. Okay, so what I am going to do is that we will see how we can connect different commands. Okay, so this is the inter-process communication. In this, you can see that this is one command, and this command will have some output. So the output of this command becomes the input for the other command. So this is the output, and which is becoming the input for the other command. Okay, so this is what happens in a inter-process communication. There could be n number of different commands that we can use here. Okay, so could be like, let's say ps, or you can use with sort command, or you can use with any other command. Basically, you can see this is one layer, second layer. So you can have n number of layers. You can link the output as the input of the command. Okay, just to get you guys how exactly it works, let's get into the system. Okay, so here if I type ls-l, you will see this as the output. Okay, so this is our command ls-l, and this output I want to redirect to the input of another command. So for the grep command. what I want to grab, let's say, only the shell scripts, that is sh, from here. Okay, so you will see that all the files which has sh in that gets listed only. So you can see that the output for this command, which was, this is the output for this command, and this output has become the input for the grep command. Grep is like a filter command, so it will filter anything having the word sh. Okay, so here you can see that all the commands is having the word sh in this. Okay, so this is how we can redirect the output of one into the input of another. Let's take the ps commands. Let's say this is ps minus ef grep for this process called sap. So you can see that how we can filter using this grep command. Basically the output for this, if you just see the output for this is a big list. Okay, but if I combine this output with this command, so this becomes the input for this command, and I am filtering anything having the word sap in it, so that we see only the sap relevant stuff here. So this is how we can link the two commands using this pipe symbol. So this is called the pipe symbol. This is there in your keyboard. Okay, if you can look for this word, this one. Okay, this is like a vertical arrow just above your enter key, you may find it. Okay, this is a straight vertical line. So this is how we do the redirection of output of one command as the input for another command. So that is pretty much I wanted to cover in this particular topic. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is pipes and redirection. So what this actually is. So whenever we type any command in Linux, let's say this command ls, this has some output which is printed on the screen. So if we want to capture this output, and instead of printing on the screen, we just pipe this and redirect this output as the input of another command. Okay, so what will happen in this case is we are redirecting the output of one command as the input of another command. Okay, so let's see this concept in more detail, what it is. So in this case, what happens is that we can combine the multiple commands. Okay, so what this pipe does is, this is redirecting the command, that is, this is one command, and if you don't, this is your first command. Okay, so the output will come on the screen, that is your terminal. So there are some files are there, you will see those files. But instead of this output to come on the screen, we redirect this output as the input for another command. Say ls cat these files. So it will list or cat all these files, or ls, let's say lpr, that is print all these files. Okay, so basically this is one command, command number one. This is command number two. Okay, so this way you can have multiple commands. So the output of this command, so its output is sent as input parameter for this command. So this way we can club multiple commands. So that makes the Linux or the Unix system extremely powerful, because these are simple commands, but you can achieve many complex things out of it. So just to recap, most of the processes initiated by Unix command write the output to the standard output, that is your terminal. So whenever you type any command, the output goes on the screen, which is called your standard output. Okay, so this is normally it's your terminal. So then, and for many command, they take the input from the standard input. Say, let's say this command cat and the file name file1. So this is we send the input from the terminal itself, because this is sending the output to the terminal and this is taking the input from the terminal. So we just club these two commands using the cat command, using this particular pipe symbol. So automatically this output becomes the input for this command. Okay, so we will see a couple of examples on these lines. So let's take some examples. So let's say that this is one command, that is ls minus l, and I want to take the output of this command. So you can see the current output. This is the current output, and I want to just do pipe and just say okay, grep starting with D, that is grep all the lines which is starting with D, that is directories. Okay, so I'll just press enter. You can see all the directories have come. Okay, so there are multiple uses of this command, so that is just one example. So let's say in case of this, let's say I want to say there is one command called awk command. So I won't go into the details of this. Let's say print say $9. Okay, so we will see the details about this command as well, but you can see that I have outputted just the column number 9. So you see there are 9 different fields, 1 2 3 4 5 6 7 8 9. So ninth field I have outputted. So this way I can redirect the output of one command as the input of another command. So every process has at least communication channel to it. That is, you have the standard output, you have standard input. Okay, so there are three things: standard input, okay, standard input, that is std in, standard output, and standard error. Okay, so the standard output, so whenever let's say any process is running in the system, they are allocated the numbers for it, and these numbers they corresponds to something like this. Okay, so this is 0, this is 1, this is 2. So instead of just saying standard output, standard input, we can just type okay, redirect to this and redirect to the error to this, output to this, and other details into this. So how we use this command? So let's say I want to use redirect the output. Okay, so ls, and this is the redirection symbol. I want to put it in this file, say this file. So if you see the output of ls, this is the output, and if you cat this file, you can see that this file has this particular out. It has come here in this. Okay, so this is how we redirect the output of one command into another command. So then there is, this is what we have seen is the standard output. Then there is something called standard input. Okay, so let's say cat, and I am taking the input from this file. Okay, you can see that it has taken this particular input. Then there are errors also, like if let's say I want to search a particular file name. Let's say I want to find out a core dump, and whatever error comes in, I don't want to see these errors. I want to see them, send them to the dev null. We'll see this, what is this dev null, but this is basically to a device or to a file, or we can just specify, put it in a particular file, say /tmp/errors. So what will happen is that this is one command, and I am sending whatever error comes during the execution of this command into this. So this will keep running basically, and later if we come here, we can see the output of this command in this errors in this file. Okay, so these are the three things that we need to take note of. Okay, so first is this symbol that we just saw, redirect the output. Okay, then we saw this symbol, that means redirect, take the input. Okay, then there is one more command called append. That is, let's say if I want to append the output in another command. Let's say I have one file and I want to append that file with different things. So let's say cat/temp/1, and I want to append that, okay, in some file, say /temp/2. Okay, and if I again run this, and if you just see the size of, you just cat this file, you will see that this file has 3 times more entries than it was previously, because it gets repeated. Okay, because you are appending one by one instead of overwriting it, you are appending the output there. Okay, so that is about the standard output, standard input, and we use normally in this ps command a lot. So let's say ps-ef grep for, let's say, process as SAP. Okay, it's grep command, grep for SAP. So it will filter me, it will just do the listing of all this, and this output is sent to this command, and this command will filter all the rows which is having SAP word in it. Okay, so that is about these commands here. So that's all for this topic. We'll continue with our redirection in our subsequent trainings as well. Thank you for joining and have a nice day. Bye-bye. Hi, good morning everyone. Let's get started with our next topic, which is standard input redirection. So we'll see an example of how we can redirect a standard input. So standard input by default is the terminal. So let's take this particular example. Let's throw some output on the screen. So let's say this is my dollar prompt and I want to sort out few things. So short and just press enter. Okay, and start typing this commands. Just press Ctrl D. Okay, so Ctrl D is normally we presses, it's like this is the caret sign and D. Okay, so you will see the output in the sorted manner. Let's see how it works. Okay, so let's say short. Okay, and this press enter. Here we can specify some things like art, gallery, science, math, English. Okay, and after that if we press Ctrl D, you can see how the output is arranged. So this is the output. You can see A, E, G, M, then S. So this is in a shorted manner, that this output is in the shorted manner. Okay, so let's take another example. Let's say that same thing whatever we have typed here. Okay, this one is, let's say if I put this in a file. Okay, so let me create a file. Let's say slash temp slash file name is list. Okay, so just go into the insert mode by pressing I and then just paste it. Okay, escape and colon WQ. So we have created this file. So let's read this file what it is. Okay, now this file you can see that this is not in a shorted manner. So what we are going to do is we are going to short this by giving this short command, and this short command is taking input. So this is the input symbol. Okay, so the input is coming from where it is coming. It is coming from this file called slash temp slash list, and press enter. You can see the output here. It is in the sorted manner. Okay, so that's how you can sort the output. Okay, and if you want to redirect this sorted output in a new file, you can do that as well. You can just say sort this and redirect this output into a file called sorted file. Okay, you can see that the output is redirected. You don't see anything on the file on the screen. So if I just cat this sorted file that we created, okay, here you can see that this file has the sorted output. So the output is redirected and the input is redirection coming from this file. So this is how we do the input redirection. So that's all for this topic for today. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, which is on redirection. So in this topic we are going to see the different types of redirections, why we need to perform a redirection, what is the benefit of doing a redirection. So as we have seen that every process has three different communication channels available to it. The first one is the standard input. Okay, so standard input in this case is your keyboard will be your standard input. Okay, so that is standard input. Then the next is the standard output, which is your screen. Okay, that is std out. Okay, and finally the third is if there are any errors, they should be captured as well. So that is standard error. That is stderr. Okay, so these are the three different types of outputs which are available, and normally we refer them by a file descriptor. So the file descriptor, there is a file descriptor called 0 for this one, 1 for this one, and 2 for this one, and they are the file descriptors. Okay, so how do we use these file descriptors? So for this, let's say that I want to echo a particular message, okay, and want to capture that in a particular file. So on the prompt, let's say this is a message, echo testing is done. Okay, and if I want to redirect that, so this is the symbol that we use, redirect. So redirect this into, so here what we are doing is we are redirecting the output. Okay, so your standard output becomes a particular file. Let's say this file. Okay, so we are redirecting it, and let's see other things. That is, this is the redirection about the standard output. Then take we can take the inputs as well here. So how do we take those inputs? Let's see them. So another thing is, let's say that I want to redirect both the output and the error to a particular file. So how do we do is, let's see this example. The same example, let's say testing is done. Okay, in this case, I want to redirect not only my output. So output is like this, but if I want to redirect the also the errors, then this ampersand sign is there. Okay, so and we can give this file name. So both the output, so this means the standard output and the standard errors, both are going into this particular file. Okay, let's say that instead of sending the output or the errors to this file, I send the errors to some other file. Okay, so in that case, echo testing is over, and I want to send the errors to a particular file. So I will just write 2 is the descriptor for error and just say this sign. So this means sending the errors to this file. Let's say the file name is /temp/errors. So we have seen that if we want to redirect the channel output to a particular file, the file descriptor is 1, and this is how we do it. If we want to redirect both output and error to same file, this is symbol is extremely important. Just take note of this symbol. This symbol looks like this. So greater than sign and then ampersand sign. Okay. Then for redirection for errors is, this is the symbol 2 and this greater than sign. So this means your standard output plus standard errors, and this is just the errors to a particular file. Okay, let's say that if we want to read these errors from a particular file. Okay, so in this case, let's say that the input is, our input is different. Okay, so in this case, the input becomes the file that we created. So your input is, let's say that this is what I want to do. So I want to mail a particular file. Okay, mail -s. What I want to do is I want to mail, this is the subject, test mail, and in the mail I want to, this mail I want to send it to say this person, and what in the mail I want to send this file as the input. Okay, what is that file that we saw? Say outputs. Okay, so here what is happening is that this particular command, it takes this is as the input. So your input in this particular case is this file. So you are inputting this particular file, okay, and then sending a mail. So take note that how we use the standard output, standard input, and there is one more thing that I want to show you guys is the reroute a command's output. Okay, so let's say that you already have a file, okay, and you want to enter the subsequent, let's say, echo, that is the second line in a file, in the existing file. But if I write like this into the same file, slash temp slash output, this file will be overwritten. But if I want to append it, okay, so I will use this sign called, this is the sign 2 greater than sign. So what will happen is that this line will show both the lines. Okay, so this is how we use the standard output, standard error symbols. Okay, so let's see it in the system. Okay, so let's take the example of the redirection to a output file. So echo testing is, it says started, and I want to echo that in a file called slash temp slash output. So what I'm doing here is that I want to write this output or this message in this file. So I will use this symbol. This is for standard output. So the output of this command. Okay, so if I just write like this, what will happen is that you see there is nothing has come to the screen, but whatever was expected on the screen, so this is the command. If I enter like this, this is the expected output. So what is happening here is that this output is captured in this. If I just read this file using cat command, you can see that this output has redirected. So this is called redirection, and this output has gone into this particular file. Okay, this is how we use the redirected command. Okay, and let's take an example that I want to append this file with some message, say adding a second line. Okay, and I want to append. So if I append, what will happen is that, so before that, let me say if I just write like this, so what will happen is that this file will be overwritten. Okay, so let me show you that example first before I do an append. Okay, now if I read this file, you can see that this is overwritten. This text is no more there. It is overwritten with this text. So let's say that again you have entered this command. Okay, and if you read the output for this file, you can see that this is the first line which is there. Now if I want to append this, so how do we append? It is 2 greater than signs into the same file because it's an existing file. And if you see this output now, you will see there are 2 lines. Okay, so this is about the output redirection. Okay, next thing we'll see is about the input redirection. and we'll continue it in our next topic. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is the redirection for errors. So in this we will see how to redirect the errors. Okay, so just to recap what we have seen in our last topics. So for doing a error redirection, we use this type of symbol. Okay, so this means that the errors are redirected, and if you don't specify, you may get some errors like, okay, any errors which will come on the output screen. But if you specify this, and let's say that file name, okay, so in this file the errors can go. So just take an example. Let's take an example here. So I want to redirect. I am searching for a file. Let's say I am using a find command. I want to find from the root directory, and the name of the file that I want to search is, say, james.exe file or james.txt file. Okay, this file I want to search, and any errors that are coming, I just want to redirect to this file called /dev/null. So take note that this is a very special kind of file. It's like a discard, that is anything which will go into the junk, or this is kind of, that is, discard these errors and don't keep a file of it. So it will be like a trash bin kind of thing. So errors, you will not see it on the screen. But if you want to redirect these errors to a particular file, so instead of /dev/null file, we'll specify some other file. Okay, so we want to search this particular file, and errors I want to redirect to this file called /temp/errors. Okay, so what this will do is this will redirect all the errors into this particular file. Okay, so let's see an example for this one. Okay, so let's see an example and then we'll move forward. So let's take an example. Let's say I am in this folder. This is the folder I am in, and let's type one particular command. Let's say in this folder, okay, so this is also empty. Okay, so let me look for a file. Okay, so let's search for this file called, this is the file, let's say this file. Okay, I want to search this file from, say, root folder. What is the name of the file? This is the name of the file. And so this is the file that I am searching. I want to redirect the errors. Okay, so this is how I will put it, /temp/errors. So all the errors will get redirected here. And you will see that the list of files by this name. Okay, so this is how we can redirect the errors to a particular file. So if there are no errors, this file will be of 0 byte. But if there are errors, you will find the number of errors listed, which was supposed to come on standard output, that is on your screen, will be captured in this file. Okay, so this is taking, here you can see that this is the list of the files So this is the file that we searched. So this file is present in so many locations. Okay, but if we search the size of this file, let's see if there are any errors. You can see that the file is of 0 byte. That means there are no errors. Okay, now here you can see that there is some output on the screen, and you want to capture this output also. That is, you want to capture your errors output in one file, say this file, and your errors in this file. Okay, so this is how you can do that. That is, you are capturing this output that you are seeing here. Okay, so the output that has come here, you want to capture using this command, and the errors that you want that is coming here, you want to capture it here, so that on the screen nothing comes, because your output is going in this file, your errors are going in this file. Okay, so this is a way we can redirect our errors and the standard output to a file. So let's see the size of this file now. Okay, so and if you cat this file, so let's cat this file, that is, let's read this file, you will see that all the output has gone there. Okay, and as we saw previously, there was no error, so this file should be of 0 byte again. Yes, so this is how we can redirect the errors. Okay, redirect the errors to a particular file. So that is pretty much I wanted to cover in this particular topic. Thank you for joining me, and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this training topic of processes in a Linux system. And in this topic, we are going to see the different aspects of the processes. That is, what is a process? What are the different types of process? What is the state of a process? And which are the different attributes of the process? How to identify a state of a process? Okay, so let's get started. So first thing is, I'll give you a brief overview of what is a process and the basic commands for running a process. So this is a very important and useful command for a Linux administrator. If you do ps, it will show the different processes that you are using. Okay, if I type ps and you give the option as aux or minus aux, okay, you will see screen scrolling showing different options. Okay, so and if we scroll up a little bit to see the different attributes shown here for a process, you can see that so many processes are running on a system. And if you want to see a page by page, or if you want to scroll a process, you can just execute a command called ps minus aux or ps aux, and this is a pipe symbol. Okay, so this is very important for the different factors that we will be seeing in our subsequent trainings. Just take note that pipe and more, you will see that this is your first screen, and at the bottom you can see more option. So you can see the different attributes for a process which is running in the system. So let's see what these attributes are. So let me give you a quick overview of them. Okay, so let's copy this and let's paste it here so I can give you a brief overview of what they are. Okay, so here you can see that I have a list of different processes here. Okay, so here is the list of different options that we have, and let's see how to use them and what is the significance of each of them. Okay, so this is one of the most commonly used option that we saw, which is PS AUX. And in this PS AUX, so this A stand for, so you have PS AUX. So PS is for process listing. And this option A that we saw, this stand for all processes, that is, show me all the processes. So which are the all processes that is talking about? So he is talking about all the processes, even though if they don't have a control terminal. Okay, then in this U means user oriented. Okay, so this U stand for the user oriented output. Okay, so this is your user oriented output here, and X in this case means, so even processes that don't have a terminal there. So X is means show me even the processes that don't have a control terminals. So here you can see that this TTY, this is your control terminal. So even if you don't have any control terminals, you can see that this is a system process, init a system process, this is a system process. So they are the daemons which runs in the system and they don't have a control terminal. So you see that using this option, you see the processes which doesn't have the control terminal. Okay, and this is a user oriented view. So this is one of the most commonly used option that is used in this. And let's see, at the top you can see what this all means. Okay, so here at the top here you can see that this is the user command. Okay, so this means the user name of the process. Okay, this is your user command. Okay, you have the PID. This is one of the most important significance or most important thing in this. You can see that this, for an init, this process ID is 1. Okay, so for the init process, this process ID is 1. So next process ID is 2, next is 3. So these are the boot related process IDs. Okay, so you will see the difference between the boot related process IDs and when you are running a process, what is the process ID. So just take note that this is one of the most significant thing that is there in this. Okay, so the most significant part here is this process ID. Okay, and the next thing here, out of this, the most significant part in this is your CPU usage, percentage of CPU this process is using, percentage of memory this is using, and here this means the virtual size of the process, that is how much is, what is the virtual size for this process. Okay, and in this field you can see this means stat. So this stat means the current process status. Okay, so which are the different status of the process we will see in our subsequent subsequent lectures. The S means that it is a sleeping process. Okay, so and this small s means that this is a process leader. So process is a session leader. Okay, now which are the other options for this? So we will be seeing further, but just for your information, one is running process, sleeping process, zombie process. Okay, Then there is a process called traced process, which is being traced. Okay, so these are the different state of the processes. Okay, then there is a flag. You can see this small s. This is the flag and this is the state. Okay, so this is on the process side. So just to recap what we have seen so far, here you can see that this is your Unix or Linux system, and this command remains the same irrespective of whether you are working on Unix or Linux, because this is a command which is across the Unix or Linux flavor. Okay, well, this is another view of the same thing. Okay, so you can see which user ID with which process is running, process ID, CPU usage, memory usage, virtual size, whether it has the terminal or not, state of the process, when it started, for how long it is running, and the command that is being executed. Okay, so let's see some other type of process. Let me take out this more option. And here you can see the different states of the process. You can see states like this has a terminal. Okay, so let me take a screenshot for this one. Well, this is another view where you can see some more options. Things like this is one state. Okay, so this is a running process. Okay, and here you can see, okay, 1 second. Okay, so here this option that you are seeing, this red option. Okay, so this is one option that you are seeing that is starting with R. Okay, so this is one option that you are seeing here. That means this is running. There is another option that you can see, there is not question mark, which means there is no terminal, but this means there is a terminal associated with it. Okay, so this is a terminal and this means that this is a running process, and this is your command. Okay, so this is the user ID with which your process is running. This is extremely important thing, that is the process ID called PID. Okay, then there is one more thing that you can see here is since when this is running. Okay, all this information is useful for troubleshooting. Okay, how it is useful, let's see that. Let's say with which user. Suppose one user is complaining that I have this problem. So you need to find out which are the processes running using that user. Okay, so from which terminal the user is coming. So in case if user said my process is hanging, can you reset my terminal? So you need to know or find out which is the terminal. Okay, someone may come and say, can you check is my process running? You can check the state of it. Okay, and someone may come and say that, okay, I'm running this particular program or command. Can you check is it still running? So this is where you will check that information. And this is how we find out the different aspects of a process, different parameters of process, and how we use this. Okay, that's all I will cover in this particular topic. Thank you for joining me and have a nice day. Bye-bye. Types of process. In this topic, we will see the different types of processes. Okay, so there are two types of processes in an SAP or in a Unix or in a Linux system. First type is a user process. That is, user is running it from his terminal. Okay, so this process is associated with a terminal. So let's say that I am running this particular process. I will have a terminal associated with it. Okay, how we can check that part? Let's say that I am running this process, say this is running in the system. Okay, and here you can see the terminal associated with this. Okay, so let's say I'll send this in the background. Okay, Control Z and then press BZ. It is gone in the background. Now if I run ps-ef, or let's say if I want to run say ps-aux command and pipe grep for something called sar command, you can see that this is the terminal number which is associated with it. So if I just say I'll stop this so you'll get better picture. FG is for foreground. Just press Ctrl Z. You can see that nothing is coming on the screen. Okay, so that means that this process that was running is stopped. Take note that it is not killed. Okay, how do we know that? Because if I just type FG, that is bring it in foreground, or if I go send it in the background, you can see that this is still running. It is still sending the output. Okay, so it is not killed. If I press Ctrl Z again, okay, so Ctrl Z is not working in this. If I press Ctrl Z, take note it is not working because this process is already in the background. How do we know? Just type jobs there. You can see that one job is running. But if I bring it in foreground by typing FG, okay, so it is in foreground. Now if I press Ctrl Z, you can see it is stopped. Okay, so this type of process has a terminal associated with it. Okay, if you see I am giving pipe grep command, reason is the listing is too big and I want to just keep it short and filter out. So this is just a filter command. Okay, what I am filtering is SAR. So it will show me from the entire process the SAR. This is your terminal which is associated with it. This is the user which is running this. So this is a user process. Okay, now next thing is let's see at the other processes. So let's say ps-aux, pipe it to more, and here you can see that there are a lot of different daemons which are running. Okay, so these are the different daemons which is running, and under terminal TTY there is a question mark here. Okay, so this means that this is a terminal ID and there is no terminal associated with this particular process. So this is called a daemon process. Okay, so the next thing that is a daemon process. So what is a daemon process? So daemon process means there is no terminal associated. Okay, so these are the two types of processes. You have a terminal, this has no terminal, and this runs the main programs within the system. Let's say if it is a web server, it could be running a daemon called httpd. If it is an SAP system, you could have different processes running with the user ID as SAP, and their the processes could be things like could be something like, let's say there are tons of different processes. So let's say it is start SRV. If it is an Oracle system, you could see process something like the log writer. The So you will see different types of process depend on the application, and these are all the daemons because it doesn't need a terminal to be running. So they are all the daemons. So this is a daemon process. All these are daemon process. Let's say if it is an FTP server, you will have a process called FTPD. Okay, so that is so for an FTP, the process will be FTPD process. So depending on the application, you will have the daemon process or the daemon which is running, which will keep listening for your request, and it doesn't need a terminal to run. So these are the different types of process that I wanted to cover. Hi, good morning everyone. Let's get started with our next topic, which is manage processes. So Linux manages processes by sending them signals, and the command that is used to send signals is, we can use a command called kill command. Okay, and there is another command called kill all as well in SUSE Linux. So we can use either of these commands to send the signals. Okay, so let's see the attributes of a kill command. What are the attributes we need to send and what is the significance for them? So if let's say this is PSAUX, and you see the list of different processes running. Okay, now you need to kill a particular process. Okay, so let's say that there is a process which is, this is the process which is running. Okay, and if you see what is the process ID of this particular process, let's see the process ID of this particular process. So let me run this in background. Okay, and let me open another window to see this particular process, how it is. Okay, so I have opened another window over here, and let's see this particular command. We can use, normally we use this as the command, but in some systems we use EF also. Okay, so let's grep for this process which is running here in the background. So the process ID for this is the process ID. Okay, this is the user with which the process is running. This is the terminal which it is using it. Okay, and let's try to kill this process. So when we kill a process, we can send different type of sig terms and different type of signals. So the kill -9 is hard kill. Okay, so we can just say kill -9 and the process ID. It will kill the process. It is saying that the process is completed. So let's run this one more time. Okay, now this process is now running in the backend, and let's grep for this. Okay, so you can see that the PID of this process has changed. This is the old process ID. When the job is completed, this process ID is no more there. And you have the new process ID for the new job that we have triggered. So now if we want to kill this, you can see in the backend this is running. And if we want to send a hard kill signal to this, so kill -9 process ID, we can do it this way. You can see at the backend that it's killed. So this way we can kill a running process. Okay, now let's say that we again trigger this and let's try to use another command, which is kill all command. Okay, so we will see how we can use the kill all command. Okay, so here you can see that this particular process is running the SAR process at the backend. Okay, and we can confirm by running this statement. Okay, this process is running. So we can use this command kill all command, and the argument for this is, instead of the process ID that we used last time, we will use the specified name. Okay, so we will use this name and we'll see the result of this. You can see that immediately you get a message, it's terminated. Okay, so we can terminate or kill a process using kill all command, and here we need to specify the name instead of the process ID. Okay, so these are the two different ways we manage the process. Hi, good morning everyone. Let's get started with our next topic, which is the states of a process. So which are the different states of process? We will talk about whenever a process is running in a Unix or a Linux system, it has three different states. Let's look into them. So the first state that we will talk about is the processes which are running. Okay, so the processes which are running in the system, and how do we find out whether the process is running? We will see that. So what happens is that whenever a runnable process is ready to execute, that is the time when CPU is available for it. Just let me rephrase this. A runnable process is ready to execute whenever CPU time is available. That is, it has acquired all the resources it needs and it's just waiting for the CPU time to process its data. So as soon as the process makes a system call that cannot be immediately completed, the kernel puts it to sleep. So let's say that, let's take an example that this is your kernel and this is the memory that you have, and these are the list of different processes which are there. Now the process, let's say that 4 processes are running. Now you have just one CPU. So first process is running. Okay, so it is CPU is running this particular process. So that process is in the running state. But as there are 4 processes, so this gets some time. It processes to a particular state. Then after some time, this gets its time. Then this gets its time, and then this gets its time, and afterwards then this again gets its time. So you can see that this particular CPU that you have, this CPU is running all these processes and it is not getting completed at one point of time. That is, it is not happening that one process is totally complete, then it will pick up, CPU will pick up the next process, then it will pick up the next process. So this way it doesn't work. So what happens is that these processes, the process which is running, they wait for the CPU time. Okay, they wait whenever the free CPU is available. So the moment free CPU is available, they will straight away start getting executed in the CPU. And once the system call, that is, as soon as the process makes a system call that cannot be immediately completed, the kernel can put it to sleep mode for a time being. So that is the first state, that is, process is running in the system. Second state, as I said, is the process is sleeping. Okay, so let's say that this particular program that you are running, this takes 10 minutes total time. Okay, out of these 10 minutes, it may happen that for 8 minutes, the system, that particular process is sleeping, and it gets the time for execution only for the remaining 2 minutes. Okay, so this is the 2 minutes the system, it is running in this actual running time, and the total execution time in this case is 10 minutes for this process. So sleeping process are waiting for a specific event to occur. Okay, since sleeping process is effectively blocked until its request has been satisfied, it will get no CPU time unless receives some signal to activate this. So that is about the sleeping process. Okay, so let's see how these sleeping processes looks like. Okay, let me show you a few things over here before. Okay, so let's take a command psaux, and as it will show a lot of process, I will just pipe it and keep it more. So now here you can see that this is the state of the process. You can see that so many processes are in the running sleeping state. S stand for sleep. Okay, and at the bottom you can see there are some processes which is running. Okay, so these are the different states of a process. So we have covered two states. One is the running process, the sleeping process. Next state that we will talk about is the process is stopped. Okay, how do you stop a process? Stop a process, it's like you have given some signal to stop it. Okay, stop is nothing like, but it is kind of sleeping only. But there is no way for a process to get out of the stop state unless it has the other process wake it up or kill it. So the stopped process. Okay, stopping state. You can send a signal like Control Z. The running process gets stopped. And if you just type BG, means it can go into background phase. Okay, so let's say you have executed a program which is running for long time. Okay, and you feel that you have executed a one command. Okay, let's say SAR14. So this is a command that you have executed, and it is running and running and running, and let's say it keeps on running, and you want it to put it in a stop state. So if you press Control Z, you can see that Control Z. So how you get this caret is just press a finger on Control button, and you can see that if you do a process now, process minus aux. Okay, just type it more. Okay, just keep going. Okay, and you will find that the sar command which you had given. Okay, so what we can do is how to find out that, because it's a big list. So we can use pipe, and there is a command called grep. What we want to grep, sar command that we gave, and now you can see the state of this particular process. Okay, so this state here, you can see that this is a different state. This is a different state. So this is your stopped state of the process. Okay, and if I, let's say, if I just type BG for that process, means I am sending the stopped process in a background. So just see how that process goes into the background. Okay, you can see that the SAR has again started. Okay, and if you now do a PS and grep for the SAR command, you will find that this is no more T. Okay, so it will be either in running or sleeping mode. So that is the third state that we saw. That is stopped state. And how do you stop it? Let's say if you want to explicitly stop it, you can use Control Z or Control Z. Okay, next, finally, there is one more state that is called the zombie state. Okay, what is a zombie state? This is also pretty common, because when a process is running, okay, and they have completed their work, so let's say it has to perform these 4 or 5 activities, it has completed all these activities, okay, but it has not sent the status back. So status has not sent back. Okay, so the system doesn't know whether it is complete or not. Okay, so this is just hanging around. Okay, so it will be just hanging around. It is not completely done. So how do we find out? We can find out, okay, this is, so there are a lot of processes. You will find question mark there for some of those processes, but I'll show you that how we can check that part. Okay, so now here you can see that this is done. So this is one of the way we can get the status, or these are the different 4 ways of finding out the process, or these are the types of states of process. Okay, so a process can have either of the 4 states. It could be either running, it could be sleeping, it could have been stopped explicitly by someone for some activity, or it could be a zombie process, that is, it may have been completed, but it has not yet sent the status back. So the system doesn't know whether it is completely, and they will be just hanging around doing nothing. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining, and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this training topic of scheduling the priority or changing the priority of a particular process. So the range of priorities that we can assign for a process ranges from -15 to 20. So this is the range in which we can define, and here -19 priority means this is the highest relative priority. 20 means it is the lowest relative priority. And what this priority means is, let's see them now. Okay, so using nice command, let's say I want to run a particular command and I want to run it with the highest priority. So how will I do that? -19, and I can run this particular command. Okay, and the command will go something like this. Okay, so it will be, let's say, nice minus n, and I want to run with minus 19 priority. And the command, let's say I want to run this particular command called, let's say I run this share command itself. Okay, so here you can see that this command is running with this priority. Okay, so now let's run this again. Okay, now this will keep on running for a certain time, and let's check the process ID for this. Okay, so PS AUX, and let's grep for this process that we are running SAR. And if you see the process ID, this is the process ID. To change the priority of this process ID, okay, what is the process ID? We have, this is the process ID that we have, and to change it we will use this command called renice command. Okay, so let's check the priority of this process first that we are running. So PS AUX, and let's grep for this process. Okay, the process ID is 61294. Okay, so let's revisit this using nice command. So how can we revisit using the nice command? Okay, so this is going to be nice minus n, and then the priority, and then the command which I want to execute with that priority. Okay, so this command is running with the highest priority. Now if I want to see what is the process for this command, I can run this ps aux grep sar. So this is the process ID. Okay, there is one more line, if you notice, that always comes, because this line is for this command and we don't want this command, so we just eliminate this. Now this is the process ID. So to change the process ID, we use the renice command. Okay, so renice to, let's say, plus 20, and the process ID is 61326. Okay, so here you can see that the old priority is this, new priority is this. Okay, so that is what a priority and a nice and renice command is for. Okay, so priority basically is the niceness of a process, is a numerical hint to the kernel about how the process should be treated in relation to other processes contending for the CPU. So there will be multiple processes trying to get hold of a single or whatever number of CPUs you have. So all these processes are trying to get the time for that particular CPU, and the moment the CPU gets free, whichever in the queue has highest priority gets the first attention. So this is how you can use your nice and renice command to schedule it with a particular priority and to change the priority of a running program. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining and have a nice day. Bye bye. So we have used kill command with -9 option. Let's use the kill command with, instead of -9 we will use kill -15. 15 is actually a very polite kill. Okay, so this is a polite way of sending a sick term signal to a process and giving an opportunity to clean up after itself. A process doesn't respond to sick term signal when the strongest signal, that is sick kill signal, that is kill minus 9 is set. And sick kill, that is kill minus 9, it basically kills the process immediately without giving a chance to clean up. So you can see that there is something called kill minus 15, which is a polite way of killing it. Or and the signal which it sends, kill minus 15, we call it as sick term signal. Okay, so let's try to see a process which we want to kill. Okay, so let's try to run this command. Let's say this command is running, top command is running. Okay, and I want to kill this particular process ID. Okay, so what I want to do is I would like to kill this particular process ID. Okay, this is the process ID that I want to kill. Okay, 60668. Now let me go to the another window. Okay, and let's try to kill this process ID, that is kill minus 15 that I want to show you. And the process ID that we want to kill is, let's say 6414. Okay, this is the top command that I want to kill, which is 60674. Okay, you can see at the back end immediately the prompt is returned and this is killed. Let's see again. This is your top command, and you can see that at the top command, this is your top command. Okay, so for top, this is number 3, process is 60678. Okay, so let's try to send this kill minus 15 signal, which is 60678. You can see that immediately that process gets killed. Okay, so that is about the kill minus 15. Okay, which is sending a sick term signal, and we spell it like this, sick term. Okay, then we have seen the top command. We have seen, let's try to run this process again, top command, and let's see, try to send this kill minus 9 signal, and this signal we also call it as sig kill signal. Okay, so just I had written to show you guys what it is. So kill minus 9 sig is a sig kill signal, which is like a sure shot, permanent, immediate kill. Okay, so here you can see that this process, what is the process ID? Number 2, 60684. 60684. Okay, if I just press here, it's an immediate kill. Okay, you can see that at the top itself that menu comes, prompt comes. So you can see this is where you have the immediately the root, it gets killed. You can see this is killed. Okay, so let me clear this window. Now it is clean. Okay, so now let's see one more command called pkill command. Okay, so let me show you what this command is. So let's see these two very similar commands, pkill, and there is one more command called pgrep. Okay, these two are pretty close, so let's start with pgrep command. Okay, pgrep command, what it will do is it will list the processes. So let's say this is a command minus u, let's say this is the ID, comma, let's say we want to search for some other user, and let's start some process using this ID first. Okay, so let's say I start this process here with the ID as Sam. Okay, so let's see the processes which is running using these two IDs. Okay, you can see that this is the list of all the processes which is running using these two IDs. Okay, so if we want to kill these processes, okay, so how we are going to kill them is we can use this command called pkill and -u, and if we just write Sam, it will kill all the users session user listed as Sam. Okay, so it will not give you the output of the process IDs. So here you can see that this is your process IDs. Okay, but if you just type pkill, it will not show them, but it will kill all these processes straight away. Okay, all the processes which is by this ID, say, let's say PS, let's say I am having running this as the grabbing this particular user, and if I try to kill this particular user session, because this ID is root, okay, so here you can see that the user ID for this is root. 0 means it's a root. So that is the reason it is showing up all the root IDs here. Okay, so let me change this for you so that you can get a feel of how the different users, how we can kill or use this pkill command for the user. Okay, so now let's see the processes which is running for user Sam. Okay, you can see these are the processes which is running for user Sam. And now if we do a pgrep, okay, -u user Sam, and you will see that these process IDs are listed. And instead of pgrep, if I use pkill minus user, say Sam, what it is going to do is it is going to kill all these process IDs. Okay, and if I do this command again, you can see that all commands are killed, all these processes, this, only the SU session is remaining. Okay, so everything is killed. So all the processes owned by this user ID, by this username Sam, is killed. So this is how we use this particular command called pkill command, okay, and pgrep command. Hi, good morning everyone. Let's get started with the next topic, which is signals in a Linux system. So some of the most common or popular signals that we'll talk about in this is Control C and Control Z. So what are they? Let's say there is a command which is running and eating up all your resources and you want to kill this in your screen. So if you just press Control C, that's it, gone. So that is Control C. And let's say this particular command is running in your system for long and you want to stop this from running. You can press Control Z. Okay, so you can see that Control Z, the command is stopped. But if you see the process, so we can use this command for process, that is see the output, and we can use this command as well, this option as well. Okay, see the output here. See the difference in the two outputs. Okay, here you are getting the type which is stopped. So you can see that this particular command, using Control Z signal, you have stopped this. Okay, so just take note of these two very important signals, Control C, Control Z. And as you can see that this is stopped and is running in the background still. So you can send it to run in the background now because it is stopped. And if you check the status of SAR, let's say in different terminal, if I run this status. Okay, so let's check for this status ps minus aux grep for SAR, and you can see that this has changed because it is running in background. Okay, and you see that option that minus is a bad signal here, and if you just change from minus, so this is how you will get the syntax errors. Okay, so now if you want to bring this in, if you press Ctrl C, nothing will happen to that command because it's not running in your terminal, it's running in background. Okay, what you can do is you can type FG, that is command comes in the foreground. Okay, and if you just check this process, see this. Okay, this is process has changed the type, and you just again press Ctrl Z, see this process type. Okay, so these are the two very important signals that you should remember. And if let's say if I put it in foreground and say press Ctrl C, immediately it will be gone. Okay, let's say this command is running, SAR command. Okay, let's say I run this command because it is complete, so run it again. And the moment I press Ctrl C, that's it, it is gone. Okay, so these two, you can see the practical aspect of these two signals, Ctrl C, Ctrl Z. Take note that they are very important signals, and we will talk about the signals in more details, but they are very, very important. So some of the key signal types that we can talk about is there is a signal called HUP, that is hang up signal, INT, interrupt signal, quit, this is also for terminating it, kill is another signal. Okay, stop, one signal, user okay, so we can see that these are some of the signals that can be sent. Okay, I will not go into details of all of them. Okay, so just I will see. Okay, the moment you type kill minus L, it will give you the list of all the signals. And if you remember what we had spoken previously, this is the permanent kill signal, and this is sick term signal, which we had spoken that this is a soft or polite kill. Okay, so that is pretty much I wanted to cover in this topic. Thank you for joining me and have a nice day. Bye-bye. Hi, good morning everyone. Welcome to this training topic of SU, that is the super user command. And this command actually You can call it as a super user, or you can call it as a substitute user. Okay, so these are the different names for this particular command. And so this is one of the name, that is su. You can call that as a super user because you can get this extra privileges using this. You can call it as a substitute user. Okay, so let's say if you are a particular user and you want to work with that particular user. So let me clear this. If you say the ID for this is the ID. And now if I want to become a root user, that is I am switching a user to root user. So I can type su root. Okay, so let's say if I check my ID now, I am a root user. So I have all the privileges of a root user. So there is one more variant for su. Let's see that as well. That is called su dash. So the moment you give su dash, what happens is that it is going to execute the profile, that is it will give you the profile of this user. Okay, so if we don't give that, so we will be in the same directory like this one, but the moment we give su dash root, okay, so the moment we give execute this command, what will happen is that I will get the profile for this. Okay, so ID is root, but if you see the location, I am in this location, that is the home directory of the root user, and I will get all the profile related parameters for this user. So that is the beauty of this su dash, that is you will become that user, plus you have all the startup profiles whatever is available in the dot profile, in dot bshrc, or if it is this C shell then dot login. So you will get those privileges using this su dash command. So just to recap this su command, so using su command, what you're going is you are switching or you are substituting for a user, or you become a super user, that is you attain the power of that user. Okay, so you can do a switch user, you can do substitute users or super user, and su dash that we saw, it gives you the power of that particular user, the profile of that particular user. Okay, so that is for su. There is one more variant of su which is not so well known amongst the people, which is called the sg command. Sg command, what it will does is that it will give you the group. Okay, so there is a command called sg, and the moment you type this sg command, the moment you type this, you will see that the group is this group. It is no more root group. Okay, so you are switching a group in the sg command. Then there is another variant, and that is extremely important variant for su command, which is the sudo command. Okay, so sudo command, the beauty of this particular sudo command is that you can keep track, or you can audit the user who is given these special privileges or super user privileges, and you can control what all the activities this user can perform as this substituted user. So you can give the subset of the privileges of that user. Okay, so that is about the sudo user. So sudo, take note that this is extremely important concept in Linux, because using sudo we become that particular user. Okay, so we will become that user, but we don't have all the privileges of that user. And what this it can do is there in sudoers file. Okay, so let's look at this particular file first. So this is a file where it specifies the privileges for a root user. If it uses sudo command, what privileges? So root will have all these privileges if root uses the sudo. Okay, so just take note of this. The syntax for this is we specify what this user can do. Okay, so this can mount these particular file systems. Okay, so this can shut down this. These are some of the examples. That is, when you become a particular user, you are allowed to execute these commands, whatever we list down, and but not all the commands which is available for a SU user. And whatever you do, that gets tracked. That is, there is a we can track what work you did as a sudo user. So we can see using the vi sudo command. Okay, so using this command, we can see that what all has been set up, who can do what all things. Everything can be seen from here. So this is the file, you can edit it from this. So any addition happens through this vi sudo, and if you see that this will follow the syntax for the vi command, and if you just type a, it is going into the insert mode and you can start typing it. And if after that if you want to exit without saving this, just say :q0. So what I'm trying to say here is that this particular file you can edit using this instead of directly editing the etc sudoers file. Okay, so that is pretty much about the sudo command, and we will see more of this. We will go through some more details about the sudoers, but for now just take note that this file you can edit, make changes using vi sudo command, and which internally uses the vi editor. So vi editor is opened using this. Okay, so that is pretty much I wanted to cover. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of wildcards and pattern matching based. In this topic, we will see how to use the wildcards, why we need to use it, how to match the patterns. Basically, we use these for locating the files and directories on the command line. So there are two major wildcards that we used. First is the asterisk. So let's use it. So if I just type ls-l, it will give me all the files which is present in this folder. Okay, so now let's look at ls-l, let's say test star. So what do you expect? Anything starting with text, and after test it can be any number of characters or digits. Okay, so if I just press enter, you can see that everything starting with test has come in here. Okay, so that is the asterisk, which is the wildcard character. So let's try it one more time. Let's say that if I want to see anything starting with R star. So R star means that anything starting with R and after that it can have any number of characters or digits or numbers. So here you can see that it has shown me all the files starting with R, but given that this is a folder, here you can see that so it lists this particular folder also. Okay, so that is R star. That is how do we use the star character. Let's take some more examples here itself. So if I just type ls, it will show me everything. But if I type, let's say ls tests 1 star, so I should get everything starting with test 1. So here you can see that this is test, this is nothing to start with test, so this is not listed, this is not listed, this is not listed, this is not listed because this is not having test 1 to start with. Okay, now this has test 1, so you have it here. This has starting with test 1, so you have it here. This is starting with test 1. Okay, so you have it here. Now this is test 2, so you don't see it here. The output test 3. No, this is not what we want. So you can see that how we use this asterisk character. That is asterisk marks, how do we use it? Now let's look at this character called question mark. Okay, so let's see what is this question mark means. Let's say if I want to see test question mark dot txt. Okay, what do you expect? Question mark here is replaced by a single character or digit. So here it is replaced by 1, by 2, and by 3. So anything with test question mark dot txt. Question mark means one single character. Okay, so that's how we used these two things, that is asterisk and the question mark. Okay, so if we take some more examples, there is one more wildcard that I want to cover is, let's say if I type ls, say test, and under this you can see 1-3, okay, dot txt. You can see that you will see test after that it could be in a range from 1 to 3. So from 1 to 3 is 1 has come, 2 has come, 3 has come. So this means the range. Okay, so this is how we use these 3 different wildcard characters for pattern matching. Okay, so that is pretty much we wanted to cover in this. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is on the find command. Find is one of very important, very popular command, and a system administrator uses this command almost on a daily basis. So There are a lot of things from the security perspective, from the usage perspective, from the functionality perspective, for which you require the find command. So let's look at some of the variants of the find command. Okay, so let's say that to start with, I want to find something in the current directory. So this will tell that find dot means from the current directory. What? Minus name. Okay, and which name I want to find? Let's say I want to find a file by name, say init.d. So this is how we can use this command to find this type of file. So if it is on the system, how do we run this? It's going to be find, let's say this is the, so let's say from find from dot means from the current folder, minus name, let's say test file. Okay, you can see that it will return that particular file name as output. Okay, second thing, let's see that if I want to find something instead of from the current folder, I want to find something from a particular folder, from this folder. Okay, this could be anything, and just specify test. So from a particular folder, find a file. So you can see that find from slash find slash I from slash itg, find this particular file, which is the test file. Okay, from this find out this file, and here you can see that I am in this folder, and this is the permission of this particular file. Okay, so you can see that if I give from dot, it is able to find it, and this is using root id. Okay, so from this minus name, and there is another variant is specify this minus print. Okay, so if we go to user bin folder and say that I want to find something from user bin, let's say which ls command. Okay, so it will show on the screen what it was trying to search. Okay, so we specify name minus name and file name. So if we do here, we can see that file is not here. So let's search for a file by name, say zless. You can see that it is showing up this particular file. Okay, so this means that find from this folder, and same thing I can do it from the current folder, find from dot. You can see that it is able to find, but this is an absolute path and this is a relative path. So just take note of this difference. Okay, so the next thing is about the wildcard characters. Okay, so let's say that I want to find out all the files which are starting with Z. So I can say Z star. Okay, from minus name. So Z star being a this character. So this is a wildcard character. Okay, so there is escape sequence is required. So anything starting with Z will be seen here. So let's say that if I say anything starting with Z E, okay, so I will write this as Z E backslash star. So backslash star means that backslash is escape sequence, because as it is, if you write star, it will not mean anything. So we will write it as backslash star. So anything starting with ZE will be print here. You can see that these are the three files which start with ZE. Okay, so let's say that I want to find out the files of type F. Okay, so let's say that in this I just want to find from dot minus type equal to F and minus name, say Z star, or star, normally we use it as Z star. Okay, so anything starting with anything having file type as F, that is, it's a file type. Okay, and starting with the Z, so these are the ones which are starting with letter Z. Okay, so that is about finding out a file. Okay, so next thing, let's look at files without 777 permission. So how do we do that? First thing is find from dot, okay, minus type is 5 and pipe minus perm is, let's say, 640. Okay, so okay, so let's search for files with 640. There is none. So let's search for files having permissions, say 755. You can see all these files are there. Okay, so this is how we can use this particular variant. Okay, so this is extremely important. Let's say that if I want to find files which are older than a particular day, okay, so we can specify this command that find files which are older than, let's say, 10 days, or find files which are changed, let's say, in 1 hour. Okay, or let's say the files which are changed in, say, 50 to 100 days. So we use this find command to perform that type of activity as well. So how do we use them? So let's take one example, that find the files which are last accessed, say, 10 days ago. So find from dot, okay, minus m time. So we use the m time. Okay, so minus 10. Okay, let's say instead of 10 days, 100 days. Okay, the moment you increase the number of days, you will see that, okay, these are the files which have the modification time, let's say, more than 500 days. No. 700. Okay, so more than 900, you get so many files. So this is how we use the modification time. Okay, let's say that I want to find out a particular file, or I want to find out all the files owned by a particular user. So what I will do is find, let's say, from a particular folder. Okay, what I want to find minus user is let's say, or minus group is, so I am looking for the user. So user is, let's say, ec1 adm. So what it will do is it will find out all the files owned by this particular user. So this is how this is extremely powerful utility, and you use it at least once a day. Okay, so there is another variant for this that I wanted to show you guys, is to find out larger files. So how do you find that? So let's say that I want to find out larger files. So I will specify a parameter called minus size is, let's say, 100 meg. Okay, so this will show me all the files having size more than 100 meg. So these are the different variants of find command, and all of these variants are extremely important, and day in day out you have to use these variants to manage the system. So that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of YAST, that is YAST. So YAST is actually an extremely important and a must tool which is used for configuring the SUSE Linux using a GUI method. Okay, so the way YAST is, we can use YAST like this, which is a command line interface, plus there is a YAST 2, which does the same thing, but it is a GUI based. So if I click on YAST 2, or if I type YAST 2, it will open an interface for me, and here you can see that this has opened this interface, and if I maximize this, you should be able to see what all can be done using this particular YAST. You can see that you can configure or manage your system using bootloader, change your date and time, languages, change the language and installations, partitioner. Okay, so I'll just cancel this. Okay, then you can see that for softwares, media check, online update configuration, software management, software repositories, and from the user and security perspective, you can see that you can configure a firewall, you can configure security, you can do user management from here. So that is about the security and users. You can do network services, that is define a host name, Kerberos client, LDAP browser, LDAP client, configure your NTP. Okay, you can configure a proxy from here, you can configure the remote administration, Samba server, Windows domain membership. So all this can be configured from this particular tool. So in this topic, we'll see just what is possible using this tool. You can configure your hardware, you can do server installation, HANA configuration, product installation. Okay, network related activity you can perform from here. So if you look at this particular YAST tool, which is kind of a complete configurator using GUI, and most of the work is automated here. Okay, so that is pretty much about this tool YAST Control Center. This is the YAST Control Center, and we can pretty much do most of the system admin work from here. Command line work is also important once this GUI things doesn't work, but take note of the simplicity this provides. Okay, so that is pretty much I wanted to cover in this topic. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of user creation using YAST command. Okay, so using YAST command, we can create a user as well. And let's see the syntax for the YAST command first. Okay, so to find out how to add a user, we can just write YAST to add users, add, and just type help. It will give the options that you can use while creating a user using add option. Okay, so this gives the options like you need to give the name of the user, you need to give, if you want, you can give the UID, you can give common name, password, home directory. Okay, so you can give all these parameters depending on which you want to specify. Okay, so let's create one user using this command, YAST tool. Okay, so we are going to create using YAST2 users. What we are doing, add. Okay, what is the username for this? Let's say it is a test4 user. Okay, and if you want, we can specify the common name for that, which is a test user. Okay, and if we want, we can specify the password here. Password here is, let's say the password that I want to use is, say, password 123. Okay, so this is the password I want to use, and I want to, let's say I want to specify the GID for this, and GID, let's say 100. So what I'm doing here is that using YAST command, this is the syntax, and we can pick up the mandatory fields like username is mandatory and the rest is optional here. So I will just execute this. So this will create a user by name, the test4, and let's see how it looks like in the password file. So grep test4 in from the password file. Okay, here you can see that this command has created this user, and the description for this is my test user, and this is automatically assigned, shell is automatically assigned, and you can see the GID as 100. Okay, so this is how we can create a user using YAST2 command. That is pretty much I wanted to cover in this particular topic. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of GCOS. GCOS is not extensively used nowadays, but let me tell you what this is and how this is useful. So let's get into the system and let's look for this user. Okay, so let's say that this is a user which is there in the system. Okay, so there is a user called test4 user, and this is the entry of test4 in the password file. Let me paste this here. Okay, so now let me tell you which is the GCOS field in this. Okay, so this particular field that you are seeing here, this one, this entry is called the GCOS entry. Okay, so this is your GCOS entry, and we can change this GCOS information using command called chfs. Okay, so let's try to chfn. So using this chfn command, we can change this. So let's see how do we change this and why do we need to change this. Actually, this will help to update the information for things like your full name, so that you have meaningful information here, your office number, your room number, your telephone number, and all that information. So let's see the use of it in the system. So let's say that I type chfn for that this user. Okay, now you can see that this is the username currently, but I want to change it to say this user. Okay, room number, let's say this is the room number. Phone number, let's say this is the phone number. Home phone number. Okay, and if we want to specify anything else, we can specify. So let's check this information whether it gets updated here automatically or not. You can see that whatever information you provided is updated here. And if you check, if you just use this command finger test 4. Okay, so this command is, it's an external command which is not found in this system, so that's fine. Basically we can test it using this particular command, which is the finger command. Okay, so now you can see that this is your GCOS information here in the password file, and using this particular command we can change this information, the GCOS information, can update it with the full name, the number, the phone number, etc. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this next topic of a group file in a Linux system. So this is the file that we are referring to. Okay, let's look at what this file is. So this file actually is storing the information about all the groups. Okay, and list of all groups and its members. That is, who is a member of a particular group. So let's look at the syntax for this and let's see which files, what are these files. So if we read this group like this, you can see this is the syntax for this. Let's take one line for now. Say this is the line we pick up and we paste it here. So now let's look at these values. So the first number that we are seeing here, this number. So this number actually stands for the group name. So this is the name of the group. Okay, then there is another field where this is your exclamation mark. This means that it has an encrypted password or a placeholder. Then the most significant or important part for group is this number. This is called the group ID number. Okay, this has great significance in a Linux or a Unix system. And after this, you can see that this is the list of its members. Okay, so here this group has just one member. Let's say if you have more than one number, say you have another member, you have one more member. So we write them like this, that is separated by comma here. So there are four fields. First field is the group name. Then this is for the encrypted password. Then you have the group ID. You have the list of all the members in this group. Same applies for all the entries. So for one group, there will be one entry in this file. And depending on how many groups are there in the system, you will have so many lines. Okay. So that is about a group file, but there are few more things which is not required right now. But let me show you what these are. If you do a man group, okay, so this is not coming, but what I'm trying to say here is that you can store the information about when you are changing your, when the last change was made, if there are any warning, grace limit, expiration, etc. So all that information can be stored here as well. Okay, but take note of this mandatory information, which is group name. This just, you can just ignore this field. This is about the encryption for password, group ID, and the member of the this particular group. And if you go in a system, if you just type ID, okay, you will find the information about this is your primary group and these are the other groups that you may have. Okay, so you can see this is one example which says that this group has so many members, so all these are member of this group. Okay, but apart from this group, let's say that you have, let's say that you log in as say CE2 ADM. Now if you type ID here, see this UID is this, and from where this UID has come, I'll show you. Let's copy, let's take out this field called CE2 ADM from password. So here you can see that this UID has come from here. Okay, this is your main group. Okay, this is the group and this number has come from, okay, let's grab just this number from a etc group file, and you can see that this number is unique here and this is the name of that group and these are members of that group. Okay, so apart from that, this group, this has so many other groups also. Okay, so it has these many groups, but this is its primary group. Okay, so that is about this particular file, which is the group file. Okay, so let's close this topic here. Thanks for joining and have a nice day. Bye bye. Hi, good morning, everyone. Welcome to this topic of group additions and modifications and deletions. In this topic, we are going to see how we can add a new group in a system, how we can modify a group, how we can delete an existing group. So, in the previous topics, we have so far seen that what is a group. Now, let's try to add a new group in a system. So, as you can see that we have this group file which stores all the information about the groups. Okay, so let's try to add a group called new group. Okay, so how do we add a group? We add a group by using a command called group add. Okay, so the command name is, and I want to add a particular group called new group. Okay, now if we see this file, etc group file, if I just cat this, you will find an entry for this new group created. Okay, so this is how we create a new group. And let's say that tomorrow, if you feel like modifying this particular group name, you feel that name is not good enough, and you can modify this name by group mod. Okay, so using group mod, you can modify. You just need to specify which group you are modifying it, and using this option called -n, you specify the new group called new grp in caps, let's say. So this missing here. Okay, so now here you can see that you have modified the group name, and if I try to again read this file, you will see that this name had changed to this. So this is how we can modify it. And let's say that if you feel like deleting this particular group, okay, so you can delete this group as well. If suppose this is a redundant group and it is not required in the system, so you can just delete this particular group using this command called group del, and you need to just specify the name of the group that you want to delete. So group del and name of the group, and just press enter. And if you again read this file, you will find that this entry is no more there. So this is how you perform maintenance in a group. And if you want to see the options which is available in group add, you can just type this command. This is how you can get and help on this command. So while adding a group, you can specify these options as well. So this is how you perform maintenance on a group. That's all I wanted to cover in this topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning, everyone. Welcome to this topic of GID. So GID stands for Group Identification Number, and this number we get it from the file called etc group. So this number is stored in the etc group file, and if you see the group file, let's open a group file and let's see what is the GID. Okay, so you can see that this number, this is the group identification number. So you can say, let's say the daemon has a group identification number of 2. Then if you go to, let's say you're going to use a root which has the group identification number of 0. So this is a group identification, and you can organize users in a particular under a particular group, and the main significance depends on how you want to use that, because you can organize them all users under a particular group. Say, let's say for an SAP system, okay, anything related with the key group is SAP sys. So users like SID ADM, SAP ADM, database administrator, so all that can be put in this group called SAP sys. Like that, there are groups. You can organize groups for your application. You can organize, let's say that all the staff are staff for, say, finance is put under this group called FI group. Okay, all the sales people are put in, say, SD group. So you can organize the group. One benefit is you can identify who they are. Okay, and second thing is you can find out whether how many people from a particular group are using this system. Okay, so that is about the GID part. As you can see that the group file defines the group with GID field, and etc password provides a default GID at login. Okay, so we will cover the set GID GRPID option as well in our subsequent trainings. But for now, just take note that GID is unique for a particular group, and this is a unique number. And using GID, we can organize the users, and we can track from which part of organization or which company, how many users are there in this. And it all depends on how you want to group them. So that is where you use group file and GIDs to manage them. That is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of login shell. So what is this topic all about? So when we create a new user, a shell is assigned to the user. So let's see the user creation process one more time, and let's look at the shell. Okay, so let's go to the system and let me open the password file. Okay, let's take this example, the bottom one. Okay, and let's paste it here. Okay, now if you look at this particular example, what you will find is that this is the shell that we are talking about here. Okay, so this is your login shell. So when the user logs in, he will find this particular shell. Okay, so this is the shell that will be given to the user the moment he logs in into the system. And to see which are all the shells which is available in the system, let's look at this particular file called etc shells. So you can look at these are the different shells which is present in the system, but the most important of them is the bash, the csh, the ksh, and sh. So these are one of the most important shells which will be used. And if you want to find out which shell you are in, okay, what is the shell you got, you can just type this command called echo dollar shell. It will tell you that this is the shell that you got. Let's say that for this user test 4, okay, we will do issue dash to simulate the user. And if we look at the shell here, just type the same command echo dollar shell, you will see that this is the shell that he gets in. Okay, so the shell is a command interpreter, and the traditional is slash bin slash sh, but the most common ones are bash and csh. So bash, and basically this is a bourne shell. Okay, so that is about the shells. So just to recap these shells, so the most important ones are the bourne shell, the corn shell, okay, then you have seashell. Okay, so for bourne shell, as we have seen, slash bin slash bash. Corn shell is ksh. Seashell is csh. And by default, he gets a shell which is the sh, which is the traditional default for any Unix. Okay, so slash bin slash sh. But these are the most common ones that is used extensively. So shell is, it's like a command interpreters. So whatever commands that we are learning, we are using, this is understood by this command interpreter. Okay, and we have seen where we can find the list of all the shells in the system. That is there in the file called slash etc slash shells folder. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of user administration in a Linux system. In this topic, we are going to cover a couple of things. First thing is about the user administration, that is using the password file. So the user's information is stored in the etc password file. We'll look at how these users are organized into different groups. So we'll look at the etc group file. We'll look at the structure of this particular file, and we will look at the information about the passwords, that is the password policies. Okay, then we'll talk about the UID, that is what is a UID, what is a GID. Okay, and we'll talk about couple of things like what is set UID, set GID. Okay, and we'll look at the shadow file, that is the significance of the etc/etc/ shadow file. Okay, and we'll look at the etc/g shadow file as well. Okay, then we will go into the details about can we add a user, how can we remove a user, how can we set the password for a user. Okay, so let's look at these things one by one. So first thing is about the etc password file. So let's see the structure of the password file. Let's go into the system and let's read this file using this command called cat command, and we'll read this structure of the password file. If you read the structure of this file, you can see that this is a colon separated file. That is, there is a colon between one field and another field. Okay, let's look at each of these fields, what is the significance of them and why we need them. So let's copy this because this has almost all the fields listed here. So let's say that I am copying this and let me paste it here. Okay, so this is the information that we got from a password file. Okay, so let me reduce this size. So now here you can see that first information is about this stand for which user it is. So this is the user name in the system. So that is about the first field in the password file. So first is your username, that is the login name using which you log in into the system. The second, we'll come back to the second, the X field. Okay, so this X field actually is the password field. Okay, the X indicates that this password is there in the etc shadow file. Okay, then next thing is about this field. Okay, so let's note down one by one. So first thing that we saw, this is your username. Okay, so this is the username that you have, and let me select this. Okay, so this is the username using which you log into the system. This is the password using which you provide the password, you log in, but this X indicates that this password is there in the shadow file. Then after that you have the user ID and you call it as the user ID. Okay, then you have the next number after that is the group ID. That is how these users are grouped. After that you can see there is a lot of information here. This is a text and this just means this is a description that what this user is. The description can be anything, but it should tell in brief what is this particular user. Okay, then the next thing that we see is the home directory. Okay, so this is the home directory of this user, and once the user logs in, this is the shell that is going that he's going to get. So this is in brief the structure. So couple of thing, and one of the most important thing here in this case is this number UID. This number has to be unique. Okay, so make sure that you give lot of focus to this particular number, and this number governs a uniqueness across the systems. This number governs that what is the unique value. So even if you change the username, this number doesn't change, so this UID doesn't change. So just take note of this particular number. See, take note of the significance of this number. This is extremely important for a password file. So this is your password file that we just saw. Okay, so this is an etc folder, and the name is, we write it passwd, but we call it as a etc password. Okay, so that is a common way of calling this. So that is about the password file. In our next topic, let's look at the shadow file. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is the password command. Using this command, we change the password for the user. And how do we use this command and change a password? We log in as a particular user. Okay, if you see, we have logged in as a user called test1, and this user wants to change his password because it is getting expired in few days. So he just want to make sure that the user doesn't get automatically locked or the password stops working. So he need to change his password. So to change the password, the command is passwd. Okay, so when you execute this command, it will ask for your old password. Just provide your old password, and then it will prompt you for a new password. Okay, so if the word is based on the dictionary, it will prompt you that this password is not good. So re-enter that. Okay, if again prompt, so make sure that your password is good enough. Okay, so it will give you 3 tries. So, and if your password is still incorrect and you cannot make out what password you will use, you can retry to change it. Okay, enter the old password. Okay, enter the new password. Okay, so just take note that this goes by your company's policy for passwords. That is how many characters you should have, how many numbers you should have, how many special characters you should have, and that governs that what password it will accept and what it will not accept. Okay, once the password is changed, you will get this type of message that the password is changed, and now you can start using your new password from here on. Okay, so this is one way to change it. This user himself can do it. Now if suppose root wants to change this, so let's say I am a user logged in with user ID root, and the user complains that he cannot log in. Test1 complains that I cannot log in. So the root can change the password for that user using this command. Okay, passwd and the username. And if I press enter, here take note that it is not asking me for the old password. Okay, so I can change the password for this user. Okay, so this is how the root user can change his password. Okay, So whenever this user logs in, it may prompt him for changing his password before he can move further. So that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this next topic of Linux training on the user maintenance. The topic is etc shadow file. Let's look at the syntax for this file. This file stores the password information in an encrypted format. So let's look at this file first. Okay, so let's pick up one of this field. Let's say I pick up this. Or let's say I pick up this one. Okay, so this is what I want to pick up. And let's paste it here. Okay. So in this case, you can see that this particular shadow field, okay, so this particular shadow file that you are seeing, this is a colon separated file which stores the encrypted password related information. Okay, so the key things to note is that the password is stored here. Okay, so this is the password that is stored, and this password is in encrypted format. So this is your password. Okay, so this password is in from here till here. This is your password in encrypted format. Okay, and this, if you remember, this is coming from your username in the etc password file, and this is the username. Okay, this is same as the field in the etc password file. Okay, so this is your login name, the login name with which you log in. So this field, using this field, you can connect to the password file. Okay, then the next thing is about this particular number. So this number indicates when the password was changed the last time. Okay, so this indicates the password change, and this indicates the next possible password change. Okay, by default this value is, or the recommended or suggested setting for this value is 0. Okay, but this actually means that the number of days that must elapse between password changes. Okay, so in how many days you can change the password, so that is reflected by this particular field. Then next thing is maximum number of days between password changes. Okay, maximum how many days? And the last, if you see this particular field number 7, okay, this shows that, let's say your password need to be reset in, say, after 40 days. So 7 days before, that is after 33 days, it will start prompting you that, okay, change your password now. Okay, then there is, if you see, there are two fields where there is no value. this one and this one. Okay, so this means the grace limit. Okay, and last field is if there is a lock or if this has expired. So this is the syntax, or these are different fields in a shadow file. Okay, the significance of this shadow file is it is storing the password in the encrypted format. So the password is not there in the password file, but it is in the shadow file. Because if you see the permission for password file, anyone can read it. Okay, so let's see the syntax for this. So anyone can read it. And let's see the syntax for shadow file. Okay, the permissions. You can see that only root can read write and only shadow can read it. And for shadow, if you look at the group grep shadow from etc group, so you will see who are the members. So there is no one is there in this group. So except root, no one can edit this file. So this shadow file, this ensures that your password is not here. Okay, so this provides some level of security. So that is about this particular password file. So that's all I wanted to cover in this topic. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of UID. UID stand for user identification. Okay, so let's look at this particular file, the password file. And in the password file, there is an entry for username. There is an entry for user ID. So for human, we require a username, but as far as the system, the file system is concerned, the software is concerned, it will use this. So most of the operations require UID to work with. So that is, so UID actually identifies the user to the system. Okay, as discussed, the UIDs are used mainly by the file systems, the softwares, and the login names are provided for the convenience of users. Okay, so let's look at the password file again. Okay, let's look at the initial few lines using head command. If you look at it, let's look at root as well. Okay, take a look at this entry. This value is 0. Okay, so the user ID is 0 for root. Okay, take a look at some other user IDs like bin. The user ID for bin is 1. If you look at daemon, it is 2. So it's customary to put these fake logins at the beginning of the password file to give them low UIDs and a fake shell. And if you look at the shell for them, this is your bin user which has a shell, daemon users which has a. So take a look at this shell called false. This is one shell which is false. Okay, the false shell, what it does is that it prevents from people to logging in as those users. Okay, so this is about the UID. So why UID? Because this is how the software administration or software management or file system recognizes the users. So they recognize by user ID. But for human purpose, there is a mapping called user name. Okay, so this, you can see that this is your user ID, username, and this is your user ID. It's a numeric number, and this has to be unique in the system. For root, the user ID, the UID is 1. Okay, and let's look at some other. Let's start with this file. Okay, so if you look at some other users, like take the value for nobody. Okay, see the value for root 0. See the value for daemon 2 1, and you can see that for security purpose, these files, these users, they have /bin as /false as the shell, which means nobody can log in with that ID. Okay, that is kind of a security measure to prevent people from logging in. Okay, so that is pretty much I wanted to cover in the topic UID. Thanks for joining and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of user creation. In this topic, we are going to see how to create a user. Okay, so what we are doing here is we are going to create users. Okay, there are multiple ways we can create user. The first one that we are going to see here is using the command called user add. Okay, so using this command, we are going to see how we can add a user. Okay, so adding a user in the system that we are going to see. And along with the user add, once the user is created, we may be interested in modifying the user. So we can say user mod. There could be a requirement that once the user leaves the company, you may be asked to delete the user. So user del. This is a single word. Okay, so that is about the users. But when we create users, there is one thing called groups as well. So we create the groups also. Okay, so because user will be a part of group so that they are organized, so we'll create a groups also. So we can map these users to either an existing group or create a new group for them. So how do we create a new group? We can use the command called group add. Okay, so but in case if we need to modify some values in the group, we can just use the command group mod to modify, and if the groups are no more needed, we can delete the group del. Okay, so let's see these commands plus one more command that is extremely important and is used on day-to-day basis is the password change command. So using this command, we can change or set a password for the user. Okay, so this is one very important command and used almost daily, depending on how frequently you forget your password or how frequently the company policy forces you to change a password. So depending on that, you use this command. Okay, now let's create a user. Okay, so we can use this command called user add command. But with user add, there are few things which we need to take note of. There are numerous options for user add. So we'll use an option called -m. That means we are telling that is generate a home directory under /home by default. Okay, so let's create a user by name, say test1. Okay, and we want to, instead of defining a primary group, we can define a primary group for the user also. So you can say, okay, this is the group. This should be an existing group. And we can specify, if you want, we can specify a password also here if you like. So we can say that, okay, the password for this user is, say, this is the default password for the user, and we can just press enter. Okay, so if the user is already existing, you will get this type of message. Okay, let's create a user by name test2. You can see that the user is created. How do you validate whether the user is there? We can just say su-test2, and if you just type ID, you will see that you have created a user by name test2, which has a primary group of SAP sys, and these are the default groups for the users. So one thing to take note of these defaults, so from where these defaults comes, we can find out that information as well. Say if we type this command called show defaults, it will say that, okay, so under this ID it cannot find this. So let's run with the root ID. Okay, so with this root ID, let's execute the same command, user add show defaults, and here you can see that the default group is this. If you are not specifying the group name, this is the group name that it gets. Okay, so let's create one more user and see how the default group works. Say user add -m. Let's say we create a user test3, and we don't specify other parameters, and let's don't specify the password also. Okay, now you can see the user is created, but we need to change the password for test3. So this is where the root user can change its password, and it can assign whatever password required as per the company policy. Okay, so the password is set. Now let's log in or test whether this user is there, su-test3, and if you just type ID here, you will see that the ID for the previous user that we created. Okay, let's see what was the ID. You can see the UID is 1003. Group, we explicitly defined it. Okay, now in this case, you get the next UID number 10004. GID, we did not define it, but it has picked up from the defaults. Okay, then other groups is added by default from this. So these two groups are added automatically. So this is how we create a user using user add command. Okay, then there is a command called user mod command, using which you can modify a user's parameter. Okay, so let's use this command user mod. If we use this command using any other user, you will see that this command is not found. Okay, but let's run it with the root ID. So we are going to use this command called user mod, and we want to modify the group of this user. Okay, so user mod for which user? Test 3. What we want to do? Modify the group to say SAP sys. Now let's do an su dash test 3, and if you press ID here, you will see that the GID for this user is changed. So this is how we change the GID, okay, using user mod command. So any of the user parameter can be changed from this except the UID. Okay, now let's look at another command called user del command. So user del command is for deleting a particular user. Let's say that this user 3 is no more needed and I need to delete it. So I will use this command called user del and the username, and you can see that this user is deleted. How do we check that? We'll just say su dash test 3. You can see this user doesn't exist. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Okay, now let's look at this particular file called login.devs. So this file is in the etc slash login.devs folder. So let's look at this file. Actually, this file stores a lot of information about some of the default values when the user account is created. Okay, so let's look at this file. Okay, it's login.devs. Okay, so here you can see that the first parameter default.home is set. That means even if you don't specify, the default home will be set for it. So like this, there are a lot of default parameters which get assigned when we create the user. Okay, so here you can see the information about password aging control. So these are the default parameters that you might have seen in a etc shadow file. Okay, then there are some very important parameters, like you can see that things like umask, that is whenever you create a user or a directory, by default it will be set to, you will see that you will mask these fields. Okay, so the resultant permission will be by you masking this particular value. So that is one very important field. We will see what umask is in our subsequent training, but just take note that whenever you create a directory by default, or directory or file, by default it will have a particular permission. So that permission is governed by this value. Okay, so let's look at the other values. Let's say you can see that there are some other commands you can define here as well. So that is about this particular login.devs, and the significance of login.dev is that whenever user gets created, if you want to populate some of the default values, you can define them here. Okay, like if you have seen the shadow file, these values. Okay, so let me show you shadow file one more time. Take note of these values. So they automatically gets picked up from this file. Okay, and if you create a directory, let's say you create a directory called, you are in say this folder. and you create a directory called say test. If you just see the permission for test, take note of the permission. If you create a file here, okay, so just take note of the permission for the file test file. So here you can see that this is the permission. Okay, so in this permission, you can see that this is masked 022. Okay, so that is why this is R. Okay, this is R. So, and this 0, because of that, this is RW. So basically, this is something which is used for during creation of files and folders. Okay, so that's what I wanted to cover in this topic. Thank you. Bye bye. Hi, good morning, everyone. Welcome to this topic of DF command. DF is one of the very popular and a command which almost a system admin uses multiple times in a day. So if you type DF and press enter, it will show you the output of DF command. Okay, in this, let's look at what is the output of this command, what all the different parameters or what all it means. Okay, so here you can see the output of DF command, and you can see that this is the first column that you are seeing here is list of all the file systems which is present. Okay, then you can see that used space, available space, and this shows the percentage used space, how much percentage is in use, and this is about the mount point for this, that is at which location we call it as a mount point as well. Okay, and here you can see that the utilization is extremely important here, that is how much is used. More than that is how much is available, that is percent use is the extremely important field here. So normally what happens is that if a company, they may set an alert if anything is more than say 95%, send an alert, so that send an email alert or a phone alert depending on the criticality of the system. So this field is the extremely important field, that is how much is used, and the mount point is where this particular file system is mounted, that is about the mount point. Okay, so this is the DF command. Then there is some variants of the DF command, so let's look at them. DF minus H means human readable form. Okay, so you can see that this is telling this is the size, the disk is this size. Okay, and this looks more readable, that is this much gig is available. Okay, but at the top it was 1K block size. Okay, then there is another variant for this command is df minus ht, that is in terms of t, that is terabyte, how much is available. So these are the different variants of df command, and it is one of the extremely important command for a system administrator. So that's all pretty much I wanted to cover. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, which is the free command. Okay, this command helps to display the current memory used, both physical and the swap. Okay, if I press enter here, you can see that this is the physical memory which is used, and this is the swap memory which is used. Okay, so this command is used to find out the memory which is available in the system, the swap which is in use in the system. And there is one more variant for this command which you can use it as well, just to see. Okay, let's say free minus s let's say 1. So every 1 second you will see the output. So you can see that whether it is increasing or decreasing the free space. That will help to gauge how your system memory is, whether it is increasing or decreasing or how it is performing. So normally you use this to keep an eye on a system on a periodic basis, just to make sure that it is behaving the way it should be, especially while running a critical program or while performing a critical activity, especially during the month end processing or whenever any key process runs in the system. Okay, so that is pretty much I wanted to cover in this topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of server performance related analysis. And there is a command called top command. This top command is used for identifying resource intensive processes. So use this command to quickly identify which processes are the highest consumers of resources on your server. Okay, so if you just press enter, it will say which servers are using highest number of resources in terms of which are the CPU intensive processes that you have. Okay, so the process ID of the top consuming sessions are listed in the first column. So the first column that you're seeing is the process ID. Okay, so just take note that this is the process ID which is taking maximum CPU resources. Okay, so this helps to identify which are the top system resource processes, the processes which are using the maximum amount of system resources. Okay, so that is about this particular command, the top command. And top command also helps to give you another important information about your memory utilization. How much is used, how much is free. The swap space, is there any swapping taking place? Okay, currently there is no swapping. So this is another key parameter. The CPU load on the system. What is the load on the system? Okay, so these are few of the most important. At the top you can see that the load average is this much. Okay, so this helps to tell the load on the system, the swap in use on the system, and the top processes which are the heavy users of the system processes in the system. Okay, hi, good morning everyone. Let's get started with our next topic, which is on identifying the memory intensive processes. So in this topic, what we are going to see is we are going to use this ps command and look at the options which tell us the memory specific bottleneck. So what we are going to do is we will see the options, that is memory, PID, the user, the terminal, and the arguments. Okay, and let's sort this so that we see only the top ones. So minus n, that is numeric, and minus k. So sort minus k, then 1, and in the reverse order so that we get highest at the top, and just say pipe it to head. Okay, so what this will do is this is going to give me the top processes which is using the memory heavily. So you can see that these are the processes which are using the memory heavily. So this is the memory utilization of these 5 top processes. So this way we can find out which processes in your system is using the memory heavily or which is utilizing it very heavily. Okay, so that is one very important command that you should take note of. That is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is the vmstat. Vmstat is a command which is used to identify the system bottlenecks. So let's look at this particular command. So we will look at this command called vmstat. Okay, we use it for identifying the performance bottlenecks. This actually vmstat stand for virtual memory statistics tool, which is used to quickly identify bottlenecks on your system. Okay, this shows the real-time information about your process, about your memory, about your paging, disk IO, CPU, etc. So let's look at this command in the system and let's look at this output. Okay. Okay, so let's see it on the system, vmstat. Okay, let's look at the details about this. So let's review, let's analyze this, whatever we are seeing there. Okay, couple of things to take note and is of significance is, we will mark that here. Okay, so this is, here you can see that this is talking about the process. Okay, so this is talking about the process here. So let's look at a couple of important things here. You have at the top, you have the process, you have memory, swap, IO, system, and CPU. So it is reporting in real time these things. It is telling the different processes, the memory utilization, okay, the utilization about, so this process is, this is stand for the CPU. Okay, so in this one, if you look at it, there is something called this letter, which is B. Okay, so this letter, if a process is sleeping is consistently greater than 0, then you may not have enough CPU processing power. So just take note that if this value, if B is greater than 0, that means CPU is insufficient. Okay, next thing is about the IO part. Okay, so for IO, if you take note that there is this component called WA, that is waiting time for IO. Okay, so waiting time for IO, if you see this parameter, okay, let me pick up a different pen color. Okay, so this parameter, this WA parameter, if this is greater than 0, that means that the waiting time for IO is high. So waiting time is high means there are storage issues in your system. Okay, your storage subsystem is overloaded. Okay, so that means your storage is overloaded. So if WA is greater than 0 means your storage is overloaded. So storage bottlenecks. Okay, then so we have seen about the CPU bottlenecks, which is the parameter for CPU bottlenecks. So this is for CPU bottlenecks, this parameter. For IO bottlenecks, you have this parameter WA, and then there is this parameter. Look at this SO and SI. This particular parameter, SO and SI. So SO means that memory is swapped out, and this is swapped in. That means swapping is taking place. That means memory bottlenecks. Okay, so if this is greater than 0, that means memory bottlenecks. So we have seen CPU bottlenecks, disk bottlenecks, memory bottlenecks, how to identify them. Okay, so that is the power of this particular tool, the VMstats tool. Okay, then if you look at it, this what we have seen is at a particular point in time. So this is at point in time. But if I want in say interval of say 1 second, and number of interval is say let's say is 100, you can see that every 1 second you will find an entry listing down okay what is wrong with which. So you can see that this is your B number, B, which is your CPU bottlenecks. This is your WA, second last. So this is 0, this is fine, no storage bottlenecks. SO, SI, that is swapping, there is no swapping, so no bottlenecks for memory. So this is how we identify the bottlenecks at different layers. Okay, so that is about the VM stat command. Okay, so that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Hi, good morning everyone. Let's get started with our next topic, which is on CPU bottlenecks. That is, how do we identify CPU bottlenecks and fix them? Okay, so let's look at it. So there is a command called mpstat. So using this command, we can find out the bottlenecks of CPU. Because CPU is one of the main resource to identify the health of the system, the utilization of the system, and the default option of mpstat will show only one line of aggregated statistics for all CPUs on the server. So if you have multiple CPUs, you can see an aggregated value there. So if there are more than one CPU, you will just get one line of it. That is the summation of it. Okay. You can also view CPU snapshot that reports statistics accumulated between intervals. So you can use -p option to report only on processor, and it will display output like this. So let's say you have this -p option. Okay, so if you just write or just click enter, it will say the different things what is possible. So we'll use the option -p, and let's report on CPU number say 0 every 2 seconds, and let's say 20 different reports. So what is happening here is that you can see the CPU zeros statistics. Okay, so this is showing the utilization of CPU 0. Now in this case, if you look at percentage idle, that means for this time it was idle. Okay, so if idle is high, then your CPUs are most likely not overburdened. Okay, but if the percentage IO weight output, okay, this output is a non-zero number, that means you have IO issues in your system. Okay, so if you identify that the CPUs are overloaded, this is the way you can identify it. So this will help to identify the CPU bottlenecks. Okay, there is one more variant for this is, let's say, -p all. Okay, so this will show, here you can see that CPU all, that is 0, 1, 2, 3. Okay, but if you do man mp stat, okay, so you can see the manual page for this, and this will show you the different options which is available. Okay, so this is one very good command to find out the bottlenecks in CPU. So that is about this particular mpstat command and how we use this command to find the bottlenecks in CPU. Okay, so that is pretty much about mpstat. Thanks for joining and have a nice day. Bye-bye. Hi, good morning everyone. Welcome to this topic of IO stat, that is monitoring of IO statistics to determine whether there are any disk storage bottlenecks in your environment. So this command, the command is iostat. Okay, so here you can see that it will tell you about different devices and how many reads and writes is happening for that particular device per second. Okay, so there is one variant of iostat which I wanted to cover here is iostat -xd. Let's say 5. Okay, so the X is, you will get the extended option, and -d, it will give the device as well, which is the device in question. Okay, so this way you can generate the IO statistics every 5 seconds. So you can see that this statistics is generated. So this output will help you to gauge which device is experiencing heavy IOs. That is, in this, look for devices with abnormally high block read or write per second. Okay, so just read which is having higher number of read and write per second, and if any device is near 100% utilization, that is a strong indicator that IO is a bottleneck. And if the bottleneck device are used by the system, then that particular application may get performance issues. So this is one way to identify the performance bottlenecks in with respect to disk IOs in the system. So that is pretty much I wanted to cover in this particular topic. Thank you and have a nice day. Bye-bye. Hi, good morning everyone. Welcome to this topic of CPU. So what happens is that whenever you're working on a system, you may be interested in seeing how many CPUs are there in your system. What is the capacity of the CPU? So to find out that information, there is a utility, or we can say there is a command called this is a file which stores the information about the CPU, which we can see it using cat command. Okay, so you can see that this is shows the list of all the CPUs which is there in this, and for each CPU there will be one entry. Okay, so this has more than 75, 76 CPUs. It's a heavy duty system, but let me run this, pipe it to more, and here you can see that this is your first CPU. Processor ID is 0, vendor is this, CPU family, model name, stepping, and CPU speed, cache size. So this tells about the different CPUs which are present in your system. So this is extremely important because this will let you know how many CPUs are present in your system and they are running with what capacity. So this information actually is useful to find out how many CPUs are running in your system, whether they are powerful enough to handle the database software being installed or any other application that is need to be installed or that is running. And if you have multiple CPUs, then you will see a listing of each CPU, and this helps to determine whether your server meets the required capacity or not. So that is pretty much I wanted to talk about regarding this particular file about CPU information, that is slash proc/CPU info. That's all. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Let's look into another command for measuring or analyzing the performance of the system, which is extremely important command, that is the SAR command. SAR. SAR stands for System Activity Reporter. Okay, so this means System Activity Reporter. So what you can do is you can use -u option to report on CPU statistics. So let's say that this is your command prompt SAR -u, and this will report the previous day's worth of CPU statistics. Okay, the file that is used by SAR is stored in the folder called /var/log/sa folder, and the file name will be SA, and there will be a number for month. Okay, 2-digit day of the month. Okay, so or you can specify something like that, SAR -u, let's say -f, and the file name. This is for the file in December. So let's look at this particular option, this particular command. Let's say if I type SAR, you will see the statistics like this. But if I type SAR -u, okay, so you can see the previous day's worth of CPU statistics. So let's see the another variant that we described is SAR -u -f, and let's say the file name is say, okay, so it is saying that there is no such file or directory. So let's go for this /var/log/sa, and let's type this command. SA20 is for today. Okay, so what we will do is we will run this command as SAR -u -f, and this is the file name SA20. So you will see the statistics captured in this command. Okay, so this is about the sar command. So in this particular command, if you look at this, the percent IO wait, so this will tell that if there are any IO bottlenecks, that is there any wait for IO taking place, and follows that high percentage IO wait time indicates that IO subsystem is a potential bottleneck. Okay, so that is about this particular command, that is the sar command. Okay, so as we have seen how we can identify or how we can use this particular sar command, that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's look at the other topic about displaying the memory which is configured in your system. So this information is also coming from a proc file which is meminfo, and let's read that file. So cat slash proc slash meminfo, and you will find information about memory which is configured in this system. Okay, so here you can see that this is giving information about the total memory. Okay, so this is your total memory which is configured, and this is talking about the different parameters about this is the swap which is configured in the system. Okay, so this will tell you that how much memory is defined in your system. So this will help to find out your physical memory, your virtual or swap memory, and depending on the software you want to install in the box, you can weigh whether your system will be good enough to run that particular application or not. Okay, so that is about this particular file, that is the meminfo file, which provides information about the memory which is configured in your system. There are few more things that I wanted to talk about, but we'll cover that in our next topic about the swap space. That's all for this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of finding out and modifying the open file limits in a Linux system. Okay, so here we can see that under a proc file system, you will have information about the max files. Okay, so let's read this. This will tell that these are the maximum number of files which can be there. Okay, maximum open file limit. But if we want, we can change this using the sysctl command. Okay, so how do we do that? Sysctl -w. Okay, so fs dot file dash max is equal to, let's say, 65536. Okay, so if I read this file again, okay, so you can see this value is changed. And let's say if I want to revert back this value for some reason, okay, I want to keep it this value. This is the value now, and if I read this, this gets updated. So this is how we modify the files related with the open file limits. Okay, so that's all I wanted to cover in this topic. Okay, the reason why we have to do this is because Linux imposes a limit on the overall number of files simultaneously open on the system. So if you want to open multiple files more than this limit which is specified, you have to set this value accordingly. Okay, that's all for this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, in which we'll talk about how to see the kernel parameters and how to make changes to the kernel parameters. Okay, so we will see that there is a command called sysctl command. Okay, so using sysctl, we can see the different kernel parameters. So how do we run this command? And so this command looks something like this: sysctl minus a. Okay, so this command will give you the list of all the kernel parameters, and if we want to make some changes in this parameter, we can just make those changes. That is, we can specify the value of that, and let's say that I want to make these changes, so I will just edit this particular file called sysctl.conf, and I will run this particular command called the sysctl-p. So this will ensure that the changes are reflected. Okay, so sysctl-p. So this is sysctl space minus p. So let's look at this. So this is using vi, we can edit this. Now let's get into the system to see them. So first thing is, where is this stored? Okay, so the first thing that we want to look at, the proc folder where we store this information. Okay, so let's look at this particular proc folder. So cd/proc/sys. Okay, then we can go to the kernel folder, and if you just do like this, you will see the different files which is storing that information. Okay, so what you can do is, let's say I want to see the semaphores. So this provides the information about the semaphores. I want to see the shared memory. This will give me the information about the shared memory. So this is how we can find out the existing information, but the command that is used, instead of going to the file, we can just use this command sysctl-a. So this will list all the parameters. Okay, and we can make changes to these parameters as well. So let's say sysctl-a, and I would like to see just the SHM, that is shared memory parameter. So this will give me the list of all the shared memory parameters. Okay, so I will get the information about all the shared memory parameters. So in case, let's say if I want to modify this, so what I will do is I will run this particular command with the W option to dynamically change the values. So sysctl-w, and I will pick up what I want to change. So let's say that I want to change this value. So this is equal to, okay, now I specify in double quote whatever value I want to give. Okay, so let's say I want to give this value. Okay, so this will change. Take note that there are no space between the two. Okay, so there is no space in between the two. Okay, so that is about how we change the dynamic values, but there are values which will not get changed like this, and we may need to mod we may need to shut down the system for some values, but this is how we can dynamically change it. Just press enter. And there is another way that we can change them is by modifying this file, that is vi/etc/sysctl.conf. Okay, and let's say I want to change this shared memory. So this is where I will come and make a change. So once the change is done, what I will do is I will just run this command sysctl-p. Okay, so this will reread this particular file and the changes will get reflected without the reboot. Okay, so that is pretty much I wanted to talk about these memory parameters, kernel parameters. Thanks for joining and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, which is about the limits in a system. So I'm talking about this command, which is ulimit. And to see all the options, whatever is configured using ulimit is, this is what it is. So ulimit for data segment is unlimited, file size is unlimited, pending signals is this. So you can see that these are the different values for, say, file lock, virtual memory, max number of user processes. Okay, so maximum memory size, number of open files. So here you can see that these are the different limits which is set for a. Okay, so these are important actually. The reason why they are important is because, so whenever you get a logon shell, will impose these maximum limit on any resource that a process can use or a user can use. So each resource has a soft limit setting and a hard limit setting. The soft limit setting specifies that the default resource limit when a user logs onto the system. If the user exceeds the soft limit setting for a resource, an error will be thrown. The user can manually increase the setting of the soft limit setting. Okay, so where this is configured and how you can change these values. So this is configured in a folder called /etc/security, and under that, if you see, there is a file called limits.conf. So limits.conf will have all this information about which user, what is the limit. So by user, whether it is a hard limit or soft limit, and which are the parameters that we are controlling from here. Okay, so whether it is a hard limit or soft limit, core limits the maximum file size, data max data size, fs maximum file size. So this way you can see that each parameter, you can limit which parameter and you can define the value for a particular parameter. So that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is on cron tab. Okay, so we will talk about the cron tab in this. So cron tab actually is a command to manipulate the user's cron tab. Okay, so there are various options in cron tab. The first and most important option and mostly used option is cron tab -L. So L stand for listing. So if there are any cron jobs, it will be listed here. Okay, so it will show you a list of cron jobs which are running in a system. Then there is another option which is cron tab -E. E means it will open an editor for you to edit. That is, it is going to open a VI editor. So take note that this will have the VI syntax. Okay, so we can add an entry here in this file, and This is a purely VI editor. If you press I, it will change the input mode. If you press escape, you will be out of the input mode. And to quit this, you can type :Q0. Okay, so this is a pure VI editor. You can edit whatever you want using cron tab -E. Okay, so let's take another option for cron tab, which is cron tab -R. That is to remove a user's entire cron tab. We will use this option called cron tab -R. Okay, so this option is not so much used, but these are the two heavily used options for cron tab. The first option says that which are the cron jobs. Okay, this option says how you can add an entry. Okay, as you can see that right now I don't have any entry in cron tab. Okay, so there are no lines. That means there is no programs running using cron for this user. Okay, and what is this user? This is a root user. Let's say that if I become some other user, let's say I become a user called EC2 ADM, any other user basically. And if I just type cron tab -L, it will show me the cron programs for that user. Okay, so you will see the programs which is running as cron for a respective user. Okay, so each user will have access to cron tab command by default, and he can run cron tab -L to find out which programs are running using his ID. And if he wants to schedule a program, he can just type cron tab -E and start making an entry of the program which he wants to run using cron. So for now, I'll just don't edit it, but we will cover the syntax of this particular cron in our subsequent topic. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, which is cron tab. Okay, in this topic, let's see the syntax of cron tab, because cron tab is going to be the scheduler, and to know and to read that, to use that, to make an entry in that is going to be very significant for any Linux administrator. So let's see the syntax of that particular file. And as we have seen that the syntax to the command to edit that file is cron tab -E, and that has to be in small letters. Take note that Unix or Linux is case sensitive, and there is a difference between the capital letters and small letters. So if you type this command, okay, it will say command not found. Now, but same thing if you type in small letters, you will see that you will see the listing, and I want to edit this, so I can open a VI editor. Now, this being a VI editor, you can go to the insert mode by pressing I. Now you can start typing the syntax for any job that you want to schedule it. Now let's look at the syntax for it. Okay, so this is going to be the syntax for this. So this file will have one entry for each command or each program that it is going to run, and that line will look like this. So what this means that the first entry is minute. Okay, so this minute value can range from 0 to 59. Okay, and the next entry is hour. Okay, if you want to run something at say 4:05 a.m., so you will just say this entry will be 05, this entry will be 4. Okay, so that is how we need to make an entry there. So let's make an entry. Let's say that I want to run something at 4, and so minute is 5, hour is 4. Next is your day of month, that is on which day of the month. Let's say on 4th of April. Okay, so how we are going to write something at 4th of April? Just tab, and next is day of the month, so this is number 4. Okay, and 4th of April, that means number 4 again. Okay, and next is, so we have seen month field, and after that you can see that this is day of week. So what day of week means is that, do you want to run it on Sunday or Monday or Tuesday? So that is the day of the week. Okay, so that is going to be our next entry. So if we say that any day is fine, we can run it on every day. So we can just say, okay, any day is fine. And what command we want to execute, we just need to type that particular command. Say, let's say this is something that I want to execute. Okay, I want to run this particular program, which is I'm taking a backup every. Okay, so now how you are going to read this? So the way you are going to read this is that the first entry, what is your first entry in this case? So the first entry that you have is your minute field. So this is your hour field. So at 4:05 a.m., that is in morning at 4:05, and next is day of month and month field. So on 4th date, and month is April. So this is day of week, that is doesn't care about day, every day, and this is your command that you want to execute it. Okay, so this is how we make an entry for any program that we want to run using cron. Okay, so now let's look at some examples how we can make it more usable, because this is kind of theoretical entry, that is I want to run something at this time, but there could be chances that I want to run every minute, every day, or every hour I want to run something. Okay, so let's say that I want to run something every minute. I'll just put a star. Okay, if every minute, so for an hour it is going to be star as well, that is every hour means. Okay, so every minute, and just take note that you have to use tab. Okay, so every minute, every hour, every day, every month and every day of week. Which command? Let's say I want to run this ls program slay. Okay, so this is what I want to run. So this star indicates every. So this is your minute field. This is your hour field. This is your day field. Day is numbering from 1 to 31. This is your day of week. Okay, and this is your command. So we have minute, hour, day of month, then month and day of week. Okay, and then command. Okay, so this is your minute. Minute can range from 0 to 59. Hour, it can go from 0 to 23. Day of month, so this can go from day means day 1 means date is say 1st April, so the day is 1. 5th April, day is 5. Month is, for April month will be 4. Okay, day of week. So is it Monday or Tuesday? So based on that, so it is starting from Sunday, Monday, like that the clock starts. That is for day of week. And finally the command that we want to execute it. Okay, so let's say that I want to execute. Let's take some other examples for cron tab because it's very important. You should know this by heart. Okay, you should know exactly what it means because as a Linux administrator, there will be numerous times you will be required or you will be asked to set up a schedule job for running a particular program. Okay, so let's say that, let's go back to our program. Let's say this is one entry that I have, and let's say that I want to execute something say at 4:05 and say 6:05. So I can just write at 4:05, 6:05. Okay, or let's say that if I want to write, say I want to run something at 4 a.m. and 4 p.m. So p.m. will be 12 plus 4, 16. So this will run it on 4 a.m. and 4 p.m. That is 4:05 a.m. and 16:05. So this is going to be 4:05 p.m. and 4:05 a.m. Okay, on 4th of April. Okay, so this is how we can use two different dates. That is, I want to run something at this time. Okay, let's say that if I want to run something, say, instead of only on 4th, I want to run, say, these days, 4, 5, 6. So basically, we use a comma to separate them. Okay, so we can say that this program is going to run on 4th, 5th, 6th, 7th. So this is how if we want to run it multiple times. Okay, so that is about the comma operator. Okay, now let's look at some other things like, let's say that I want to run something from say 5 p.m. to say 11 p.m. So what I am going to do here is that, so I want to run something at 5 p.m. So 5 is going to be 12 plus 5, 17. and dash 11 p.m. So 11 and 12, 23. So 11 to 20, 17 to 23. So this way we can define the range, that is from this time to this time. So from this hour, 17 hours to 23rd hour, every hour you are running it from 17 to 23. So we have seen star. This is star means every minute, every hour, every day. Okay. So that is about star. We have seen comma, that is on 4th, then on 5th, then on 6th, or whatever day you specify. Okay, then dash, that means we are specifying a range, that is you run this program from this range to this particular range. Okay, so that is about the range. Okay, now let's look at, so this is about some of the examples that I wanted to cover, especially dash, comma, star mark. Okay, so that is about the cron tab entries. Now there are few more things that I wanted you to. So after this you just need to say colon. So escape. So just type escape and colon. This being a VI editor, all VI commands will work. Colon WQ. Okay, so this will save this particular entry, and now if you do cron tab minus L, you will see two entries are there. Okay, and let's say that you want to edit it. How you are going to edit it again? So cron tab minus L, and for listing cron tab minus A to edit. And let's say that someone says that okay, don't run this program is causing problems, so just comment it out. So this program will not run anymore. Okay, unless you again enable it. So once that is done, so just colon WQ, so that change is done. And if you run cron tab minus L, it will show that okay, this is the program that will run on periodic basis. There is one more thing that I wanted to tell you guys is about something called restrictions, how you can set up the restrictions. So there is something called cron dot allow and cron dot deny files. Okay, so in using cron dot allow and cron dot deny, what happens, you can see that these are the two files. So if you have a file in cron dot deny, and if a user entry is here, that means that user cannot run a program using cron. Okay, so just take note that if you want to prevent someone from running a program using cron on a periodic basis, just make this entry. Okay, and if suppose you have cron.allow file, in this it is not there, so anyone can run or schedule a cron job so long as his entry is not there. But let's say that there is a file called cron.allow. So what will happen is that only those users will be able to run the program whose name is there in cron.allow. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is on cron. So in this topic we will see how the jobs can be scheduled using cron, what all the cron jobs are, and we will see how we can review the logs whether the jobs using cron is working properly or not. Okay, so this cron actually it's a kind of scheduler at OS level, and we can schedule periodic jobs in this. Let's say any maintenance job that we require, like any log archival, log removal, rotation of log files, zipping of big files, deletion of some temporary files. So all these are the activities which need to be performed on a system on a periodic basis. So for a periodic basis, we need a scheduler. Okay, we need a scheduler which can run on a periodic basis. So in Linux, that scheduler is called cron. Okay, and there are two types of cron jobs. One is the system jobs which are running as root user, and second is the user jobs. Okay, if you want to see more details about cron, you can just type man cron, and the first thing that it is going to tell you is that this is a daemon. Okay, that means this is a background process which runs at OS level on an ongoing basis. Okay, so let's see that particular batch job. Okay, and we will see how cron takes care of scheduling the programs. So let's get started with it. So first thing is, let me search for this process called cron. Okay, here you can see that there is a process by name cron here. Okay, this process, this ensures that this is a daemon. Okay, and if you run the top command, you can find this daemon running in the system always. Okay, for some reason or for whatever reason this is not started, there are some files in the etc folder which will ensure that the jobs which are scheduled to run periodically, that is either monthly or hourly or weekly and daily, those jobs can continue to run the way they are scheduled to run. Okay, so here you can see that in this folder you can see, if I just type ls-lrt star cron star, and you can see that there are no weekly jobs scheduled in the system, there are no monthly jobs scheduled, there are no hourly jobs scheduled, but there are daily job schedules. And you can see that for each job there is a file. So this is a daily job which is running, and this daily job, how many daily jobs are there? You can see that this is the list of the daily jobs, and they will be in this folder cron.daily. And so it's taking a backup. Okay, cleaning the temporary file, rotating the log file. Okay, so these are some of the programs. These are system defined programs to make sure that system remains clean, but you can add to them so that you, whatever applications you are running in the system, whatever security or audit work that you are doing, you can make sure that you are able to manage them, you are able to rotate them, you are able to zip them or archive them, because they are log file. It is storing some information, and if it is not needed after a period, certain amount of time, you need to make sure that you either archive them, you either delete them depending on your company's policy. Okay, so that is on the different type of cron jobs. Okay, so you can see that the Linux cron process automatically executes tasks at various times based on the content of the configuration files stored in the user specific directories. Okay, which directories? So it looks for the files in the waspool cron folder. Okay, or in the system wide configuration file called etc cron tab. Okay, so two files to take note. One file is, you can see under var spool cron. Okay, so whatever users are running the cron jobs, you will see an entry for that particular user here. Okay, and so there will be an entry for anything running at the user level. Then there is something called etc cron tab, which is kind of system level file. Okay, so anything we are running at the system level, we will have an entry here in this file. Okay, so you can see that this is what is running on the system level cron tab, and these are the user level cron tabs. So there are two types of crons. One is defined at the system level. So if the ID is root, you can see that at this ID, whatever you see is called the system level cron. Okay, next thing is the user level cron. So if you log in with any user ID, let's say there is this ID in the system, and anything, if you just type cron tab -L, you will see that there are no jobs, but whatever you define in cron of this, you will see an entry taking place in var spool cron. Okay, so these files, that is the files under this folder, the files under etc cron tab, so this file runs processes in the directory, these directories, that is hourly folder, weekly folder that we just saw, and so cron.weekly, so all these are in etc folder. Okay, so how can we check that? So let's say that I'll just exit out of this. Okay, and let's go to etc folder again, and if I do ls-ld cron star, you can see that list of the cron files. You have a daily job, hourly jobs, monthly jobs, weekly jobs. Okay, then there is something called cron.deny. Okay, if you just open this file, you can see that these are the users who is not allowed to run the jobs as cron. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of at command, that is AT. So this is going to be the topic for today, and in this topic we'll see what is this at command and how and what for do we use it. So this add command is something like, let's say I want to do this today. I want to go to office and have a cup of tea. So this being a one-time activity, I don't have to schedule it using cron, and I can schedule it using add command, this type of activities. So add command is used to schedule programs need to be which need to run just once a while. Okay, so for those commands we just use at, and that's it. So let's see how that works. Let's look at some syntax. So the way it looks is, the way we execute this is, we just type at, and let's say it's 1400. Okay, take note that commands will be executing using /bin/sh. Okay, now let's say that I want to run this command, let's say ls command, and next thing is I will say how to exit out of it, control D. So what will happen is that this particular command will be executed. Okay, which command? ls command at this time. Okay, so this time it will be executed, but take note that the requirement for an add command is this: there should be a file called atd file. Okay, we should have this file running. That is, if you just do ps-ef or ps-aux and just grep for this process called atd, this process is not running, so this command will not be executed. That's why this warning message is coming. So you just need to make sure that this process is up and running before you can execute an add command. Okay, now let's check the ps-ef or aux again for this process atd. You can see that this process is running now, and it is running as at user. And let's try to run this same command again. So at 1400, what I want to do is I want to run this command, and to get out of this, just type control D. So you can see that this job is scheduled and this will run at this time. Okay, so now if I want to see later, let's say that I come and check which are the jobs which is scheduled. You can see that this is a list of jobs which are scheduled to run at 2. Okay, and we can use, there is a command called at rm, using which we can remove the jobs from running. Okay, so we can use this command to run the jobs from running, or we can remove it from this list. So that is about the add command. So we have seen that add command is used to schedule a job for one time. That is, those jobs which we don't want to run periodically, we can schedule it for running at later time using add command. Let's say that I want to trigger a backup of one particular file system at 9 p.m. I don't have to log in at 9 p.m. I can just schedule it using add command, which will make sure that the backup is triggered at 9 p.m. Okay, so this is how we run the add command, and this is the purpose for which we run the add command. So that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this training topic of background jobs in a Linux system. So we can run the background jobs in a Linux system, and we will show you how we can run the program in background, how we can move the existing program which is in the foreground into background. Okay, so let's get started with it. There are a couple of things that we will we may need to take note of. First thing is there is something called ampersand, this symbol. So this, the moment you put this symbol in a command, it will take that particular command into background. So this is one way of sending a command in background. Okay, so let's say that I want to run this command called sar1 say 100, and I'll just put it in ampersand. So that means that this is running in background now, and this is the process ID of that particular background job. Okay, so this is the way we can run the program in background. Take note of this symbol one more time. This is the way to send or run any program in background. Okay, now if we want to bring the job which is in background in foreground is fg. Okay, this is the fg is the command. So this is the command fg. Just press enter and you can see that this program is running in foreground. And to send this program again in background, we can just type control z. Okay, you can see it is stopped. But if you type bg, this program will go in background. Okay, so this is running in background now. So this is the way we can run a program in foreground or run a program in background. So that is pretty much I wanted to cover in this particular topic. Just to recap, to run a program in background, you need this symbol called ampersand. Okay, this is the symbol. And to send the running program in, let's say if it is running in foreground, to send it in background, you just press Ctrl Z and type BG. Okay. So this is running in foreground now. If I want to send it to background, you can see Ctrl Z, it is stopped. And if you type BG, it will go into foreground. Okay. So this is the way we can run a program in foreground or run a program in background or send a running program which is running on your screen on background. So that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, which is on the Linux file systems. Okay, so in this topic we are going to see the different file system types in Linux and how do we see them on the system. So there is a file called etcfs tab. So all the file system which need to be mounted at the system boot time is stored in this file. And there is one more file which is extremely important, which is etc mn tab. So this stores at real time which systems are currently mounted. Okay, so this stores currently mounted systems, and this stores all the systems, all the file systems which should be mounted at boot time automatically. So when the system boots, all the file systems which are listed here should get automatically mounted. Okay, and we will see how to use this command, the mount command, the unmount command. Okay, so we will see how we can use these commands. Okay, so let's get into the file system first. Okay, so file system in Linux, actually there are different types of file systems. So first thing is, let's open the file first. Okay, so this is the file that I was referring to, etcfs tab file. So this file, if you look at this syntax, you will find the information about what are the types of the file system. Okay, so let me copy this particular information here. Okay, and let's paste it here in this folder. Okay, now let's review this information that we have just pasted here. Okay, so the first file system is the swap file system, so let's take it out. Second is the root file system, which is slash, and then this is slash proc file system. Okay, so here in this particular, let's review these file systems. So let me remove this for now for time being, and let's look at the file system types. Okay, so here you can see that there is this particular type is the file system type. This is a GPFS file system here in this case. Okay, so you can see that the file systems which are, okay, this is your sys debug file system, USBFS file system. Okay, so this is a list of the file system which is there in this system. So GPFS file system, it's a specific file system from IBM for Linux. Okay, so IBM can provide high availability using this. Apart from that, there are a couple of other file system types that is listed. Okay, but the key file system type, because this being an advanced system, it has a couple of different file system types. But let's look at some of the main file system types, especially the ext2, ext3 file systems. Okay, then there is a file system for CD-ROM. Okay, so there is a ext2 file system, ext3 file system for CD-ROM, JFS file system, XFS file system, NTFS file system. So these are some of the key file system types. Okay, so let's look at this command. Okay, so let's look at all the file system types which is present in Linux system. So this is a mount of, this is the mount command. We are seeing the manual page for this, and if you scroll down, you will find an information with the -t option, that is -t type of the file system. And you can see there are so many types of file system which is supported by Linux, SUSE Linux. There is, you can see different type of file systems, ext2, ext3, ext4, XFS file system, NFS file system, VFAT. Okay, so this is a bunch of different file systems which are supported by Linux. And let's see in our system what all the different file systems are there which is mounted. So this is the list of file systems which is mounted. Okay, you can see these are the different file system types which is mounted in this. And if you do df-ht, you can see this type. You have slash as ext3 file system. Then this slash dev, the devices is, this is the file system. Then you have shm mounted as tempfs file system. You have this folder mounted as gpfs file system, and this mounted as gpfs file system. So you can see the different commands that we used here for file systems. Okay, and these commands will help you to find out what all the different file systems available in a Linux system. Okay, so just to recap what we have discussed so far, file systems provide a base for your files to be stored on the physical disk. A good analogy for a disk is like holding the buildings that houses your local library, while the file system is its infrastructure, the shelves that hold the books and the card catalog that enable you to find a particular title. So Linux supports many different type of file systems, each of which has its own internal structure over access methods. To access a specific type of file system, Linux uses kernel software known as device drivers that understand the internal structure of a specific file system. Okay, Linux provides a general system that is easily extended. Linux provides the virtual file system layer as well. Okay, so the key things for you guys to take note from the day-to-day perspective is, first thing is the mount command. Okay, if you just type mount, it will show which are the file systems which are mounted. Okay, there is another command called df command. This is extremely important and this should be used on almost on daily basis, this command, which will tell which are the file systems that are present, which are mounted, and how much file system is in use or not. So that is about the df command. Then we have seen the different files. The key files is etc fstab. Okay, listing down the different file system types that you have. Okay, then you have the file systems which are mounted currently. So this is an overview about the file systems in a Linux system. Okay, that's all I wanted to cover in this topic. Thank you and have a nice day. Bye-bye. Hi, good morning everyone. Let's get started with the next topic, which is on the mount command. Okay, this particular command. This is one of the very important command for system admins, and this command is used to mount the file systems. Okay, if a particular file system is not mounted, you can mount it from this command. Let's see how we can mount a particular file system. Okay, so let's mount particular file system which is there in fstab. Okay, so let's say that I want to mount this file system. Okay, this file system gets mounted. How can I check that? And just type. You can see that this file system is mounted. It is mounted as type GFS. But why as GFS? Because this information is there in this file called fstab. Okay, this fstab has this entry which says this is a GFS file system, and so it gets mounted here in this particular manner. So this is how we can mount a file system. Now let's see how we can unmount a particular file system. So this is your file system which is there. This is the file system that you have, and you would like to unmount this file system. So how will you do that? Just type umount, okay, and name of the file system. Okay, you get the prompt that means this was successful, and to validate you can just type df-ht. You can see that this file system is not there. Okay, so, and in case if you want to mount it back, you can just say mount this file system. Okay, and this will be mounted back. So this is how we mount and unmount a particular file systems. Okay, so far we have seen the mounting and unmounting of the file systems which are there in fs tab file. So what will happen is that the type of file system, the parameters for mounting is all picked up from this file, that is the fs tab file. You can see that we had mounted or unmounted this file system. The type of file systems comes here. The parameters for mounting comes from here, that is it should be mounted in read write mode, m time, a time, dev equal to this. So these are the parameters, these are the attributes of the file system which should be provided, and it is picked up from here. Okay, and this is the device which gets mounted. So at this device you mount this particular file system, and once you cd into this file system, you will see all the files which is present here in this file system. Okay, so this is how you perform mounting and unmounting activity in a Linux system. That's all I wanted to cover. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, which is on LSOF. This stands for list of open files. So why this? What is the significance of this? Many a times what happens if the system is hanging, there are files which are not released. When you try to bring down a process, it is not releasing all the files. To find out which files are still in use, we use this command called lsof and give the process name, the file system name, whatever file system we are trying to unmount is not getting unmounted, the process not getting killed. So we use this command called lsof command. Let's look at the lsof syntax. Okay, so this is extremely powerful command, and let's see this syntax lsof, and we can give the file system name as well, but if you just give lsos, it will give you the list of all the open files. Okay, now if you give lsof with some process name, some file name, so let's see what will happen. If I just say this particular file system, which are the open files for this. Okay, there is no open file for this. Let's look at some process. Okay, so here we can see these are the different process IDs. List of open file. Let's pick up any process ID. Okay, so you can see that this is giving how to use this particular command for a process ID. Okay, so to look at the syntax, the help for lsof, just type lsof -h, and here you can see the different use of lsof, and the most common or the most popular use is for the process IDs for the file systems. Okay, for the file systems, for the process IDs. Okay, so let's see the file systems process IDs in use for, say, process 24. You can see this. Okay, if I just type psef ps minus ef. And let's look at one process ID, say this process. Okay, so we will see which are the open files for this. You can see these are the list of all open files for that particular process. Okay, so this helps to identify and kill or remove those open files if the process is already stopped. Okay, so that is one of the significance of this. So first significance is about list of the open file for a file system. Second is list of the open file for a process. Okay, so just take note of these two things. That is extremely important. Okay, so the first thing is the file system. Second is for the process. So whenever a file system is hanging, you are not able to unmount the file systems. You take the help of LSOF. You're trying to stop a service is not getting stopped. So you can find out using LSOF which process is still in use. So which are the open file for that particular process ID. So this is an extremely powerful and helpful command for a system administrator, especially for the advanced level of admins. Okay, so that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye-bye. Hi, good morning everyone. Let's get started with our next topic, which is on etc fs tab file. That is, how do we mount a file system automatically? So there is a file called /etc/fstab file, which is used to store information about file systems that have been permanently defined for the system. This includes the swap partition, the root partition, as well as other partitions that are created during installation. Apart from that, any other file system which we want to mount at the boot time, at the time when the system starts, is kept in the etc fstab file. Now let's look at the structure for this file. Okay, so whatever system needs to be mounted, there should be an entry for it in this file. So this file will be read for any file system. Now let's look at, let's take an example. Let's say this is the file system. Okay, now let's analyze this. Okay, so here you can see that this is the file system that we have, which we want to mount at the boot time. Okay, so if you look at this particular thing that we have, so this first entry that we have here, okay, so this means that this is the file system that I want to mount. Okay, then there is another column which is called the mount point. That it at which location I want to mount. That is the directory you want to mount the file system under. Okay, then after that, the third column that you have, that specifies the type of the file system. Okay, you can specify it using -t option, this one. And after that, you can see this is listing down different options for mounting. Okay, so this is a comma separated options. You can have a number of options here. Okay, so this is about the different options for mounting, and then there is something called this is this particular column. This means the dump priority, specified dump priority. And 0 means do not back up this file system. Then there is one last entry that you see, the last column. So this column is the order in which the file system should be checked. If this is a journal file system, this is not needed as a file system check is run when the file system is mounted by the file system driver. 0 means do not perform this check. Okay, so 0 entry means that do not perform the file system check. So this is what the different options are which are there in the file. What is the name of the file? etc fstab file. So for each file system there is one entry. So this entry means one file system. So depending on how many file systems you want to mount, you will have so many entries. Okay, so that is pretty much I wanted to cover in this topic. Thank you for joining and have a nice day. Bye bye. Hi, good morning everyone. Let's continue with the mount command. So in a mount command, you just type mount. It will show you the different file systems which are mounted. Okay, you can see df-ht to see which file systems are there. Okay, so now let's try to mount a file system. Okay, so let's try to mount a file system and mount -t, the file system type, which is I have a GPFS file system that I want to mount, and -o equal to, that is the options that I would like to mount this file system as. I want to mount it as a read write, m time, a time, dev equal to /sapmnt log no auto. So these are the different parameters that we use. So just take note of some of the parameters that may be required depending on how you want to mount the file system, what is the type of file system. And this is the device which we have created, sapmnt log, and I want to mount this as, say, this. Okay, so here in this you want to mount a file system. This is the file system that you want to mount. Okay, the type of the file system is GPFS, and the options that you want to mount as is, these are the options. Okay, so we'll see the different options, but take note of this option, which is I want to mount as a read write. That is, I should be able to write into this file system. Okay, at this device, and this is the mount point. Okay, if I press enter, and you will see that this file system is mounted successfully. So this is how we can mount a particular file system. Okay, now let's look at a command called stat command. Okay, so stat command, and I want to see the stat for this. Okay, so this will tell me this particular information, which is extremely important. That is when this file system was accessed last, when it was modified, when it was changed, which is the device type, the inode number, the number of links it has. Okay, so all this information is seen here about this particular file. So for any file we can do it this way, find out these attributes of the files. Okay, so that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of file systems and Linux. In this topic, we will see the different file system types in Linux. Especially, we will start with the hierarchical file systems in Linux. Okay, so hierarchical file systems. What is an hierarchical file systems? So there is a hierarchy of file systems that is which specifies which directories, what file should be located at first level, what file should be located at second level, and so on. So hierarchical file system. So this is the file system hierarchy standard, and you will find that there is something located at first level, and you will find few of the folders located at second level. So let's look at them in detail about which are the ones at first level, which are the ones at second level. Okay, so there is the root file system at the first level, /user/var at the second level. Okay, so let's look at this particular hierarchy of Linux file system structure. Okay, so if you look at this structure, you will find information like, okay, so at the top, at the first level, you have slash, and under slash, okay, so under slash, you will find file structure like bin, sbin, lib, etc. Okay, user, opt, root. Okay, then you have home, boot file system. Then there is something called media is there. Then mnt is there. Okay, so boot file system, under boot you will find things like grub. Okay, in media you will find your cd-rom, floppy, etc., zip, and in user you will find things like user bin. Okay, sbin, you have user lib, user include, local, etc. And at the top level, this is your top level, this is your second level. Okay, then you have covered up to media. Then you have some of the important ones that is called /var, /tmp. Okay, then you have the dev, then you have sys and proc. So these are the list of what is available, and let's look at in detail about these file system types. So beneath the root directory, you can see there are series of subdirectories, and specification for these directories are to be named are contained in the file system hierarchy standard. Now let's look at, so root directory, this is your root directory. You can see that this is your root directory. Okay, so this is your root folder. Okay, this refers to the highest level of the file system tree. This root partition is mounted first at system boot, and all programs that are run at system startup must be in this partition. Okay, so there are some of the main directories which should be there at the boot level. So we can see that these are the directories at the boot level. So things like, you can say, so for the boot level you have /bin, which is holding all the binary files. You have /dev, which has all the devices, /etc, which has the configuration files, /lib, which has the libraries, and /sbin, which has the system binaries. Okay, these files, these directories must be in the root partition. Okay, so this is what is there at the root partition. So this /bin that you are seeing here, this has all the binaries which is required to manage the Linux system, including you have the /bin /bash, that is the shell. You have /bin /cat command is there. You have /bin /dd for copy files byte-wise. Gzip is there in this folder under bin to compress the file. You have mount command is here. You have rm command. You have the vi command. So all these are there in this particular folder. Now let's look at the boot folder. Okay, so we have seen /bin. Now let's look at the boot folder. Boot folder is also extremely important that you can see, because this contains the static bootloader like grub, Grand Unified Bootloader. It contains the kernel and the init rd file identified with the links vm lineage and init rd. So this /boot is one of the very important file systems as well. Okay, so /boot. So this file system, as we have seen, that this file system contains your bootloader grub. Okay, that is Grand Unified Bootloader. It contains the kernel and the init rd files. Okay, these files, they are linking back to vm lineage and init rd. So that is about the boot file system. Then you can see there is /dev file system. This contains the special files that are used to represent the various hardware devices installed in the system, the hard disk, etc. Okay, then after that you can see that, so this is your devices, all devices. Then etc, its configuration files used by the systems are stored here. You can edit these files with a text editor to customize how Linux behaves. So all the configuration files. Okay, then there are library files, contains the library code used by the programs of /bin /spin. Your kernel modules are also stored in the lib module directory of /lib. Okay, then you have other folders. Some of the significant ones are the proc folder is there. So this folder is different from other directories in this list. This doesn't actually exist in the file system. And within slash proc are a number of different subdirectories. Notice that each of these subdirectories is identified with a number, not a name. These numbers correspond to the process ID of the associate process running in the system. So for different processes, you will find a process, a number you will find. So different numbers will be there in this particular slash folder, slash proc folder. So this is not like a normal directories which is there. Okay. So next is the sbin folder. So sbin is extremely important for managing and administering. So the files like your fdisk, your fsck, your ifconfig for configuring the network, your init files, your mkfs files, your shutdown and halt commands. So all are there in this sbin folder. Okay, then there is one important folder is the temp folder, where all the temporary files which are created by your system, which are required by your system, is kept. Okay, so this is about the different files and folders. Okay, there are few more, but I won't go into the details of them. Just to name them, they are something like this slash mnt is there. Okay, this is not visible. So slash mnt is there. Normally we used to mount the media here. Temporarily mount points, temporary file systems are mounted at this. You have the slash media is here. So all the CD-ROM, floppy disk, etc. is mounted in this. There is something called slash var file system. So variety of variable data, including your system log files, are here. Okay. So then there is one important is the slash user file system. So slash user file system, if you note, this is contains the application files. In fact, most of the application files used on your system are saved in the slash user folder. Okay, so that is pretty much about the hierarchical file system of Linux. Okay, so there are few other important file types in the device folder. We will not cover it here, but there are some very important file types like slash dev slash null, the null device, your hard disk, your CD-ROM device. So we will be covering that in our subsequent trainings. Thanks for joining and have a nice day. Bye-bye. Hi, good morning everyone. Welcome to this topic of the command called fuser command. Okay, in this topic we will see what is this fuser command and why we need this command. So the command name is fuser. This is also a very powerful command like lsof, which will give the list of the open files for the file system. Let's say if you cannot unmount a file system, you will find which processes, which are the open files using this. Then for the process as well, if you want to kill a particular process and you want to bring down a particular process, it is hanging, it is not able to stop it. There are some process still using this, so we will use this command. So there are different variations of this command. Just to see these files, if you can see fuser minus m and the file system name. Okay, then if you want to kill it, you can just run with minus mk option. So k is just take note, it will kill it, so just be aware of it. You can use minus v option as well to get it in the verbose mode. Okay, let's say that, let's take an example here. Say if I do this, and if I want to unmount this file system, the unmount will fail. Okay, the reason why it will fail is because it will say device is busy, because you are already in that folder. But let's get f user to find out that information. Okay, f user minus m, and you can write it like this, and you can use the minus v option as well. Okay, see the difference, which gives more verbal information. So this root user, there is a, you are logged in as this, and if you want to kill this, okay, let's say I want to kill this whatever is being used, you can see that the process is killed. So this is how we kill forcefully this using fuser command. So that's all. That's what I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, which is CPIO command. Okay, in this topic we are going to see the command called CPIO, and we'll see the different options of how to use CPIO command. So let's look at the first option, which is about creation of archive using CPIO command. So let's say that we are at the command prompt, and here in this case, let's say all the files that is there, I'll just list those files, and I will use the command called CPIO with the option called -OV. Okay, O stand for out or create. Okay, so this is for it will out or it will create something, and this V stand for verbal, that is verbose. And here we specify the file name, and the file name is normally in the form of CPIO extension, so we can say sample.cpio. Okay, so this is how we can do this. There is another variant for this, is we can use the find command, that is find from wherever we are dot. Okay, so the option that we are going to use here is that find dot minus depth. Okay, so it will bring all the files and folders in the recursive format underneath it, and this command remains the same here, CPIO -OV, and here we can say it is sample say 1.cpio. So this is another way of creation of archive using CPIO. Okay, so let's see it in the system. Okay, so let's say that we are in this folder. Okay, and there are a couple of files here, and I want to create an archive using CPIO command for this. So how do I use the CPIO command? I will just use this option called ls, and you will use a pipe symbol here, then CPIO -O is for out or creation, and V is for verbose, and redirect this output to, let's say, sample1 or sample.cpio. Okay, it can be anything basically. Just make sure that whatever naming convention you specify, you just stick to it. Okay, here you can see that this is created an archive. Okay, now let's use the same. Let's create a similar archive using the find command. So find from dot minus depth. Okay, so this will archive all the files and folders underneath. And pipe cpio minus ov, and we can store the output in say sample1 dot cpio. Okay, just take note that it has brought in all the files and folders beneath it in the recursive format. And if you just see this one, it's just the folders there. Okay, so this is how we can archive the files using cpio command. In the next step, we will see how we can extract these commands. Okay, so basically how we can unbundle these commands. We need to remove the bundle out of these commands. Okay, so let's see how that works. Okay, so for extraction, what we will do is we are going to use this command. The way we use the extraction is we use this command cpio, and with the parameters as minus I is for, here we are giving the out parameter, so this will extract the file. So we will use for extracting the files. Okay, and we can have different options, like you can have say dvm, and we specify input parameter from the archive that we created, that is /temp /sample dot cpio. Okay, so let's try to see this in the system. Okay, here just take note that what we are doing here is that we are extracting the archive. So this is one way of extraction of archive. Another way, another variant for this is we can use it in this format also, as we saw. So let's say that I will use a cat command. Okay, so let's say cat, this file name, and pipe this to cpio minus idvm. Take note that this I is important because this is for extraction. Okay, so let's see it in the system how it works. Okay, so we are here in this folder, and let's go to this folder called say /sapmnt slash. This is some folder that I have created. Okay, let's say that there is nothing here. Okay, so we will create a folder called sample folder. So let's get into this sample folder and take the note that there is nothing is here. Now let's use this cpio command. So cpio minus idvm, and we will try to extract this particular. Okay, so this is the one that we want to extract. So this command is going to take an input from this file. Okay, so this is how we are going to use this. So if I just press enter, you can see the output here. Okay, so this is the output for this command. Now let's go back and try to create another folder, let's say this folder, and we will test out the other option, that is, let's say I want to cat this file. Okay, and I want to take the pass this output to CPIO command. Okay, so and you can see the same way things are created here. So this is the way we can extract a CPIO. Okay, so what we have seen is we have seen how to use the CPIO command to create an archive and to extract an archive. So that is what I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of archiving and compressing the files and folders. Basically, whoever works in a Linux or Unix based operating systems, this is one of the major activity that is performed, that is moving a file from one location to another location, and it becomes pretty tedious to move the files the way we do it in Windows platform, like we drag and drop. But in this case, instead of dragging and dropping, what we do is we compress the files and folders in a tarball. Tarball is like it's a tar file where we can make a bundle of multiple files. Okay, so once we have the bundle of multiple files in one file, and we can move that particular bundle across the system, across the folder, and we can take a backup as well for that particular tar file. Okay, so let's look at this. So let's look at some of the most popular commands in that domain. Okay, one of the most popular command that is there for this is the tar command. Okay, so previously it was called the tape archive because mainly it was used for taking backups to a tape. Okay, then there is a command called CPIO. Okay, there is commands like zip, which you have it in Windows as well. Okay, there is a command like compress. Okay, so similar to zip, there is a command called zip. There is a command to uncompress. Okay, so these are some of the commands that we will be covering in this particular topic, and we not only create the archives, we can read the files from an archive, and we can extract or extract the files from an archives. So the command remains the same, but the options to do that keeps changing. So let's see the different commands and their options on how to create an archives. Okay, so let's see them. So first command that we are going to see is the tar command, and to create an archive using a tar command, if you see tar, you use this options called CVF. C stand for creation of an archive. Okay, V is stand for actually verbose, that means you will see the output on the screen. Okay, so that you will know that something is going on. Okay, then F is the file. So which is the file that you want to create? Let's say that we want to create a tar file, say sampletar.com. Okay, so its name is, let's say this is the name for it, which is says sample.tar. Okay, and this star we want to create out of, let's say, all the files in that folder. So we'll just give star. For now, let's see this example first. So what we are doing here is we are going to create a tar file. Okay, so that's why C option is there, and this tar will be in this file called sample.tar. Okay, so let's do that. So let's say we are in this folder and we want to take a, we are creating a bundle. Okay, and this bundle will be stored in this file, let's say /tmp slash. So we need to specify a file name here. Okay, so let's say if I specify sample.tar and I want to tar of everything in this folder. Okay, so you can see that the tar for all these files is taken, but take note that this tar has only one folder. It is not taking these hidden files there. Okay. Okay, so let's try to create a tar again here. So tar cvf and the file name for the tar, which is, let's say, /temp slash sample1.tar, and we want the tar for everything on this folder. Okay, so you can see that the moment you specify okay what you want to archive, it will archive everything there. So just take note of the options here. This is the tar command. C is to create an archive. So if we just check whether the archive is created, okay, so you can see that this is a archive which is created, the tar ball which is created, the tar file which is created. Okay, so we have created this archive from all the files in this folder. Okay, now let's go to this folder. Okay, let's say I am going here in this folder. Okay, so here there is one file is there and I would like to extract. Okay, what I want to do, I want to extract that tar archive. So I will specify this command xvf, that is x to extract the archive, and this is the archive that I want to extract. And if I just press enter here, it will tell that okay, what it is telling, the permission is denied for this ID. Okay, so how you are going to address this is we will give the permissions to create the files in this folder for the user. By type ID, it will tell okay this user. Okay, so if I type ls-ld dot, here it says that only root can create it, only root user and root group. Okay, so no one else can create the files here. So let me assign the privilege for others to change it. So what I'm going to do is I need to exit from here. Okay, give the change mode here to, let's say, 777, because we need others to create the files here in this folder. Or this is one way of doing it. Other way is, let's say that if I change the ownership for this folder to EC1 ADM. Okay, so this is another way of granting access. So if I just change it, you will see that okay, the permission for this is changed now. Okay, so let's log in with that user, EC1 ADM user, and let's go to this folder. Okay, if I type ls minus ld dot, you will see that ec1 has the permission. So let's try to extract this file now. Okay, so let's try to extract it. You can see that using this star xvf options, the command is star command and the options that we are using is xvf. So X here stand for extracting the archive. Which is the archive? This is the archive. Okay, so we are extracting this archive, and if I type ll here, you can see that a home folder is created, and if I go under home folder, type ll, you can see both the files are there. Okay, so both the directories are there, and if I get into one of the directory, you can see all the files are present in the system. So this is how we archive from a tar file. Okay, let's say that I don't want to archive it, I don't want to extract it, okay, but I want to read what is there in the archive file. So to read, we use the command called tar tvf. T stand for listing, so it's table, it's like listing the tar file that we have it here. So if I just read the content, you can see that it is showing me, okay, what all files are archived in this. You can see that, okay, these are the different files and folders which will get created once I extract this file. So just to recap, what we have learned so far in this is there is a command to create an archive. Okay, then we can use this command tar xvf and the archive name. So here X is your extract. Okay, so that is for extracting the archive. Then there is another option that we have seen is tar tvf. So what this tvf stand for? T stand for listing, so it will just list the content of the tar file. So that is pretty much I wanted to cover in this topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is the creation of archive using zip command. Okay, so let's see how we use the zip command. So zip command is actually the command that we can use to create an archive. And let's say that I'll create an archive for say test folder. So zip minus r, and let's give some name to it, sample. Let me create in temp folder. Okay, and which folder I want to zip is the test folder. Okay, here you can see that I have created a zip file using test folder. So now let's try to create it using itg folder. Okay, so using itg folder. So you can see that how I have created it using itg folder. So this is how we create a zip file or zip bundle using the zip command. And now let's say that you need to unzip these files, because on the other system these files are there, but you are supposed or you are asked to unzip these files. So how the unzip utility works is that, let's say that I have created this zip file in temp folder, and I am going to unzip in one of the folder. Let's say in this folder I am going to unzip. Okay, so I will use the unzip command, unzip, and give the file name here. So let's say I will unzip this file. Okay, here you can see that how it will create the files and the folders underneath it. So this is how we use the unzip utility to uncompress or extract the files from an archive of zip format. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of log files. The system log files contain information about kernel, about application, about services which are running on the systems. And these files will be extremely useful for any kind of tracing, any kind of troubleshooting, any kind of debugging at the system level. So most of these log files that we talk about is present in the folder called /var/log. So if you just do ll here, you can see the different log files which is present here. Okay, so here you can see the different log files which is available in the system. So let's look at some of them. Some of the key ones is, first thing is about the boot.log file, which stores system boot messages. Then there is cron file. Okay, so you can see if the cron is enabled in the system, all the cron related information will be stored here. So the cron jobs we can enable the cron logging into this folder. Then you have the files called related with the mail, that is mail.error, info, warnings. So these are the files related with mails. Then you have WTMP file, which is extremely important, which keeps track of logging information. Okay, you have yum.log, zipper.log, depending on what you are using. Okay, then this is one extremely important file, var log messages, and there is a rotation in place, so you can see the different variant for it. Okay, so that is about the different log files. Logging is the only way you can find out what your system and processes are doing. And Linux, like any other Unix operating systems, takes logging very seriously, and regardless of whether you can administer or you are an administrator or a home user, you will have to deal with system logs at some point of time. And as discussed, most of these logs are present in the var log messages, var log folder, and each will have its own separate log files. Okay, so we have seen which files are present in the var log folder. And now let's look at where do you configure that information. That is logging with syslog. Okay, so that is about the syslog information. So syslog is one of the extremely important concept, and what this syslog does is that you define what you want to log. So there is a configuration file for syslog, which is etc/syslog.log, syslog.conf. Okay, so let's go to this folder, ls syslog. Okay, so here you can see that you have this file. Okay, this is sysctl.conf. Then you have syslog-ng. Okay, if we cat this file. Okay, so you can find information about what is being logged, with what severity it is being logged. Okay, so let's okay, so here you can see that this is sysconfig slash syslog. Additional logging is happening here, but most of the logging is defined here. That is how the various activities will get logged, about the errors, about the crons, okay, about the firewall logs, var messages. Okay, so this is what is getting logged here. Okay, cron is disabled, so there is no cron file here. Okay, then we have network manager, var log network manager here. Okay, so basically you can configure your logging in this particular file. Okay, so syslog-ng.conf, this is the file where you are configuring that information. Okay, so that is about the logging log configuration. Okay, now so that is about syslog-ng. There is syslog.conf is also there, but we can use whichever we want. Okay, so we have this one, but there is no syslog.conf here. So that is, these are the different ways you can configure your logging in the Linux system. So that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Welcome to this topic of log rotation. So using this log rotate, you can manage your log files. SUSE Linux include log rotate scripts for most active logging processes, and these can be found in this folder, which is /etc/logrotate.d. And if you do ll for this folder, you will see that these are the services for which log rotation is in place. Okay, so the main configuration file for log rotate is here. Okay, so this is the file for log rotate configuration. Here you specify weekly log rotation, keep for backup, create new log file after rotating. Okay, suffix, text format, how do you compress? Okay, so basically this is where you can define how the log rotation will be performed. The parameters for the log rotations are defined here. Okay, so that is pretty much I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is the hostname command. Hostname command is very important and is very helpful command. It's a very simple command, but the benefit of these commands are numerous. So this is the command hostname. So as you can make out that this will give you the host name of the system. Okay, so this will provide you the host name of the system, but this will, let's say you have tons of system that you can work on or you work on. This command will help you to find out which system you are on. Okay, and another thing this command will let you do is you can change your host name. Let's say tomorrow if you decide that the current host name, say ABC, is not good enough, I want to change it to XYZ. So I will just type hostname XYZ. So the new host name will be XYZ. So this is how we change the host name in the system. Okay, that's all pretty much I wanted to cover. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is on system hardware and operating system information. So how do you find out the operating system and the hardware related information? So there is one very extremely powerful utility, which is uname command, and uname minus a will give all the information about the system, the operating system. So if you look at this command, if you try to analyze this command, you will find information about which is the kernel. Okay, so this is using this particular kernel. Okay, what is the name of the system, the version of the kernel. Okay, the kernel releases, this is the kernel release, and then you will find the kernel build information, when it was built, name of the hardware. Okay, then about the type of processor and the hardware platform. Okay, and the operating system. So this is all the information you will find in this command. So let's look at all this information. So let me copy it here. Okay, so let's look at this information that is there. So if you look at this information, so this information is basically, this is your kernel name. Okay, so you can see that this is your, this name that you are seeing here, that is, okay, so you can see this is the name that, which is there, which is your kernel name. Okay, so this is your kernel name, and okay, then this you are seeing here next to the kernel name, this is the host name. Okay, following host name, you will find information about the kernel release. So this is your kernel release. Okay, then after kernel release is the kernel build. So this is about the kernel build, and following kernel build is the name of the hardware. So this is the hardware, this is your processor type. After that, it's a hardware platform, and following that is the operating system. So this is all the information that you will find in the uname minus e command. Okay, but if you are interested in seeing the different options which is available in the uname, you can do that like this: uname minus help. So this will give you the information about the different options which is available in uname command. So we have seen this option, which is uname minus a, that is all. We can see uname minus s, Okay, so this is about the kernel name, which we saw here is Linux. Then the node name, after that is kernel release. So if I want to see kernel release, I will just type this kernel version, which is this. Then machine type is x86. Processor is same thing. Hardware platform is again the same. And if I look at the operating system, this is GNU Linux. So this is all the information about the system. We get it from here. Okay, so there is another file which is also important, which you may be interested in seeing, is there is a file by name /proc/version. Okay, this provides the similar information about the OS and its build, the GCC version, what is the GCC compiler it has. Okay, so that is the information which we can see at the /proc file system on the version file. Okay, so that is about the uname command. That's all I wanted to cover in this topic. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is monitoring the network's traffic using the netstat command. Okay, so let's see this particular netstat command. Using this command we monitor the network traffic. Okay, so that we can identify if there are any network bottlenecks and we can see the network statistics. So there are different variants for this command, but let's look at this particular variant, which is with option say this. Okay, if you look at this command, you can see that this is showing the information about the process ID, the process name, and the other information, which is the source and the destination. Okay, so what information it is showing is, let me run this with the more command, pipe it to more. Okay, so here you can see that the receive queue, send queue, local address, foreign address, connection state, the process ID, the program. Okay, so if the send queue byte, that is this one. Okay, so if the send queue bytes not acknowledged by remote host column has an unusually high value for a process, this may indicate an overloaded network. Okay, the useful aspect about the previous output is that you can determine the operating system process ID associated with the network connection. So if you suspect the connection in question is having some issue, you can use the technique to find out what is the issue. Okay, so basically this particular, using this command, that is netstat -ptc. Okay, so using this command we can find out which is the process which is causing the very high network traffic, and if suppose this value is too high, okay, that means that this is overloaded. Okay, so this is how we identify the problems in the network, but there are different variants for this. Let's look at some of them. So this is netstat -i, but this command has some different variants which may not be so useful, but one of them is netstat -i, that is what is the traffic which is coming at the interface. So this traffic, how much, so these are the different interfaces, how much traffic is coming and flowing through the interface can be seen from here. Then there is this command called netstat -r to see the routing table if there is any issues with the routing table. Okay, so that is pretty much I wanted to cover in this topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning, everyone. Let's get started with the next topic, which is on the network commands. And in this topic, we will look at some of the other commands. Okay, so the commands that we are going to look at is, so far we have seen the ifconfig command, the ping command. Okay, and let's see the other commands here. So there is a command called trace route command. Okay, so this command, it takes one input, which is your trace route, the host name or the IP address. So let's say I want to trace to, say, trace route www.hpe.com. So I want to trace this particular URL. So trace route means that for reaching to this URL, so this is your source and this is your destination, which is www.hpe.com. Now from here to this place, this journey may not be straightforward. You may have to go through the multiple routers, multiple routes to reach here. Okay, so this command will tell you that if you are going from tracing the route from the source to destination, you have to have these many ports. You have to cross these many hops. Okay, so your network packet will be hopping from here to here to here to here. So this is how we will reach this particular this place. Okay, so the next command that we are going to look at is going to be your netstat command. Netstat command is extremely powerful because this command, the way this command operates is netstat. There are multiple options it may take. Let's look at this option -r, which means that this is going to print the routing table. Okay, so routing table for this system means that if I want to go from, say, this place to this place, which is the first step I am going to take, which is going to be the next step, and if I am wants to go from here to here, how I am going to go. So we define the path here, that is routing table here, how the packet will be routed. Okay, so that is about the netstat command. There are other variants for this command, which is netstat -i. This will give you the interface statistics -r. Okay, so and netstat -a. So these are the different options which is available with netstat command. Okay, now let's look at some command called nslookup command. So if you type nslookup and the host that you want to look up, let's say I want to find out the IP address for this website. So how I am going to find out IP address is, and I will type nslookup, the URL. Okay, this is the FQDN, fully qualified domain name. So if I just type this, it will give me the IP address 19.23.17.14. So this is the IP address that I am going to get. So this is how we find out for a particular name Okay, what is going to be the IP address? Okay, then there is one extremely powerful command which is called the route command. Okay, so the route command is extremely powerful command, and let's look at it briefly. Not go into the details of that particular command. Okay, so let's look at that particular command. So the route command, what that command does is that is used to show and manipulate the IP routing table. Okay, so let's say that I want to add a particular route. How can I add a route? I want to delete a route. How do I delete a route? I want to add a default gateway. How I am going to do that? So by default, route will print the routing table. Okay, but if I want to add a particular route in the routing table, I'll just type a route add. Okay, which network I want to add? Let's say that I want to add 192.168.1.0. Okay, let's say this network, and for that the gateway is 192.168.1.1. Okay, so this is how I am going to add a route. But if I want to delete this route, I will just write this command route delete, same thing whatever we wrote here. And there is another extremely important part of this command, which is the default route. That is, if we have not provided any information which is the path your network packet will get routed to. So how do we add it? Default route is route add default. Okay, and we need to specify the name of that default. Okay, so this is how we add the default routes. So that is pretty much I wanted to cover. Thank you and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with our next topic, which is X INetD. So X INetD, if you know the way the traditional daemons work, so let's draw down how the traditional daemons work. So what happens is that, let's take an example of, let's say, the traditional daemon for, let's say, FTP. Okay, so this is your, let's say this is your FTP server. Okay, so there will be a daemon which will running FTPD. So that particular daemon will listen for any request on a particular port, and that port for FTPD is 20. So that is a traditional way any server daemon processes a request. But in case of INetD, okay, so for INetD it is a little bit different. So this is your X INetD. Okay, so this we call it as a super server. The reason we call it as a super server because the XINetD daemon is the extended internet services daemons, and the purpose of this is to control the starting of various network services which are not started at boot time. And why we don't start them at boot time? Reason is that they remain dormant, and when some request come, then only it becomes active. Okay, so these network services daemons could be, let's say it could be your FTP It could be say TFTP, or it could be uh, TF. So different daemons, there could be many other different daemons. Okay, it could be, let's say, VSFTPD. So different type of daemons which listens for the different requests. So these are not started at boot time. Okay, so they are started when X init D receives the request. So the request comes to X init D, and this super server listens on multiple ports. So it will be listening on ports like say 20, it could be listening on port say 63, it could be listening on request say whatever we map it for XFTPD. So let's say this is the port number. So this daemon listens for all these ports, and any request when this and any request which come is handled by this. So when the session is closed, the super server shuts down this particular daemon. This allows for more efficient use of system resources such as memory for infrequently used services. And the drawback for this is that it takes a little bit longer for the request service to respond to requests. Okay, so that is about this X init D, which we call it as a super server. Okay, so this X init D, what is happening here is that any request is coming to port 20, port 63, port this, or any XYZ services which is managed through X init D. This will receive it. So that request will be serviced by this. It will receive the request for that port, and it will start the service at this port. And once the work is done, it will close down this particular process. Okay, so when it receives the request, once it is done, it will close down this. So the memory is not held up basically, and this memory is used for any other activity. So it's like an optimal utilization of these different daemons, and they are triggered or they are started when the request is received. Okay, so now let's look at in the system how it all looks like. Okay, so let's see this. This is our one of the SUSE Linux system, and in this system, let's look for this process called say okay, so this is one process that we checked. Let's look for this daemon X init D. Okay, so let's go to this folder etc, and in this folder let's look at this configuration, this file X init star. Okay, take note that there are two files. One is this is the configuration file, and there is a directory which stores all these services. So let's look at this file first. So if you do cat for this file, you can see that this directory, so all the files which are included in this directory is addressed or taken care or managed by this particular daemon. Okay, and if we go to this directory, let's look at this is the directory, and if we look at all the files here, let's say one of the file which is, let's say it's a VNC. Okay, so this will start this service. Okay, and this service will be started at this particular port. So you can see that which service, what port, and which process to start, all this is listed here in these files. Same thing goes for any other file as well. Okay, so you can see that, let's see these servers. Okay, so these servers, you can see that this is going to start at this port. If we take any other service, let's say rsync. So when the request comes for this, it will start at this port. Okay, it's a stream, it comes in stream format, and this is the process, this is the daemon that will be started. So this is the way how xinetd acts like a super server. So, and it listens on all these ports whatever is listed here. Okay, so that is pretty much I wanted to cover in this particular topic of xinetd. So we have seen how a traditional server works, that is, it is alive all the time till the system is running, and it will wait for the request. But in case of xinetd, as we have seen that this xinetd, this is running like a super server, all the requests for all these services. So here what services we have seen? We have seen services like time, vnc, servers, rsync. So all these services are addressed, or for all these services xinetd receives the request, and on receiving the request it will start the respective daemon, and these daemons will process this request, and once the work is done they will close that particular daemon, they will shut down that daemon. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining me and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic, which is on the different networking component in Linux. So to start with, the first thing that I wanted to share with you guys is about the ifconfig command. Ifconfig is one of the powerful command. Okay, so this command is used to initialize an interface, assign IP address to the interface, enable or disable an interface, and you can view the IP address and hardware address. Okay, so let's look at this particular command first. Okay. Okay, so the command is ifconfig. So this will show you the different things. To start with, first thing that you are going to see is the list of the interfaces. Okay, so which are the interfaces you are seeing here? You can see on the left side, these are all the interfaces. Okay, so these are all the interfaces that is available on the system. So key things will be ETH0, ETH1. Okay, these are the Ethernet interfaces. So this is how first thing is you see which interfaces, and there is another variant for this command ifconfig -e, which will show everything on this. So let's take an example for a particular interface, say ETH0. Okay, so here you can see the information about this particular interface. Okay, so here you can see that how many interfaces which we have, and which are the interfaces which have been assigned the IP addresses. Okay, so take note between these two. So these are the two interfaces which have IP addresses. This interface doesn't has IP address, so let's copy these three, let's say. Okay, and let me paste them here for now. Let's paste them here. Okay, so here you can see that in this particular command, okay, so in this command, if you look at it properly, let's mark them with this. So this is one interface, pond one. Okay, and this interface, if you look at carefully, this interface has this IP address. So here, this is what is the IP address. So this is your interface. This is your IP address. Okay, and take note that this one is here, which is your hardware or MAC address. Okay, so these are some of the very important thing in this. Same thing goes for the other interface bond 2, which has this is the IP address, this is your broadcast address, this is the subnet mask. Okay, so this is your subnet mask. Okay, and this is your IP address. This is your broadcast address. And this one here is your hardware or MAC address. And this one here is the interface. Okay, so next thing that I want to show you guys is about the activities that you can perform on these interfaces. So the first activity is about these interfaces is how to bring them up and down. So if let's say that you have this interface if config, let's say this is the interface. Okay, so this is your main interface. You can bring the interface up or bring the interface down so that you can bring down the network on that network card on this available and make them disable also using this command. Okay, then let's look at one of the next thing is about you have seen the enabling disabling. Okay, MTU size. Okay, if we go back, okay, so on going back, we will look at this command called, okay, so let's come here and you can see the MTU is, this is the value of MTU 1506. Then you have this value and you can see that by interface what is the value you are having here. Okay, so this is the one 1500 and up means the interface is up. Okay, then this is, where is that up interface? Okay, so this is, here you are telling that this interface is up. Okay, so this is where you are telling that this interface is up and available. Okay, so about the availability of this interface. Then about the MTU, we have seen that this is the MTU value here. Okay. So another thing is that you can set the interface in promiscuous mode also, so that they receive packets belonging to only particular NIC card. So if you put interface in promiscuous mode, it will receive all the packets. So it is very useful to capture packets and analyze later. Okay, that is about the promiscuous mode. Then let's look at one very important command, which is called the ping command. Okay, ping is used to find out whether the system or the network is alive, whether the device is working or not. Okay, so for that purpose we use the ping command. Okay, so the ping output looks something like this. Let's say if I do ping localhost, okay, you can see that it is sending a packet, okay, 64 byte bit packet from localhost, which is this IP address. So this helps to identify whether a device is functioning or not. Okay, there are different variants for ping command, but take note of this particular ping command. Okay, so that is about some of the utilities for managing your network. Thanks for joining and have a nice day. Bye bye. Hi, good morning everyone. Let's get started with the next topic about the shared memory. So to see the shared memory which is allocated in the system, we use the command called ipcs-a -m for shared memory. So this will talk about just the shared memory for different segments. Okay, this is the shared memory ID, who is the owner for that shared memory, what is the permission, and the shared memory which is allocated. Okay, so that is about the shared memory, but as we have seen that this parameter is configured in sysctl.conf file in etc folder. So anything related with shared memory for semaphores, okay, they are configured in etc sysctl.conf file, but we can see what is allocated here. Okay, how do we modify them? So to modify these values, as we know, they are there in this folder. So let's go to this folder first. So if we go to this proc folder, let's say proc sys and kernel folder, and if you just do ls here, you will find information about shared SHM, shared memory, semaphores. Okay, so all the shared memory related stuff, semaphore related stuff can be configured using by modifying these files. This shows that what is this value, and we can modify them by modifying sysctl.conf and let's say SHM. So this is about the shared memory which need to be modified. So shared memory, semaphore. Okay, so this is how we modify this, and once the change is done, just type sysctl-p. Okay, so that's how we manage the shared memory, the number of semaphores in a system. Okay, then there is this command that we have seen, ipcs-a. We have seen if we just type ipcs, it will give you about the message queues, the semaphores, and the shared memory. Okay, this is also pretty important command because it will tell you, especially for database kind of scenario, which is extremely important, whether your system has enough shared memory, enough semaphores, enough message queues. So that is extremely important. Okay, then let's look at the help for this particular command ipcs. Let's say -h is for help. So you will see if you use -m option, you will see shared memory. If you use -q option, you will see messages. You use -s option is semaphore, and everything is this option. So this is how we use this particular command called ipcs command. Okay, and there is one very important something about removing in memory structures. So how do we remove that is, once you find out the semaphore ID, once you find out the ID, and then you can just remove that IPCS minus RM, and then minus M and the message, whatever that number is there. Okay, so using that you can kill that. So let's see that. So what we are seeing, what I want to show you guys is IPCS minus SM, that is shared memory and semaphores. And let's identify something. Let's say this is the one that, okay, so this is something I want to kill. So this is the semaphore this is the semaphore ID which is there. So what I can do is I can just type IPCS minus S, and the semaphore ID in this particular case is, so it will be IPCRM because I want to remove it. So minus S and the semaphore ID. So this way what will happen is that this semaphore will be removed. And if we again run this command minus SM, you will find that that semaphore is gone. So this is how we remove the semaphores if something is stuck, something is not working. We use the command IPCRM for that. Okay, so that is pretty much I wanted to cover in this particular topic. Thank you for joining and have a nice day. Bye-bye. Hi, good morning everyone. Welcome to the final conclusions section of SUSE Linux Administration Training Volume 1. Okay, in this training, as you have seen that we have gone through the different concepts required for a Unix administrator, and we have tried to cover them through practical demonstrations, through the real-time example showing you how and you can perform a particular activity. Okay, this training gives you in-depth concepts which can be observed even by a newbie to take up a career in Linux administrator. And let's get into the next steps. So the first thing is try to complete volume 2 and volume 3 of Linux administration, and after that, or along with completion of this training, you can register for the free Amazon account and try to get a Linux system where you can practice the entire volumes, that is volume 1, 2 and 3. And once you practice everything, you will be a master of this particular technology and you can prepare for certification and get a job in Linux administration as well. So that is pretty much. Thank you and good luck.